Continuing with gaseous state, which is a part of our states of matter. Before we move on, as we always do, we'll have a revision of what we have done till now. So when we actually do gaseous states of matter, we know that we have three different states of matter: gaseous, liquid, and solid state. Out of which, what you are going to do presently is only the gaseous as well as a little bit of the liquid state. What we saw initially for the gaseous state was what primarily dominates your gaseous state is that your thermal energy here is much, much greater than the forces of attraction. Then we had talked about an ideal gas law equation, and you have to know that the ideal gas law equation is what? PV is equal to nRT. And where did we derive this from? Our three different laws which are followed absolutely by the ideal, all the ideal gases. What we have here is the initial one that we did was Boyle's law. What was there in Boyle's law? That you have your temperature constant. So at constant temperature, we see that the pressure is directly proportional to 1 by V. Okay. And then for the Charles law, we had constant pressure. For Charles law, we had constant pressure. And now if you know the ideal gas equation, you can easily see if pressure is constant, then volume is directly proportional to temperature. And then we had Gay-Lussac's law. In Gay-Lussac's law, what we basically have is that the volume is constant. And if your volume is constant, then in that case, pressure is directly proportional to temperature. And remember that when we are saying that volume is directly proportional to temperature in case of Charles law and pressure is directly proportional to temperature in case of Gay-Lussac's law, remember that these two temperatures are the absolute temperatures which are in the Kelvin scale, and you know the conversion from Kelvin to degree Celsius. Then after that we moved on with the Avogadro's law. Avogadro's law states that at constant pressure, temperature and pressure and temperature, you have your volume to be directly proportional to the amount. And you know that what are the number of particles in 1 mole? That is 6.022 into 10 to the power 23. Basically, the Avogadro's law is V1 by N1 is equal to V2 by N2. And what we had seen was at STP, standard temperature and pressure conditions, pressure is 1 atmosphere and temperature is 273.15 Kelvin. Then at these two conditions, what we have is 1 mole of your substance or the 1 mole of gas will occupy 22.4 liters of 4 liters as the volume. Then after the ideal gas law equation, I think we had moved on with the Dalton's law of Yes, here what we had seen was like, we know that there is a difference between real gases and ideal gases. What are real gases? Ideal gases are those which will follow all these laws under all conditions of pressure and temperature. But when we are talking about real gases are the ones which will not follow these laws at all, right? They are the ones which will behave ideally at low pressures and high temperatures. This is a very important question. At low pressures and high temperature, your real gases have more chances of behaving ideally. And that we had seen using a factor which is known as a compressibility factor also. What was this compressibility factor? We had checked up a compressibility factor Z, which is nothing but equal to, it is ratio of the Vm of, say, no, Vm of real. It is the ratio of the volume of the real gas to the molar volume of the ideal gas, which we know that volume of an ideal gas is nothing but it is RT upon P for 1 mole. Molar volume will be RT upon P, and when we substitute this here, what we get is PVm by RT, where this Vm is for the real gas and P upon RT. So what we have was this compressibility factor here. What we saw from here was that if your Z is equal to 1, then that means if my Z is equal to 1, that means my PV upon RT is equal to 1. That means it is following the ideal gas law. So that implies that this is nothing but the case of an ideal gas. When Z is equal to 1, what we see is that this is the case of an ideal gas. So that means if my compressibility factor is equal to 1, then my gas is ideal. Otherwise, plus or minus, that means it is real. And you just have to remember that it will be, when it is greater than 1, then it is a positive deviation. And when it is less than 1, then it is a negative deviation. And last time we had seen that hydrogen and helium always have a positive deviation which is greater than 1, right? Then after discussing this, we had discussed the Dalton's law of partial pressures. And when we had discussed this, this was a simple law which was concerned with the partial pressure of a gas. And we had stated that what is partial pressure? That say if you have a mixture of gases in a particular container, right? Then whatever will be the pressure of one of the components of that mixture, say one gas, in the same volume considered if it is standing alone. It is the pressure exerted by a single component of a gas when it is standing in a component, in the same volume considered alone. Clear? So that was the partial pressure, and Dalton's law of partial pressure holds good only for those gases which do not interact. It holds good. Say what does it state? It states that the total pressure is equal to the sum of the partial pressures of each of the components of the gaseous mixture. So say if you have A, B, C, D and so on gases, then you sum up the partial pressures of all these gases, and that will be nothing but that will give you the total pressure. Right? That will give you the total pressure. Now here when we get the total pressure, we have to remember all these gases A, B, C, etc. are non-interacting in nature. This is what you have to primarily remember for the Dalton's law of partial pressure. All these gases have to be non-interacting. Then from here itself, we had seen that we can also work out the pressure of any dry gas. How can you work out the pressure of any dry gas? Say that is nothing but equal to the pressure of the wet gas or the atmosphere, because your air is completely filled with moisture. So it will be the pressure of the atmosphere minus, it will be the aqueous tension, minus aqueous tension. And what was this aqueous tension? This was nothing but the pressure that was exerted by water vapor. It was the pressure that was exerted by the water vapor. And then thereafter, what we had seen another expression for calculating the partial pressure of a gas. The partial pressure of any gas, of a gas, is equal to the mole fraction of that gas into the total pressure, right? So if I want, say, the partial pressure of component A, then in that case it will be the mole fraction of A into the total pressure. Now just to remind you, what is your mole fraction? Your mole fraction is equal to, mole fraction of A in particular will be equal to the number of moles of A upon total number of moles. So that will be equal to number of moles of A upon, say if you have 3 components, so it will be Na plus Nb plus Nc if you have 3 components, or it is Na upon N total. And here you also have to remember that the total of all the mole fractions will be equal to 1. It will be equal to 1. Thereafter, we had seen the Graham's law of diffusion. After this, we had moved on with the Graham's law of diffusion. And in Graham's law of diffusion, what we had seen, diffusion normally occurs from a region of higher concentration to a region of lower concentration. And what we had seen here was that the rates, if we compare the rates of the diffusion of 2 gases, then that is inversely proportional to the square root of their densities. Now, because it was inversely proportional to the square root of the densities, I can also compare it to vapor densities. Sometimes you have data given for vapor densities also. Now, for the vapor densities, what we can see here is, for the vapor densities, what we basically have is, remember that what is vapor density? It is nothing but it is equal to the mass of, say, x moles of gas upon mass of the equal amount of hydrogen. So mass of, say, equal, that will be x only, x moles of H2. Alright. So if I talk about 1 mole, then that means I am saying that my vapor density will be equal to the molar mass. For 1 mole, it will be the molar mass. So it will be equal to molar mass of gas, whatever gaseous component you have, upon molar mass of H2. What is that? 2. So what we can put it here is that molar mass of a gas can be equal to vapor density into 2. So this is also something that you have to remember. Your vapor density, of course, will vary according to the density only. So here if I am writing that the rate 1 is to rate 2 is directly proportional to the square root, sorry, inversely proportional to the square root of densities, then here this can also be treated as the vapor density 2 upon vapor density 1, and that can also be upon M2 by M1, which was equal to V1 by V2 into T2 by T1. All this we have discussed in detail before. So I'm just not repeating it. It's just a recapitulation of what we have done till now. And also equal to, all right, this is what we have done in the first class. So for all those of you, many of you who had missed this class before, can just concentrate here. What we started up with gaseous state, and you know that a gaseous state will be a gaseous state only when the molecules are far apart from each other, and that is possible only when we have the thermal energy to be much, much greater than the forces of attraction. Next, what is the most important thing in this chapter is nothing but your ideal gas law equation, where you have pressure into volume to be equal to number of moles into the universal gas constant R into T. All right, and from here, now you can remember the laws. This has been derived by using all these laws. But now you can remember all this because based on this, say Boyle's law, when temperature is constant, you know PV is a constant because NR is constant, T is constant. So PV is equal to a constant. For Charles' law, we have pressure constant. So V upon T will be a constant because NR is anyways a constant. And in all these, we are keeping the amount also fixed. Amount means we are keeping N constant. R as such is a constant. So in Charles' law, if volume is a if pressure is a constant, volume will be directly proportional to T, or V by T will be a constant. Then we have the Gay-Lussac's law. In Gay-Lussac's law of constant volumes, so in case of constant volume, we will clearly have pressure to be directly proportional to temperature. And in Avogadro's law, where we talk about constant pressure and temperature, for the rest of the three laws, we have one term constant along with fixed amount of gas. So again, there are two variables which are constant. Like here, it was temperature and N. Here, it was volume and N. Here, here it was pressure and N. Here, volume and N. And here you have pressure and temperature. So that you get to know that volume is directly proportional to the amount of gas. Then real gases can be made ideal at low pressures and high temperatures. All these laws are followed in a very low range of pressure. This is also something that you have to remember because there are graphs associated with all of them. The graph associated with Boyle's law is generally termed as an isotherm. Whatever curve you get there, because therm means temperature, iso means constant. In case of Charles' law, it is called an isobar because bar is a pressure unit and you have iso, a constant pressure. Gay-Lussac's law is isochore. Right? After that, we moved on to study the deviations from the ideal behavior. How can you measure out the deviation from the ideal behavior? By checking up a term which is known as the compressibility factor. What is this compressibility factor? It is the ratio of the molar volume of real gas to the molar volume of an ideal gas. Ideal gas, you know anyways, PV is equal to nRT. So V will be equal to RT by P. So what we get is PVM by RT. Now if Z is equal to 1, that is true for the ideal gas. If Z is greater than 1, then it is a positive deviation. If it is negative, then it is a less than 1, then it is a negative deviation. Okay, then we have Dalton's law of partial pressure, where we understand that partial pressure is nothing but the pressure of the gas when it is present in a certain amount of volume, as good, which is as good as the volume of the total mixture and the pressure that it is exerting all alone, all by itself. The total pressure can be summed up by the individual partial pressures of each of the gas when you have say the gases to be non-reacting. The gases should not be reacting with one another. Then what we have is, we can also find out the partial pressure of the gas, of a dry gas, by taking the partial pressure of the atmosphere minus aqueous tension. Now what is this aqueous tension? This is the pressure of the water vapor, say in saturated condition. So whatever water vapor pressure is there, you subtract that from the atmosphere, and what you get is only the pressure of the dry gas. Then you have partial pressure of the gas can also be written as mole fraction into the total pressure. All right, and then you can find out the partial pressure using this. You get very many questions from Graham's law of diffusion, which is nothing but the ratio of the, or you can say that the rate of diffusion of a gas is directly proportional to, say, the volumes. Because what will be the rate? Rate is speed. What is speed? Distance upon time. And if I have to talk about distance, distance traveled will be as good as the volume. जितना वॉल्यूम है उतना ही तो डिफ्यूज करेगा. So it will be V1 by T1 upon V2 by T2. And from here, what we get is, this is nothing but also equal to under root of D2 by D1, which clearly states that rate is inversely proportional to the square root of densities, and it is also inversely proportional to square root of the molar masses, but directly proportional to the square root of the mean square speed. This is the square of the mean square speed, right? Thereafter, what we moved on with was the kinetic theory of gases. After understanding the basic terminologies or the laws of the gaseous state, what we basically started up with was the kinetic theory of gases, which had some 7 postulates. And when we did that, in case of kinetic theory of gases, I am just repeating because many of you were absent in the previous classes. In kinetic theory of gases, what we basically have is that there were certain, first of all, I explained the meaning of theory. Till now we were talking about laws. Laws are something, जैसे मैंने कोई एक्सपेरिमेंट करा, जो भी मेरे ऑब्जर्वेशंस आए उनसे मैंने लॉ डिड्यूस कर दिया कि ये मेरा प्रेशर हमेशा टेम्परेचर के साथ साथ बढ़ रहा है, तो इट इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर एट कांस्टेंट वॉल्यूम. सो आई स्टेटेड दिस इज गै-लुसाक्स लॉ. पहले मैंने एक्सपेरिमेंट किया, ऑब्जर्वेशंस देखे, टेम्परेचर इंक्रीज करने के साथ साथ मेरा प्रेशर इंक्रीज हो रहा था, तो आई गिव अ लॉ, P इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर. दिस इज व्हाट इज लॉ. But what is theory is कि हमने कुछ assumptions किए, and that is helping us to understand the basic laws. Okay, whatever experiment I am performing, I postulated certain things. अब मुझे पता चलेगा वो postulates ठीक है कि नहीं है. Postulate is just a statement which is given on some logical assertions. So theory is basically to understand the observations, and law has been deduced from the observations. Clear? So this is not a law, it is kinetic theory of gases, which states that our gases are made up of, say, a gas is made up of molecules which are spherical in shape and they are identical in size, shape and mass. So मतलब gas में जितने भी हमारे particles हैं, they are identical in size, shape and mass. Second thing would be that your volume of the molecules of the gas is negligible in comparison to the total volume of the gas. तो हम मान रहे हैं कि मॉलिक्यूल अगर इंडिविजुअली हम देखेंगे तो उसका वॉल्यूम है ही नहीं, ऑलमोस्ट नेग्लिजिबल है, but it is the total volume which is actually contributing to your this thing. The third to the volume of the gas. The third is that you talk about pressure. All right. We know now in case of gases, the molecules are in random motion. The molecules are in random motion. Now they are colliding with one another and they are also colliding with the walls of the container. Now when they are colliding with the walls of the container, there is a pressure exerted. Remember that pressure of the gas is only due to the collision of the molecules with the sides of the container. दिस इज वेरी इंपॉर्टेंट फॉर यू टू अंडरस्टैंड. अगर कोई भी प्रेशर है, जब तक वो वॉल्स के साथ कोलाइड नहीं करेगा, तब तक देयर इज यू विल नॉट टॉक अबाउट इट एट ऑल. So if there are more collisions, the pressure will get reduced. Collisions amongst oneself. What we are saying is, अगर हमने एक vessel लिया, उसके अंदर we have put gas. All right. Now the pressure will be solely because of the collision of the particles of gas with the walls of the container. जब वो walls के साथ टकराएगा, तभी pressure contribute होगा to the total gas. Got it? And the point that I was explaining, I was just throw light on it, but here we consider elastic motion of the molecules. Elastic motion मतलब हम समझ रहे हैं that there is, whenever the molecules are moving, there is no loss or gain in energy. All right, no energy loss, so they are perfectly elastic. So there is total law of conservation of energy. It's not going anywhere at all. Then you have that all the molecules basically follow the laws of classical mechanics. All of them all will follow the laws of classical mechanics. What is classical mechanics? Study of macroscopic objects. And when you talk about classical mechanics, it follows only Newtonian laws. And you have done Newton's laws. Then what we have is that sixth, we say that there are no forces of attraction or no forces of repulsion. That means there is no interaction. जितने भी molecules हमारी gas में हैं, we are assuming that there is no interaction between any kind of molecule at all. Okay, and then in the end we say that the kinetic energy, the average kinetic energy of the molecule is directly proportional to the absolute temperature. We state that the kinetic energy of the molecule is directly proportional to the absolute temperature. Okay, these are very important points that we actually check up for the kinetic theory of gases. Using all this basic theory, we arrive at another equation which is nothing but equal to, this is the kinetic equation, equation of state or kinetic equation, which holds good for the ideal gases again. I will just throw light on this equation. You need to remember this because we're not doing the derivation for this. We have done the derivation for PV is equal to nRT by using Boyle's law, Charles' law, Gay-Lussac's law, etc. Now here in this case, what we are basically saying is that this is the kinetic theory for which is for the ideal gases, where P is the pressure of the gas, V is the volume of the gas, small m is the mass of the molecule, N is the total number of molecules that we have, and U square is just the speed of the molecules within this gaseous substance that we are talking about. Okay, and of course, this is being followed by all the ideal gases, means that this will also be equal to RT. We can also see that this will be equal to RT, and from here we get, say, the root mean square. If I have to find out the mean square speed, that will be equal to 3 PV upon m into n, where if this n is the Avogadro number, then that means this will be 1. This will be the molar mass only. Okay, and this will also be equal to PV is equal to RT. So I can also write this as 3 RT by small m into n, where small m is the mass of one molecule and capital N is the total number of molecules that we are talking about. So if this n is nothing but your Avogadro's number, then this can be replaced by the molar mass. This is what you see, that this root mean square speed, when I take, if I have to find out u, I will have to take the square root of this u square, and that will be nothing but equal to under root of 3 RT by m, or under root of 3 PV by m is also correct. Now here at this point, we very clearly see that this is under root of 3 RT by m. We also see that this is nothing but, you need to understand, मान लो there are some one type of particles moving with the speed u1. There are some other type of particles moving with the speed u2. तो हमने u1 स्क्वायर किया प्लस u2 स्क्वायर किया प्लस u3 स्क्वायर सो ऑन, सारे स्क्वायर टर्म्स को हमने ऐड करा for different types of speeds which are available upon total number of molecules n. So basically this is your root mean square speed. Your root mean square speed is nothing but it is the sum of the squares of each type of speed which is available for different particles n. Say if each one of them is moving with a different speed, we total them up and then divide it by capital N. So this is nothing but your root mean square speed. On the other hand, if I talk about say average speed, then the average speed is nothing but say if some molecules are moving with a particular speed, say N1 is moving with a speed U1. So it will be N1 U1 plus N2 U2 and so on. So that is how we can add it up, and that is nothing but known as the average speed, which is equal to 8 RT by pi m, which is equal to 8 RT by pi m. And then we also have here, we can also talk about most probable speed that I will just do when I revise the Maxwell distribution. That is, most probable speed is nothing but it is equal to under root of 2 RT by m. Most probable speed का सिर्फ मतलब अभी समझ लो, it is that speed with which maximum number of particles or maximum number of molecules are moving. Right? So most probable means, as the name suggests, most probable. सबसे ज़्यादा probability of this speed is more. So majority of my molecules are moving with this speed. Okay. Now one important question that normally comes is you take the ratio of, what is the ratio of URMS to U average to U most probable? What is the ratio of say UMP to U average to URMS? And that will be nothing but, it is equal to 2RT by M, which is under root of 8RT by pi M, which is, what is root RMS, URMS? That is 3RT by M. So here you will have, it will be equal to root 2 is to root of 8 upon pi is to root 3, which will be equal to 1 is to 1.128 is to 1.224. This is a question which is many a times is asked in the numericals. Or for your entrance examination also, this choice is asked so many a times. So this has to be worked out. So if you have a fair idea that this is 1 is to 1.1 is to 1.2, then you can easily remember also. You can work it out for yourself. You know that when we are taking the ratio, you should know the meaning of each. What is most probable? The speed with which maximum number of molecules are moving. What is U average? It is the average speed of any molecule, the average which you can average out on the entire range. U RMS is just simply the sum of different types of speeds which are available divided by n. So you have U1 square, and this has been derived primarily from the kinetic gas equation. This comes from the Maxwell's distribution, and average speed is by the qualitative concept that I have explained. Okay, so from here, another thing that we get is, that your kinetic energy is what? It is equal to half mv square or half mu square. So when I compare it to half mu square, when I compare it to this and just replace it, half mu square, if I replace mu square, what will be your mu square? It will be 2 kinetic energy. So it will be 2 by 3 of kinetic energy, right? Got it? Kinetic energy is equal to half mu square. So what is your mu square? Twice of kinetic energy. Pick that up, place it here. So it will be 2 by 3 n times kinetic energy, right? And what will that be here in terms of this? It will be 3 by 2 RT. When you replace it for 1 mole, then in that case it will be 3 by 2 RT. So this is another formula for kinetic energy that we get after doing the kinetic gas equation and the theory of gases. Because This will come out to be equal to 3 by 2, say, and just remember, I'll just tell you here that remember that your R is nothing, R upon Na. Say if you have Avogadro number of molecule Na, then in that case, this is termed as a new term, that is K. Say this is 3 by 2 RT, I stated is correct, right? So 3 by 2 RT, there was an N also. There was an N also. If I consider only one particle, then this will hold good. But if there are any number of particles, तो फिर यहाँ पे एक Na भी आएगा. क्योंकि what was this? This was 2 by 3 capital N mu square ही तो replace करा था हमने. That was kinetic energy. Do you want me to solve it on the board? I repeat, from here we took mu square. Mu square is equal to twice of kinetic energy. We take it back to the kinetic gas equation and we see that from here we get PV is equal to 2 by 3 capital N into kinetic energy, right? Now your 2 by 3 of kinetic energy is also equal to RT. So I can say that N into kinetic energy is equal to 3 by 2 of RT. This is what I did here. If N is 1, then it is 3 by 2 RT. If it is Avogadro number of particles, then it is RT by Na, and this R by Na term is now given a new terminology, that is the Boltzman constant. The value of R is constant, 8.314. Na is the Avogadro's number, 6.022 into 10 to the power 23. ठीक है ना? और दोनों constant divided by constant will be another constant, and this is known as your Boltzman constant, the value for which is 1.38 into 10 to the power minus 16 ergs per Kelvin per number of molecules per molecule. So it is ergs per Kelvin per molecule. Okay? I'll just revise the entire this thing. Okay? With this, we revise what we had done in the last class to almost, 60% of last class's capability. So for all those of you who were absent, I think should be able to grasp it. And the ones who are present should be absolutely thorough with it, without any doubt. Okay? So now I repeat again. In the last class, we started with kinetic theory of gases. Kinetic theory of gases is nothing but some postulates which were given. What were those postulates? The very first thing, a gas comprises of molecules, each of which is spherical in shape, identical in size, shape, mass. So एक जैसे दिखते हैं सारे molecules. Volume of molecules is negligible in comparison to total volume. Obvious ही बात है, अगर एक छोटा सा molecule होगा, तो in comparison to the volume of the gas, you can remember. Pressure is due to the collision of the molecules with the sides of the container. आपस में भी collide करते हैं molecules, but the main pressure of the gas is due to the collision of the molecules with the sides of the container. Then we consider total elastic motion. Elastic motion means what? That there is no loss or gain of energy. Then we consider all the molecules to be following the laws of classical mechanics. Laws of classical mechanics are the Newtonian laws. Then we consider that there is no interaction between the molecules. एक गैस में जितने भी molecules हैं उनमें आपस में कोई interaction ही नहीं है, ना attraction, ना repulsion. So there is no force of attraction. Then we state that kinetic energy, average kinetic energy of the particles or molecules is directly proportional to the absolute temperature. And if I am saying absolute temperature, that means I am talking about temperature in Kelvin. ठीक है, फिर यहाँ से we get an equation which again is followed only by the ideal gases. What is that equation? PV is equal to 1 by 3 small m capital N U square, mn U square. मतलब पता होना चाहिए PV, you know, small m is the mass of one molecule. Capital N is the number of molecules. अगर ये number 6.022 into 10 to the power 23 है, Avogadro's number है, तो मतलब उतने molecules divide into mass of one molecule will be your molar mass. क्योंकि एक मोल में ही तो 6.022 into 10 to the power 23 molecules होते हैं. So that will be your molar mass then. Capital M हो जाएगा ये तब. लेकिन अभी mass of one molecule into total number of molecules into u square, where u is just a mean square speed. U square is just the mean square speed. And what is this u square? यहीं से mathematically देख सकते हैं, that is 3pv upon mn, right? अगर मैंने बोला कि ये एवोगाड्रो नंबर है तो ये मोलर मास हो जाएगा. So it can be either 3pv upon m or 3RT upon m, और u क्या होगा फिर अंडर रूट ऑफ दैट. सो u RMS is रूट मीन स्क्वायर स्पीड जो हमें काइनेटिक गैस इक्वेशन से मिली है, दैट इज अंडर रूट ऑफ 3RT by m. Okay, and then what is u average? It is the average of all the speeds, which is nothing but equal to under root of 8RT by pi m. And what is your u? Most probable, that is under root of 2RT by m. And when we take the ratios of the three, this is like a question which was asked many a times in many papers. Formula लिखने बैठोगे, उससे अच्छा you can remember it as root 2 by is to root of 8 upon pi is to root 3. Why am I talking about it again and again is that ये तो आप उस टाइम पे भी वर्क कर सकते हो, but the time that you will save for this can be utilized for working out a numerical. उतना कुछ seconds उधर लगा सकते हो दूसरे question में. So it is better that you remember that it is nothing but 1 is to 1.13 is to 1 is 1.22. 1 is to 1.13 is to 1.22. ठीक है? This is something that you can remember even otherwise. Otherwise formula तो याद रखने ही है. That is under root of 2RT by m. That is from the Maxwell's distribution. This is the average speed and this is the RMS from the kinetic gas equation. And again, I repeat that kinetic gas equation is the one which is followed only by the ideal gases. Okay. Then after this, I think we talked about the Maxwell's distribution. After this, we talked about the Maxwell's distribution. Here, we say that हमारे कुछ fraction of molecules are moving with the speed u. Some may be moving with a different speed of u and u plus du. अगर हम u को एक speed मानते हैं तो कुछ थोड़े से ज़्यादा और कुछ थोड़े से कम भी तो हो सकते हैं उससे. So what it defines is nothing but a fraction, say dn, where this is a very small amount of fraction. N is the number of molecules. So dn is a very small difference in the number of molecules which are moving in between the speeds, say u and u plus du. Those speeds are हमारे पास u and u plus du. So they are moving with a very, I mean, this fraction that I write here will give me the fraction of the molecules which are, this would be the fraction dnu by n. Fraction बोल रही हूँ तो fraction बना दो उसको. So dnu is the small change, I mean the small difference in the number of molecules to the total number of molecules which are moving in between the speed u and u plus du. It's only a concept that you need to know qualitatively, which can be written as 4 pi into m upon 2 pi RT whole to the power 3 by 2 into exponential of minus mu square upon 2 RT into u square into du. All right, into u square into du. If I take this du also, that means now I am checking this fraction with respect to du. So now this gives me the total fraction of molecules which are moving with the speed of u and u plus du. Clear? I repeat it again. हमारा Maxwell distribution means that something is being distributed and we are primarily talking about the distribution of speeds only. And we are talking about the total number of fraction of molecules which are moving with the speed of u and u plus du. Okay? And now understand the terms. M is the molar mass, R universal gas constant, pi constant, 2 constant, T temperature in Kelvin. You have again m here. This u is normally the speed of the molecules which we are talking about, u and u plus du. So this u is the speed of the molecules that we're talking about here. And again R and T are temperature. Now if we go on to plot the Maxwell's distribution, then on the y-axis I'll take this fraction. So this fraction is what? 1 upon du dnu by n to u. If I plot a graph, अब मेरे को इस फ्रैक्शन का वेरिएशन लेना है विद दिस u. अब इधर देखो ये टोटल टर्म तो कांस्टेंट ही है. This was the last thing I did in the last class. That was the Maxwell's distribution. I repeat, the left hand side now primarily is only giving me the total number of molecules which are the fraction of the molecules rather, sorry. It is giving me the fraction of the molecules which is moving in between the speed u and u plus du. ठीक है, ये वो मुझे फ्रैक्शन बताएगा जो u और u plus du के बीच में कितने मॉलिक्यूल्स मूव कर रहे हैं अप्रोक्सीमेटली. दैट इज नथिंग बट इक्वल टू ये टोटल टर्म जो मैंने ऐसे इसमें डाला है, दैट इज अ कांस्टेंट. 4 constant, pi constant, molar mass of a particular gas constant, 2 constant, pi constant, r constant, temperature अगर मैं constant रख रही हूँ, if I am carrying out the experiment at room temperature, तो room temperature एकदम से suddenly rise और drop तो करेगा नहीं, तो it is considered to be a constant, right? So इसका मतलब अब मेरा fraction और अगर मैं u को plot करती हूँ, तो it will depend only on these two terms, ठीक है? When my u is small, initially मेरी speed में धीरे धीरे अगर मैं speed कम की बात करूं तो then this fraction will rise according to u square term. So then that means there will be an increase. ठीक है, there will be an increase still according to the u square term. There will be an increase. जैसे जैसे u बढ़ेगा मेरा fraction बढ़ता जाएगा because there is an increase. Now here because u is small, so there is a significant decay here. क्योंकि u अभी छोटा है तो ज्यादा इस टर्म का इंपैक्ट पड़ेगा फ्रैक्शन पे इससे ज्यादा, बिकॉज u टर्म इज माय स्मॉल इन टिल अ पर्टिकुलर रेंज मेरा u स्क्वायर टर्म विल गो ऑन इंक्रीजिंग. एंड अगर मेरा u बढ़ेगा तो दैट मींस उतने फ्रैक्शंस उसको फॉलो करना शुरू कर देंगे. एक पर्टिकुलर स्पीड से मॉलिक्यूल्स आर मूविंग, राइट? इफ दैट स्पीड इज इंक्रीजिंग विद स्क्वायर टर्म्स, उतने ही फ्रैक्शन ऑफ मॉलिक्यूल्स उसको और ज्यादा फॉलो कर रहे हैं. Got the point? So that means the fraction of molecules which are moving with that speed, say they are going on increasing. Say this is u1, u2, u3. तो जैसे जैसे मेरी speed बढ़ रही है, मेरे number of fraction of molecules जो उसको follow कर रहे हैं वो भी बढ़ते जा रहे हैं. Got the point till here? Till I reach a maximum where I reach a speed where my maximum number of molecules are following a particular speed. Maximum number of molecules, whatever that speed is, जिससे maximum number of molecules move कर रहे हैं, I call it the most probable speed. अब एक लिमिट से ज्यादा जब मेरा u बढ़ जाएगा तो फिर तो इसका भी असर होना शुरू हो जाएगा, बिकॉज अगर ये बढ़ता जाएगा तो ये नेगेटिव टर्म बढ़ जाएगा. अगर ये नेगेटिव टर्म बढ़ेगा तो मेरा एक्सपोनेंशियल टू द पावर माइनस टर्म would make my fraction go down. So after the UMP is reached, after most probable speed is reached, और most probable speed क्या है जिससे maximum number of molecules move कर रहे हैं, then I would see an exponential decay. ये ग्राफ सिर्फ आप लोगों ने समझना है. Then there will be a decay. Got this point? So just look carefully at it. In the first half you have the u square term which is dominating, and because u is not that large, so therefore this exponential decay is not really significant. But here, as soon as you reach the UMP, then in that case, there is suddenly an exponential decay, which is like in the first half, if this term is dominant, then in the second half, it is the exponential term which decides the nature of your graph. Clear to everyone? This is what is known as the Maxwell distribution. This was the expression and this was the graph that was given by him. And from here, we derive our UMP. UMP कैसे derive करेंगे? Most probable speed. We'll just replace it and we'll take the differential and then put it to 0 and then we'll find out that this is a maxima. Second derivative find out करेंगे, that will be a neg. All that is not there in your course. You can remember the expression of U most probable, which is equal to 2RT by M. So that is why I stated that most probable speed is nothing but most probable speed is दैट स्पीड जिससे मैक्सिमम नंबर ऑफ मॉलिक्यूल्स आर मूविंग. ओके, मैक्सवेल्स डिस्ट्रीब्यूशन जो है आपने सिर्फ क्वालिटेटिवली करनी है, एंड दैट आल्सो फ्रॉम एंट्रेंस एग्जामिनेशन पॉइंट ऑफ व्यू ओनली. आई डोंट थिंक इट इज डन इन डिटेल इन स्कूल एज टू दैट एक्सटेंट. ये एक एक्सप्रेशन है. इस एक्सप्रेशन में आपने दो टर्म्स पे फोकस करना है. कौन से? एक तो लेफ्ट हैंड साइड तो पता ही होना चाहिए. लेफ्ट हैंड साइड इज व्हाट? इट इज 1/du dnu/n. ये क्या है? ये आपको बता रहा है कि एक फ्रैक्शन ऑफ मॉलिक्यूल्स हैं, जो एक फ्रैक्शन ऑफ मॉलिक्यूल्स हैं, दे आर, इट विल टेल यू अबाउट दोस फ्रैक्शन ऑफ मॉलिक्यूल्स जो u और u प्लस du स्पीड के बीच में घूम रहे हैं. मतलब u स्पीड से घूम रहे हैं, plus du is like a very small change in your velocity. So it will tell you about those fraction of molecules which are moving with the speed, a particular speed u. In between the speed u and u plus du. ये चीज क्या है? Then we say that that is equal to this entire term, जिसमें मेरे दो terms important है, क्योंकि these have been experimentally deduced equation. तो इसमें दो terms कौन से जरूरी है कि एक ये fraction जो है that is directly proportional to u square. दूसरा ये फैक्टर जो है दैट इज डायरेक्टली प्रोपोर्शनल टू एक्सपोनेंशियल ऑफ -mu²/2RT. सो दैट मीन्स कि जब मेरा इनिशियली u छोटा है तो मेरा जो फ्रैक्शन है, ये लेफ्ट में इसका मतलब है कि ये मेरे फ्रैक्शन ऑफ मॉलिक्यूल्स हैं. अगर मेरा u बढ़ेगा तो मेरा फ्रैक्शन ऑफ मॉलिक्यूल्स विल इंक्रीज अकॉर्डिंग टू u स्क्वायर. ओके, अगर मेरा u स्क्वायर बढ़ेगा तो मेरा फ्रैक्शन ऑफ मॉलिक्यूल बढ़ जाएगा. तो ये यू सी एन इंक्रीज इन द ग्राफ. जैसे जैसे मेरा u बढ़ रहा है, फ्रैक्शन ऑफ मॉलिक्यूल्स उसको फॉलो करने वाले एट अ पर्टिकुलर स्पीड आर इंक्रीजिंग टिल एक स्पीड है मोस्ट प्रोबेबल स्पीड, जिसको मैक्सिमम नंबर ऑफ मॉलिक्यूल्स फॉलो करेंगे. दैट इज द लिमिट. उस लिमिट के बाद जैसे मेरा u और ज्यादा बढ़ेगा, देन इन दैट केस व्हाट विल हैपन इज दैट नाउ योर दिस टर्म विल आल्सो बिकम सिग्निफिकेंट. क्यों? क्योंकि u अगर बढ़ रहा है तो यहाँ पे -u² टर्म भी तो बढ़ता जा रहा है. How can we ignore that? छोटा था तो चलो, we just ignored it here, and increase was basically according to u square term. After most probable speed was attained, now there will be a decrease in speed according to exponential term, which is -mu²/2RT, and that is your exponential decay. ठीक है? तो first term is according to, I mean, increases because of u square, and the second half of the graph जिसमें decrease हो रहा है, that is because of exponential term. ठीक है? So after this, I think now we also talked about, say, I think critical states and critical constants. How can I forget that? Critical constants की भी हमने बात करी थी, जिसके अंदर we talked about TC, PC and VC. These are very very important. Why? Because critical temperature is that temperature जहाँ पे the demarcation between gases and liquids disappear. Remember that. What is your critical temperature? Critical temperature is the minimum temperature above which your gases cannot be liquefied. So it is that temperature above which your gases cannot be liquefied, which is 8A/27 RB. This is what you all are supposed to remember. What I have is critical constants. But before that, what is your A and B? I did not revise that. A and B are your van der Waals constant. And when I did my kinetic theory of gases, उस केस में मेरा जो second और I think sixth assumption था. अब ऐसे second, sixth तो याद नहीं होगा. Let me just tell you. One assumption was that the volume of the gas is much larger than the volume of molecules. तो हम मानते हैं कि molecules का बिल्कुल volume है ही नहीं, which is not the case. Individually आपस में molecules का अपना भी तो कुछ weight होता है. तो उस केस में हम कहते हैं जैसे अगर ये एक molecule है and it is coming in close contact with another molecule, then the excluded term which I stated was nothing but this is known as the excluded co-volume. ये मेरे दो molecules हैं. This is nothing but my excluded co-volume. मतलब मेरा आप molecule का भी जो volume है that is significant. That is not negligible. उसका खुद का volume है. And here when I see it, I check that volume. That volume now it is a pair of molecule. Per pair it will be 4/3 pi r cube is the formula for a sphere. So it will be 4/3 pi इंटू 2r का होल क्यूब. वाई 2r? बिकॉज r इसका और r इसका. सो इस टोटल स्फीयर का जो एक्सक्लूडेड को वॉल्यूम होगा दैट विल बी 4/3 पाई इंटू 2r का होल क्यूब. क्लियर टू एवरीवन? एंड दैट विल बी इक्वल टू 8 इंटू 4/3 पाई r क्यूब. 2 क्यूब बाहर निकाल लिया. That will be 8. So that means my excluded co-volume per pair of molecules will be 8 times the molecule's volume. एक molecule का volume कितना? 4/3 pi r cube. और जो excluded co-volume वो occupy कर रहा है that is nothing but 8 times of the original volume of the molecule. ये तो मैंने बात करी for a pair. If I talk about volume of one molecule, the excluded co-volume for one molecule, what will that be equal to? That will be half, क्योंकि pair मतलब दो molecules का, और अगर एक molecule का चाहिए तो उसको मैं divide by 2 करूंगी. So that will be 4 into 4/3. So excluded co-volume will be nothing but 4 times the volume of one molecule. Molecules are spherical in shape. ठीक है? This is something that we very importantly need to do. Before coming on to the critical constants also, I should have done this. क्योंकि हमने kinetic theory of gases में we had done very many postulates which are true for the ideal gases. But in reality we see that that is not the case. Ideal gas law equation क्या थी? एक तो हमारी थी PV is equal to nRT. दूसरी equation क्या थी? PV is equal to 1/3 mn u square. ठीक है, ये थी. और फिर हमने देखा दिस कैन ऑल्सो बी इक्वेटेड टू योर RT, बिकॉज है तो ये अल्टीमेटली यही ना. ठीक है, फिर अब हमने इसको मॉडिफाई कर रहे हैं हम PV इज इक्वल टू nRT. तो हमने देखा कि हमारा जो वॉल्यूम ऑफ द रियल गैस है दैट विल बी नथिंग बट दैट विल बी आइडियल गैस वॉल्यूम से कम. क्योंकि आइडियल में हमने क्या माना था कि दैट द वॉल्यूम इज लाइक नेग्लिजिबल. सो व्हाट वी से इज दैट V ideal will be equal to V real minus NB, which implies that my V real is more. Sorry, क्योंकि आइडियल केस में हमने क्या माना है कि वॉल्यूम क्या है? नेग्लिजिबल. नेग्लिजिबल मतलब ऑलमोस्ट जीरो. लेकिन इन रियलिटी मेरे मॉलिक्यूल्स आपस में दे ऑक्यूपाई वॉल्यूम. वो हमने एक्स्ट्रा वॉल्यूम को कैसे कंसिडर करा? बाय टेकिंग द एक्सक्लूडेड को वॉल्यूम. व्हाट इज दैट एक्सक्लूडेड को वॉल्यूम? 4/3 pi into 2r whole cube. I am repeating it again because I saw questions on it in your previous entrance examinations. So what you have is 4/3. So it becomes 8 into 4/3 pi r cube. ये तो हो गया पेयर का. तो अगर मैं एक मॉलिक्यूल की बात करूंगी तो it will be 4 times the molecule of a volume of a molecule. ठीक है. सो एक चीज यहाँ पे जो करने वाली है दिस, एंड नाउ B is now the, this can be termed as excluded co-volume. B is the excluded co-volume. और यहाँ पे एक चीज जो याद रखनी है, तो इसका मतलब मेरा V real जो है वो मेरा आइडियल से ज्यादा है. इस पे भी क्वेश्चंस थे तो इसीलिए कोई डाउट नहीं रखना. तो V real will be greater than V ideal, of course, because V real is V ideal plus NB. ठीक है, where N is the number of moles. फिर उसके बाद एक और assumption करी थी हमने, that was that there are no forces of attraction or repulsion. लेकिन that is not the case. अगर forces of, what is the reason given for that? अगर attractive force नहीं होता तो कोई गैस liquefy ही नहीं होती. अगर अट्रैक्टिव फोर्स नहीं होगा तो लिक्विफाई होगा ही नहीं गैस. तो उस केस में देन दैट मींस फोर्सेस ऑफ अट्रैक्शन है. और अगर मेरा फोर्सेस ऑफ अट्रैक्शन है तो मेरा प्रेशर क्यों है? दैट इज बिकॉज ऑफ द कोलिजन ऑफ द मॉलिक्यूल्स विद द साइड्स ऑफ द कंटेनर. ठीक है, तो अब अगर मेरे मॉलिक्यूल्स आपस में इंटरैक्ट करेंगे, तो वो बॉल से कम कोलाइड करेंगे. तो इसका मतलब मेरा प्रेशर जो रियल का है वो कम हो जाएगा, क्योंकि आइडियल केस में तो मैं मान रही हूँ वो अट्रैक्ट और रिपेल कर ही नहीं रहे. ठीक है, अगर वो अट्रैक्ट रिपेल नहीं कर रहे तो सारा कंसंट्रेशन किससे टकराने में है? वॉल से, एंड बेसिकली वॉल से टकराएंगे तो प्रेशर उसी की वजह से होगा, तो प्रेशर ज्यादा होगा. लेकिन इन रियलिटी व्हाट वी हैव फाउंड इज दैट देयर आर फोर्सेस ऑफ अट्रैक्शन अमंगस्ट द मॉलिक्यूल्स एंड रिपल्शंस आल्सो. तो इसका मतलब उनमें इंटरैक्शन है, और अगर मॉलिक्यूल्स आपस में इंटरैक्ट करेंगे तो साइड्स ऑफ द वेसल से कम इंटरैक्ट करेंगे, तो इसका मतलब प्रेशर रियल केस में इट विल बी लेस. और वो कैसे लेस होगा, आई टेल यू. जो भी हमारा एडिशनल, अब कोई करेक्शन टर्म है, इसका मतलब मुझे कोई करेक्शन टर्म डालना है. ये जो मेरा पी आइडियल है डेफिनेटली मींस दैट दैट इज ग्रेटर देन माय पी रियल. ये चीजें आप याद रखोगे, ये लास्ट टाइम मैंने स्पेशली हाईलाइट नहीं करी थी, बट यू विल रिमेंबर दैट पी आइडियल इज ग्रेटर देन योर पी रियल, और उसका रीजन मैं समझा चुकी हूँ, राइट. सो व्हाट इज पी आइडियल नाउ, दैट आई हैव टू इंट्रोड्यूस सम करेक्शन टर्म. ठीक है, और ये जो करेक्शन टर्म है दैट विल बी डायरेक्टली प्रोपोर्शनल टू, ये नहीं भी याद रखोगे तो भी चलेगा, तो पर याद बता देती हूँ कि कैसे आया. इट विल बी डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ मॉलिक्यूल्स पर यूनिट वॉल्यूम व्हिच आर हिटिंग द साइड्स ऑफ द वेसल. जो भी मेरा प्रेशर का करेक्शन टर्म है दैट इज डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ मॉलिक्यूल्स पर यूनिट वॉल्यूम and the number of molecules hitting the sides per unit time. तो ये n by v term दोबारा से आता है, तो इसका मतलब मेरा करेक्शन टर्म इज डायरेक्टली प्रोपोर्शनल टू n स्क्वायर बाय v स्क्वायर. और अगर n स्क्वायर बाय v स्क्वायर जब मैं प्रोपोर्शनलिटी का साइन हटाऊंगी तो इट विल बिकम a n स्क्वायर बाय v स्क्वायर. करेक्ट, दिस विल बी माय करेक्शन टर्म. आई रिपीट इट अगेन. There are in reality forces of attraction. जब forces of attraction gas में होंगे तो they will collide less with the walls of the container. What will be the outcome? That the pressure of the real gas will be lower than the pressure of the ideal that we thought, right? Thought of. So in this particular case of real gases, there will be some additional term which should be added. Why? Because ideal मेरा ज़्यादा बड़ा है. तो वो करेक्शन टर्म दो चीजों पे डिपेंड करते हैं, नंबर ऑफ मॉलिक्यूल्स हिटिंग पर यूनिट वॉल्यूम एंड द नंबर ऑफ मॉलिक्यूल्स हिटिंग पर यूनिट टाइम व्हिच इज आल्सो n by v. ठीक है, उन दोनों को जब हम क्लब करते हैं तो दैट मींस मेरा करेक्शन टर्म इज डायरेक्टली प्रोपोर्शनल टू n स्क्वायर बाय v स्क्वायर. इन दोनों को क्लब करेंगे, जब प्रोपोर्शनैलिटी का साइन में हटा दूंगी तो देयर विल बी अ कांस्टेंट दैट विल बी a. So what I get from here is that now my p has changed to p plus an square by v square. My v has changed to v minus nb. So now I have introduced an equation for my real gases. And what is that equation? That is p plus pv is equal to nRT. Ideal का था, तो real का क्या होगा? p plus a n square by v square into v minus nb is equal to nRT. और अगर 1 मोल की बात करेंगे तो 1 मोल में क्या होगा? P प्लस ए बाई वी स्क्वायर, क्योंकि n 1 हो गया, V माइनस बी इज इक्वल टू आर टी. अच्छा, एंड देन वन मोर थिंग दैट इज हियर, ये जो ए टर्म है दैट इज अ मेजर ऑफ द फोर्सेस ऑफ अट्रैक्शन. जितना बड़ा ए उतनी ज्यादा फोर्सेस ऑफ अट्रैक्शन. क्यों? क्योंकि ये हम प्रेशर के लिए टर्म यूज करा ना हमने. ये प्रोपोर्शनैलिटी कांस्टेंट किस चीज के लिए था? प्रेशर के लिए. तो याद रखा, इट विल बी रिलेटेड टू द फोर्सेस ऑफ अट्रैक्शन. ए will be directly related to forces of attraction. जितना बड़ा A उतनी ज्यादा forces of attraction. And what is this B? This is related to compressibility. जितना बड़ा B उतनी ज्यादा gas compressible. Okay? It is the excluded co-volume. Excluded co-volume मतलब कि वॉल्यूम तो उसका खुद का है ही, उसके साथ और भी जो वॉल्यूम एनकैप्सुलेट कर रहे हैं अपने साथ. ठीक है, एक वॉल्यूम तो गैस का खुद है, उसके साथ वो और भी मॉलिक्यूल्स अपने साथ एनकैप्सुलेट कर रहा है ना, तो दैट इज एक्सक्लूडेड कोवॉल्यूम. अब जितना ज्यादा ये कोवॉल्यूम होगा उतनी ज्यादा गैस कंप्रेसिबल होगी. सो बी इज अ डायरेक्टली प्रोपोर्शनल टू योर कंप्रेसिबिलिटी फैक्टर. नाउ फॉर द रियल गैसेस वी सी, जब हम उसका टेम्परेचर इंक्रीज करते जाते हैं तो एक स्टेज पे क्या होता है कि व्हेन वी एक्चुअली रीच अ पर्टिकुलर प्रेशर कम करेंगे, सॉरी प्रेशर इंक्रीज करते जाएंगे तो गैस मॉलिक्यूल्स का क्या होगा? दे विल कम क्लोज टू वन अनदर एंड एट वन स्टेज यू विल गेट लिक्विड्स, ऑलराइट, एंड साइमल्टेनियसली टेम्परेचर विल आल्सो हैव एन इफेक्ट. ये दिस क्रिटिकल कांस्टेंट्स वर स्टडीड बाय Andrews. Or what did he actually study? He studied PV isotherms at different temperature. क्या करा था उसने? उसने P वर्सेस V के प्लॉट बनाए थे एट डिफरेंट टेम्परेचर. तो एक बार एक टेम्परेचर को कांस्टेंट रखा, दूसरी बार इंक्रीज करके देखा, फिर तीसरी बार फिर से इंक्रीज करके देखा, तो ही गॉट कर्व्स लाइक दिस, समथिंग लाइक दिस. जैसे वॉल्यूम इंक्रीज कर रहे हैं, प्रेशर डिक्रीज कर रहे हैं, so he got something like this. And from here we arrived at a temperature Tc, which is the maximum temperature, sorry, this is the minimum temperature above which your gases cannot be liquefied. इस टेम्परेचर के ऊपर आप अपनी गैसेस को लिक्विफाई कर ही नहीं सकते हो. एंड व्हाट इज दैट क्रिटिकल टेम्परेचर? इट इज 8A/27 RB. व्हाट इज योर प्रेशर? Pressure is nothing but it is the minimum pressure required. It is the minimum pressure required at the critical temperature to liquefy the gas. So that is A upon 27 B square. And critical volume is the volume of 1 mole of a gas at critical temperature and critical pressure. That is equal to 3B. And I also told you PCVC by RTC अगर करोगे तो that will come out to be 3/8. This is important. And then you have, I also give you terms for A and B. B is equal to VC by 3. And as far as I do remember, A is equal to 3 PCVC square. So all these terms should be remembered so that you can arrive at these things easily. Okay, I quickly explain again the van der Waals equation में कि pressure हमारा real का जो है वो कम कैसे होता है. हमारे ideal के case में what did we assume? In ideal case we thought that there is no forces of attraction, no repulsion. And what is the pressure due to? It is mainly due to the collision of the molecules with the walls of the container. Now if the collision is basically due to walls of the container, और अगर मेरा forces of attraction है, reality में तो forces of attraction है, तभी एक gas liquefy होगी, right? So in this particular case what we basically have is real gases के case में there are forces of attraction, and if the molecule will have forces of attraction or repulsion, they'll be busy interacting amongst themselves more. ठीक है? Now if they'll interact with themselves more, then the collision with the walls of the container would be less. Now if the collision with the walls of the container is less, then in that case the pressure is lesser than the case of ideal gases. So that is why we have the pressure of the real gases to be lesser than that of ideal gases. और तभी हम एक correction term real में add करते हैं क्योंकि ideal हमारा ज़्यादा था. And what is that correction term? AN square by V square. ठीक है? उसके बाद we talked about some critical constants जो हमारे PV isotherm पे based थे. Done with real gases at different temperature. Andrews found that there comes a temperature, minimum temperature, जिसके ऊपर gas liquefy नहीं होगी, and that is 8A/27 RB. You have to remember this. What is your critical temperature? The temperature मतलब भी पता होना चाहिए कि वो temperature जिसके ऊपर हमारी gas liquefy नहीं होगी. फिर उसके बाद critical pressure, it is that pressure, critical temperature पे gas हमारी is like gases और liquid में हमारा demarcation line खत्म हो जाता है. लेकिन फिर भी critical temperature पे जितना minimum pressure मुझे लगाना है for the gas to make it a liquid, that is your critical pressure. ठीक है? And the volume occupied by 1 mole of a gas at PC and TC is your critical volume. याद हो गया? मतलब TC minimum temperature जिसके ऊपर gases liquefy नहीं होंगी, PC minimum pressure, critical temperature पे जितना चाहिए to make a gas a liquid, and critical volume, वो volume that is occupied by 1 mole at TCPC. ठीक है? And what is important here is sometimes you're asked to compute A and B. So along with the formula of TC, which is 8A upon 27 RB, your PC, which is A upon 27 B square, your VC, which is 3B, you should also remember that A can be derived from these equations only. B तो clearly नजर आ रहा है, very easy, VC by 3, and what is your A? That is 3 PC VC square. ठीक है, that is 3 PC VC square. And another thing that is normally asked is what is the ratio of TC VC by RTC? That is equal to 3 by 8. And 3 by 8 would be, I think, 0.375 or something. You check it out. After this, we had introduced two more terms. One was the Boyle's temperature. Boyle temperature क्या होता है? ये वो वाला temperature होता है जिस temperature पे my gases will behave ideally over a wide range of pressure. मतलब एक temperature है जिसपे my gases will behave ideally over a wide range of pressure. Pressure में काफी हद तक भी change कर लूंगी तो my gases will behave ideally. Normally gases कब ideally behave करती हैं? Low pressure, high temperature. Boil temperature वो temperature है जिसपे pressure काफी मैं इधर उधर भी कर देती हूँ तो भी my gases will behave ideally. So this is that temperature at which my gas laws are obeyed over a wide range of pressure, and that is equal to A upon RB. Achha, and then we had done one more, that was inversion temperature, that you will do with your thermodynamics teacher also. Inversion temperature जो है that is related to your Joule-Thomson's effect. मैंने इतना ही बताया था. Joule-Thomson effect होता है जिसमें enthalpy change same रहता है, heat change जो है वो same रहता है, और इसमें inversion temperature को explain करने के लिए I am writing it because it is related to the van der Waals constant, that is equal to 2A by RB. Inversion temperature is equal to 2A by RB, where you just have to remember that inversion temperature के ऊपर there will be heating of the gas. अगर मैं inversion temperature के ऊपर जाऊंगी तो there will be heating of the gas, और अगर inversion temperature से नीचे होंगी तो there will be cooling. Okay, because at that temperature also the thing has some temperature which may be positive, but even after that अगर वो inversion temperature से नीचे है तो there will be cooling of gas. अगर inversion temperature के ऊपर है then there will be warming of the gases. Okay, and then now I will talk about a new concept of, say, degrees of freedom. More or less whatever I have done till now is nothing but the revision of what we had done before. So revision करने में almost 1 hour spend हो गया. So let's just concentrate on now the degrees of freedom. Please remember all these formulae that we had done, and it were primarily done for all those of you who were absent. So I hope you just go thorough with them. Degrees of freedom क्या होते हैं? अब जैसे हमारा pressure, volume, temperature ये सब variables हैं. It is the minimum number of variables which are, समझ लो हर बुक में मिलेगी इसकी definition. Degrees of freedom क्या होते हैं? It is the minimum number of variables which are required to define your system completely. अगर मान लो कि मुझे completely define करना है, maybe my name works, so the degree of freedom will be just 1. If just by name there is only one such and such ABC person, so if you say ABC then that means it defines the person completely, so it is only one variable. तो ऐसे ही gases को अगर completely define करना है तो जितने minimum मुझे variable का मतलब जो vary कर सकता है, variable, it is capable of varying, able to vary, variable. ठीक है, तो जितने मेरे minimum variables चाहिए, variables क्या होते हैं? Pressure change होता रहता है, volume change होता रहता है, temperature, all these are variables. So minimum number of variables which are required to define a system completely, that is known as degree of freedom. There is a question, please explain Boyle's temperature again. Before I start with degrees of freedom in detail, let's do Boyle's temperature. Boyle temperature वो temperature होता है जिसकी वजह से जिस temperature पे my gases behave ideally for a wide range of pressure. Okay, मतलब गैसेस आइडियली कब बिहेव करती हैं? लो प्रेशर एंड हाई टेम्परेचर पे. अब इस टेम्परेचर पे प्रेशर बहुत ज्यादा भी अगर रेंज में होता है तो भी गैसेस बिहेव आइडियली. सो अंडरस्टैंड ओनली द क्वालिटेटिव मीनिंग. Okay. Now, degrees of freedom. I am not repeating, I am just starting with degrees of freedom. What is degrees of freedom? It is the minimum number of variables which are required to define a system completely. ठीक है, अब ये समझ लो कि मेरे को क्या क्या चीजें चाहिए सिस्टम को डिफाइन करने के लिए. इफ आई हैव अ मॉलिक्यूल, तो मैं देखूंगी ये कितने तरीकों से मूव कर सकता है. अब ये ऐसे भी मूव कर रहा है, ये ऐसे भी मूव कर सकता है. सो देयर आर डिफरेंट वेज. दैट वेज, अब हमारे 3 डिग्रीज ऑफ फ्रीडम होते हैं. एक होता है ट्रांसलेशनल, एक रोटेशनल और एक वाइब्रेशनल. ठीक है, अब इसका मतलब समझ लो. ट्रांसलेशन का मतलब होता है मूविंग इन अ पर्टिकुलर डायमेंशन. स्टॉप राइटिंग एंड पे अटेंशन. ठीक है, ट्रांसलेशन का मतलब होता है जैसे अगर ये ऐसे मूव कर रहा है तो ये एक्स डायरेक्शन हो गई, ये ऐसे मूव कर रहा है तो ये वाई डायरेक्शन हो गई, ये ऐसे मूव कर रहा है तो ये जेड. जो भी सीधी लाइन डायरेक्शन में जो भी मूव हो रहा होता है दैट इज ट्रांसलेशन. और जब हमारे गैस के मॉलिक्यूल्स मूव कर रहे होते हैं ना, ज्यादातर सारे ट्रांसलेटरी मोशन ही होते हैं. दे आर मूविंग इन स्ट्रेट लाइंस. कोई ऐसे ऐसे डांस नहीं कर रहा होता. सो व्हाट यू हैव इज, व्हेन यू टॉक अबाउट ट्रांसलेशनल मोशन, सो कितनी डायरेक्शंस होती है हमारे पास? 3. तो ट्रांसलेशनल डिग्रीज ऑफ फ्रीडम कितनी होंगी? जनरली कितनी होगी? 3. सो नॉर्मली ट्रांसलेशनल डिग्रीज ऑफ फ्रीडम आर 3 बाय एंड लार्ज. ठीक है, ट्रांसलेशन तो हर एक के पास 3 ही वो है, और हर मॉलिक्यूल इज फ्री टू मूव इन ऑल द 3 स्पेशल डिमेंशंस. तो वी हैव 3 ट्रांसलेशनल डिग्रीज ऑफ फ्रीडम. So what we have is it will move in the x dimension, it will move in the x, y and z. तो ट्रांसलेशन मतलब 3 में सीधी मूव कर सकती है, तो 3 ट्रांसलेशनल. क्लियर टू एवरीवन? रोटेशन का सबको मतलब पता है कि रोटेशन कैन बी आइदर लाइक दिस और इट कैन बी लाइक दिस. 2 डायमेंशन में हो सकता है. तो अगर मेरे पास, मान लो अब रोटेशन में मुझे मॉलिक्यूल देखना पड़ेगा कि मेरा मॉलिक्यूल लीनियर है या नॉन लीनियर है. अब आप हाइब्रिडाइजेशन कर चुके हो तो आपको लीनियर और नॉन लीनियर का मतलब पता है. जो भी sp हाइब्रिडाइज वो लीनियर, बाकी सबके सब नॉन लीनियर. तो लीनियर मतलब इट इज लाइक दिस, राइट? एंड नॉन लीनियर कैन बी एनीथिंग लाइक दिस. तो लीनियर कैन रोटेट मतलब इट्स लाइक अ रोटेशनल मोशन. सो इट कैन रोटेट इन ओनली along 2 axes. It's either like this or it's like this, right? Linear can move only like this. And what about non-linear? उसके पास तो तीनों ही dimensions available हैं. कभी वो ऐसे move कर लेगा, कभी ऐसे और कभी ऐसे. You getting the move? You have 3 dimensions, तीनों के long rotation. तो इसका मतलब मेरा जो भी linear molecule होगा उसके पास हमेशा 2 degrees of freedom होंगी और non-linear के पास हमेशा 3 होंगी. ये चीज समझ में आई? एंड टोटल डिग्रीज ऑफ फ्रीडम, मान लो मेरे मॉलिक्यूल में n एटम्स हैं. n अगर एटम्स हैं तो मेरे टोटल डिग्रीज ऑफ फ्रीडम होंगे 3 into n. दिस इज वेरी इंपॉर्टेंट. मेरे डिग्रीज ऑफ फ्रीडम जो टोटल होंगे दे विल बी 3 into n, वेयर n इज द नंबर ऑफ एटम्स. ठीक है. अच्छा, वाइब्रेशनल मोशन क्या होता है? इट इज अ टू एंड फ्रो मोशन. वाइब्रेशन मोशन जो होता है, पर अब आप सोचोगे वाइब्रेशनल सिर्फ ऐसे 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 यही वाइब्रेशन होता है. नहीं, वाइब्रेशन भी देयर आर डिफरेंट टाइप्स ऑफ वाइब्रेशंस. इट इज लाइक you have a zigzag motion, you have a wagging motion. Wagging is like the tail of a dog, so it's like a wagging motion. You have a zigzag motion. So all these may be vibrational motions. लेकिन कितने टाइप के वाइब्रेशन मोशंस? टोटल मेरे 3n है. ठीक है, सबके पास 3 ट्रांसलेशनल तो है ही है डिग्रीज ऑफ फ्रीडम. रोटेशनल डिग्रीज ऑफ फ्रीडम लीनियर अगर है तो 2 और अगर नॉन लीनियर है तो 3. और वाइब्रेशनल में अब कितने बच गए? अगर मेरा लीनियर मॉलिक्यूल है तो टोटल में से जितने भी ट्रांसलेशनल रोटेशनल के हैं तो 3n माइनस 3 इसके, और लीनियर में कितने हैं? 2. तो इट विल बी फॉर लीनियर 3n minus 5. So vibrational degrees of freedom will be 3n minus 5. And for non-linear, it will be 3n minus 6. Okay. Now we have degrees of freedom. मैंने क्या बोला, डिग्रीज ऑफ फ्रीडम वो मिनिमम नंबर ऑफ वेरिएबल्स हैं जो अगर मैंने डिफाइन कर दिए तो मतलब मेरा सिस्टम टोटली डिफाइंड है। अब मेरे डिग्रीज ऑफ फ्रीडम 3 टाइप्स के, ट्रांसलेशनल, रोटेशनल, वाइब्रेशनल। ट्रांसलेशनल का मतलब मैंने समझा दिया दैट इट इज लाइक ट्रैवलिंग इन वन पर्टिकुलर डायमेंशन। ट्रांसलेशन मीन्स वी आर ट्रैवलिंग इन वन पर्टिकुलर डायमेंशन। कितनी डायमेंशन होती हैं? 3। कौन सी? एक्स, वाई एंड जेड। ऑलराइट, सो इफ आई एम टॉकिंग अबाउट ट्रांसलेशनल डिग्रीज ऑफ फ्रीडम तो मेरे को कितनी जगह पे जाना पड़ेगा? डिफरेंट 3। सो आई नीड 3 ट्रांसलेशनल डिग्रीज ऑफ फ्रीडम। रोटेशनल, अगर मेरा मॉलिक्यूल लीनियर है, लीनियर मॉलिक्यूल है तो इट कैन रोटेट अबाउट 2 एक्सेस, सो आई विल हैव 2 रोटेशनल डिग्रीज ऑफ फ्रीडम फॉर लीनियर। नॉन लीनियर है तो फिर इट विल बी 3। ठीक है, वाइब्रेशनल में जो भी बच गया दैट मेनी वाइब्रेशनल डिग्रीज ऑफ फ्रीडम, दैट विल बी 3n minus 5, why 3n is total, minus 3 plus 2। ठीक है, दैट इज ट्रांसलेशनल और रोटेशनल। तो इसकी 3 plus 2 दैट इज 5, सो 3n minus 5 विल बी फॉर लीनियर वाइब्रेशनल डिग्रीज ऑफ फ्रीडम फॉर अ लीनियर मॉलिक्यूल। और नॉन लीनियर मॉलिक्यूल में कितनी? 3n minus 6। लेट अस जस्ट क्विकली टेक अप एन एग्जांपल, कैलकुलेट द डिग्रीज ऑफ फ्रीडम फॉर different degrees of freedom for carbon dioxide. Calculate the degrees of freedom for carbon dioxide. What will be the total? Time ही नहीं लगना चाहिए. You have the formula 3 into how many atoms are there? 3 atoms है. कार्बन और ऑक्सीजन, ऐसे दो नहीं मानोगी. You have 2 oxygen atoms and 1 carbon atom. So you have 3 atoms. तो total degrees of freedom हो गई 9. ठीक है. कार्बन डाइऑक्साइड कैसा मॉलिक्यूल है? पहले ट्रांसलेशनल तो कितनी होंगी? ट्रांसलेशनल डिग्रीज ऑफ फ्रीडम तो होंगी 3 तो है ही है, बिकॉज 3 डायमेंशंस आर पॉसिबल, ट्रांसलेशन 3 डायरेक्शंस में पॉसिबल है। देन यू हैव रोटेशनल। अब रोटेशनल में देखना पड़ेगा कि मॉलिक्यूल लीनियर है कि नॉन लीनियर है। कार्बन डाइऑक्साइड इज sp hybridized, sp means it is linear, so that means 2 लीनियर की कितनी थी? 2। ठीक है, और फिर वाइब्रेशनल की कितनी हो गई? टोटल 9 minus 5 4. So you can easily work out the degrees of freedom for any molecule. Calculated for water. वाटर की टोटल कितनी है? अगेन 3 एटम्स तो 9। ठीक है, ट्रांसलेशनल हो गई हमारी 3, सोचना ही नहीं है इसमें। रोटेशनल हो गई 3 क्योंकि ये अब sp3 हाइब्रिडाइज्ड है, नॉन लीनियर है तो 3। और मेरे वाइब्रेशनल हो गई 9 minus 6 which is again 3. So 3 3 3 for each of water. Clear? This concept will be used in very many other topics of chemistry as well. But ये मैंने अभी क्यों लिया है? Because I wanted to tell you that there is a law of equipartition of energy. लॉ ऑफ इक्विपार्टीशन ऑफ एनर्जी। ये लॉ क्या कहता है? ये कहता है कि अगर मेरा कोई भी एनर्जी टर्म है एंड इट कैन बी एक्सप्रेस्ड एज अ स्क्वायर टर्म, ठीक है, तो दैट विल बी डायरेक्टली प्रोपोर्शनल टू हाफ kT. दैट मींस इफ माय एनर्जी कैन बी written as a sum of if it can be written as a sum of some energy terms, each of which is proportional to a square of velocity term, then each term is proportional to half kT. मतलब कि it states that अगर मेरा total energy, अच्छा you tell me for the helium atom what are the degrees of freedom now? helium atom एक atom है तो total degrees of freedom total 3, translational 3, तो rotational 0, vibrational 0, so it will have 3. तो अगर मेरा इसका एनर्जी मैं चेक करूंगी दैट मीन्स फॉर अ मोनोएटॉमिक गैस, अगर मान लो मेरी मोनोएटॉमिक, मोनो मतलब सिंगल, मोनोएटॉमिक गैस की मैं बात कर रही हूँ तो इसका मतलब मेरा Ex प्लस Ey प्लस Ez इट विल बी 3. ट्रांसलेशन हो रही है तो मैं किसी काइनेटिक एनर्जी टाइप के टर्म की बात कर रही हूँ तो इसका मतलब इट कैन बी रिप्रेजेंटेड एज हाफ mu(x²) प्लस uy² प्लस uz². मैं इनको 3 अलग टर्म्स में भी लिख सकती हूँ, हाफ mu(x² प्लस हाफ mu(y² प्लस हाफ mu(z²). तो अगर मेरा एनर्जी, लॉ का समझ लो प्लीज, ये लॉ कहीं कोई नहीं पूछेगा, जो इसके आगे की चीज है वो पूछने वाली है. If your energy can be expressed as the sum of some energy terms, each of which is proportional to the square of the velocity, ठीक है, ठीक है, then each of these term contributes half kT energy. समझ आया कि मेरा लॉ ऑफ इक्विपार्टीशन ऑफ एनर्जी कहता है कि मेरा जो टोटल एनर्जी है ना, टोटल एनर्जी वो जितने मेरे सब एनर्जी टर्म्स हैं, अगर वो कोई वेलोसिटी टर्म के स्क्वायर को प्रोपोर्शनल है, वो भी छोड़ दो, सारे ईच टर्म कंट्रीब्यूट्स हाफ केटी एनर्जी. ये समझ आता है? लॉ ऑफ इक्विपार्टीशन को याद रखो कि कहता है कि ईच टर्म ऑफ एनर्जी नॉर्मली वो यू स्क्वायर के प्रोपोर्शनल होता ही है, क्योंकि काइनेटिक एनर्जी मोशन की बात कर रहे हैं हम, रोटेशनल मोशन, वाइब्रेशनल मोशन, ट्रांसलेशन मोशन, तो सारे काइनेटिक एनर्जी से रिलेटेड है. काइनेटिक एनर्जी की होती है हाफ एम यू स्क्वायर. तो ये सिर्फ ये लॉ कहता है कि एनर्जी इज अ सम ऑफ डिफरेंट एनर्जी टर्म्स, और हर एनर्जी टर्म इज प्रोपोर्शनल, इज कंट्रीब्यूटिंग हाफ kT टू द टोटल एनर्जी, where k is your Boltzman constant and T is the absolute temperature. तो फिर अगर मैं इधर इसकी बात कर रही हूँ, तो फिर मेरी मोनोएटॉमिक गैस की कंट्रीब्यूशन कितनी हो जाएगी? तो फिर मेरी टोटल मोनोएटॉमिक गैस की कितनी हो जाएगी? हाफ kT. 3 डिग्रीज ऑफ फ्रीडम है ना ट्रांसलेशनल, तो 3 ट्रांसलेशनल डिग्रीज ऑफ फ्रीडम का होगा हाफ kT प्लस हाफ kT प्लस हाफ kT. व्हाट इज दैट इक्वल टू? 3/2 kT. समझ आ गया? बस इतना याद रखना है, इससे ज्यादा नहीं. सिर्फ ये याद रखना है कि इस केस में मेरा एनर्जी टर्म, हर एक एनर्जी टर्म मेरा हाफ kT एनर्जी कंट्रीब्यूट करेगा. तो अगर मेरी डिग्रीज ऑफ फ्रीडम यहाँ पे 3 है, तो कंट्रीब्यूशन कितना होगा? 3/2 kT, क्योंकि हाफ 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 kT सबका. अगर मेरा रोटेशनल में लीनियर है, तो इसका कंट्रीब्यूशन अकेले में कितना होगा? हाफ kT प्लस हाफ kT, तो कितना? kT. इसका कितना होगा? 3/2 kT. समझ आ गया ये बात? और अगर वाइब्रेशनल होगा, तो वाइब्रेशनल में एक गड़बड़ है, क्योंकि इट इज अ टू एंड फ्रो मोशन, तो इट विल बी हाफ kT हियर, हाफ kT हियर, तो इट विल बी 1 kT पर वाइब्रेशनल डिग्री ऑफ फ्रीडम. हर एक एनर्जी टर्म है ना, तो kT. तो फिर अगर मैं लीनियर मॉलिक्यूल की बात करूं, लीनियर का टोटल टर्म वुड बी 3/2 kT प्लस kT प्लस 3n-5 kT. ये चीज समझ आ गई है? सिर्फ ज्यादातर मोनोएटॉमिक के लिए याद रखना दैट द एनर्जी कंट्रीब्यूशन शुड बी हाफ kT. वो हाफ kT एनर्जी देगा. अगर 3 डिग्रीज ऑफ फ्रीडम है, तो हाफ 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 तीनों देंगी, तो टोटल 3/2 kT. रोटेशनल की अगर 2 है, तो हाफ हाफ kT, तो टोटल kT. वाइब्रेशनल का ईच टर्म को हम kT मान के चलेंगे, तो इट विल बी 3n-5 इंटू kT. और ऐसे ही नॉन लीनियर का जल्दी से अपने आप लिख लो, 3/2 kT प्लस 3/2 kT प्लस 3n-6 इंटू kT. अब हम आते हैं एक नए टर्म पे, which is known as the heat capacity. What is heat capacity? Heat capacity, heat की बात कर रहे हैं, तो कुछ हीट की कितनी कैपेसिटी है हीट की? तो इट इज उतनी अमाउंट ऑफ हीट रिक्वायर्ड to raise the temperature of 1 gram of a substance by 1 degree Celsius. All right. So basically, if I'm talking about say a heat capacity C, अगर मेरी heat is Q, mc delta T, इसको ऐसे भी लिख सकते हो, ठीक है? This is the amount of heat required to raise the temperature of 1 gram by 1 डिग्री सेल्सियस. मतलब कितना डिफरेंस होना चाहिए? मान लो 273 है, तो 273 से उसको सॉरी डिग्री सेल्सियस बाय 1 डिग्री सेल्सियस बोल रही हूँ. मान लो इफ इट इज 25 डिग्री सेल्सियस, तो 25 से 26 डिग्री सेल्सियस करने के लिए मुझे कितनी हीट चाहिए 1 ग्राम ऑफ सब्सटेंस के लिए? दैट इज माय हीट कैपेसिटी, एंड दैट इज इक्वल टू, हीट कैपेसिटी कैन बी रिटन एज Q अपॉन m delta T. I repeat, this is a very important concept. Heat capacity is the amount of heat समझ के लिखो, नहीं तो मत लिखो, सिर्फ समझ लो. It is the amount of heat required to raise the temperature of mass है ये 1 gram of a substance by 1 degree Celsius. तो यूनिट्स इसकी खुद सोचो, ये मेरा कह रही हूँ, ये मेरा हीट कैपेसिटी. ठीक है, हीट कैपेसिटी की यूनिट्स क्या होंगी? मान लो अगर कैलोरी बोल रही हूँ मैं, मान लो हीट इन कैलोरीज, सो इट विल बी कैलोरीज पर ग्राम पर डिग्री सेल्सियस, या इसको कैलोरीज पर ग्राम पर डिग्री सेल्सियस, राइट? तो यूनिट्स तो आप अपने आप भी डिफाइन कर सकते हो अगर आपको फॉर्मूला और डेफिनेशन आती है. तो remember that heat capacity is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. अब यहाँ पे दो कॉन्सेप्ट आते हैं. Heat capacity at constant volume, which is equal to अगर 1 gram of substance हम मान के ही चल रहे हैं, तो heat capacity at constant volume will be the change in heat with change in temperature. एंड अभी आप थर्मोडायनेमिक्स में पढ़ोगे कि ये चेंज इन हीट इज नथिंग बट योर इंटरनल एनर्जी. सिर्फ ये अभी लिख के रख लो, ठीक है, जस्ट इन केस इफ यू गेट अ न्यूमेरिकल बेस्ड ऑन इट एट कांस्टेंट वॉल्यूम. दिस इज चेंज इन इंटरनल एनर्जी. इंटरनल एनर्जी वो एनर्जी होती है जो किसी भी सिस्टम के अंदर होती है. इट इज द एनर्जी पोजेस्ड. कई बुक्स में इसको ई भी लिखा हुआ है, तो यू कैन टेक इट एज डी बाई डी टी. अच्छा, व्हाट इज योर सीपी? दैट इज इक्वल टू dqp by dt. That is change in heat to change in temperature at constant pressure. ये at constant volume था, ये at constant pressure है, and that will be equal to dH by dt at constant pressure. Okay? इसके बाद एक और चीज जो पता होनी चाहिए, Cp प्लस Cv इज इक्वल टू R. Cp प्लस Cv इज इक्वल टू R. ओके, नाउ हियर अगर मेरे को Cv की बात करनी है फॉर अ मोनो एटॉमिक गैस, सिर्फ अपना इधर देखो प्लीज, ऑल ऑफ यू लुक नाउ. अब हमें क्या क्या पता है? मैंने जो अभी नई चीज कराई है वो एक कराई थी डिग्रीज ऑफ फ्रीडम. व्हाट इज डिग्रीज ऑफ फ्रीडम? मिनिमम नंबर ऑफ वेरिएबल्स रिक्वायर्ड टू डिफाइन द सिस्टम कंप्लीटली. नहीं याद हो रहा? कोई बात नहीं. मिनिमम वेरिएबल्स कौन कौन से हैं? ट्रांसलेशनल, रोटेशनल, वाइब्रेशनल. ट्रांसलेशनल मतलब सीधा ऐसे मूव करना. कितनी डायमेंशंस में सीधा मूव कर सकते हैं? 3. तो ट्रांसलेशनल 3 तो सबके हैं ही हैं. ऑलराइट. रोटेशनल में यू हैव आइदर लीनियर और नॉन लीनियर मॉलिक्यूल. अब अगर लीनियर मॉलिक्यूल है तो 2 साइड से रोटेट कर सकता है, और नॉन लीनियर है तो 3. और टोटल डिग्रीज ऑफ फ्रीडम 3n होते हैं. तो वाइब्रेशनल में मेरे जो भी बच गया 3n माइनस 5 फॉर लीनियर, और नॉन लीनियर में जितने बच गए 3n माइनस 6 फॉर नॉन लीनियर. अब ये तो मेरे हो गए डिग्रीज ऑफ फ्रीडम की अंडरस्टैंडिंग. अब मेरा लॉ ऑफ इक्विपार्टीशन ऑफ एनर्जी जो कोर्स में मेंशन नहीं है पर पता होना चाहिए कि जितनी मेरे डिग्रीज ऑफ फ्रीडम है सब एक एनर्जी टर्म से एसोसिएटेड है, और वो सब हाफ हाफ केटी कंट्रीब्यूट करेंगे. ठीक है, क्यों करेंगे? क्योंकि वो यू स्क्वायर के प्रोपोर्शनल है. वो नहीं समझ में आ रहा था किसी को, पर ये याद रखना हर डिग्री ऑफ फ्रीडम इज कंट्रीब्यूटिंग हाफ केटी एनर्जी. फिर अगर मैं मोनोएटॉमिक गैस की किसी की बात करूं, इफ आई टॉक अबाउट एनी मोनोएटॉमिक गैस, तो उस केस में मेरा ट्रांसलेशनल कितना होता है? 3 डिग्रीज ऑफ फ्रीडम. तो मेरा एनर्जी कितना हो जाएगा? एनर्जी कितना हो जाएगा? 3/2. ये मैंने ना यहाँ पे एक चीज गलत लिखी है. दिस इज Cp माइनस Cv इज इक्वल टू R, and nobody corrected me. Now you are smiling. Cp minus Cv is equal to R. All right. Now coming back to this, monoatomic का law of equipartition of energy के according क्या होता है? 3/2 kT. अगर ये 3/2 kT है तो मैं अपना Cv निकाल सकती हूँ. Cv is nothing but dE by dt. What is that then? 3/2. और अगर ये मेरा एवोगैड्रो नंबर 1 मोल के लिए है तो ये मेरा K क्या हो जाएगा? R, क्योंकि R by Na is my K. तो अगर मेरा ये K जो है ये बोल्ट्जमैन कांस्टेंट है, ये अभी मैंने इंट्रोड्यूस करा था 1.38 into 10 power minus 16 in ergs वाला यूनिट्स. सो R will be equal to K into Na. तो अगर मैं 1 मोल की बात करूं तो मेरी एनर्जी कितनी हो जाएगी 3/2 RT. And what will be my CV for 1 mole? It will be 3/2 R, क्योंकि CV क्या है मेरा DE by DT at constant V. तो ये क्या हो गया 3/2 R. अगर मेरा ये 3/2 R है तो मेरा CP क्या होगा, CP will be CV plus R. CP minus CV is equal to R. Please make the correction. I'm so sorry. I just wrote it by mistake. CP plus CV is equal to R initially. It is CP minus CV. Now it gives you all the more reason to remember कि मैंने गड़बड़ करी थी. So CP minus CV is equal to R. So now CP is equal to R plus CV. तो अब मेरा CP क्या होगा 3/2 R plus R which is equal to 5/2 R. और normally दोनों का ratio is a factor which is known as gamma. तो आप वो गामा भी निकाल सकते हो, that is Cp by Cv which in this case will be 5/3 which will be 1.667 or something. Just check it out. अब आप ये चीजें कैलकुलेट कर सकते हो क्योंकि आपको इस पे बेस्ड एप्लीकेशंस मिलेंगी. Just check it up quickly. I repeat. Heat capacity is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. तो एक फॉर्मूला जो याद रखने वाला है वो ये है कि Q is equal to MC delta T, where C is my heat capacity, heat, and this is amount of heat, mass, and this is the change in temperature. ठीक है. Then we talk about a specific heat capacity also, which is the amount of heat required to raise the temperature of one. Sometimes you talk in terms of molar heat capacity also and specific. Specific is of a fixed amount of gas. ठीक है, for a fixed amount. And when you talk about molar heat capacity, it is the amount of heat required to raise the temperature of 1 mole of a substance. Okay, then what we have here is we defined Cv, which is the heat capacity at constant volume. Cp is the heat capacity at constant pressure. Cv is change in heat upon change in temperature. ये तो हम देख ही चुके हैं. It is change in heat upon change in temperature for a fixed mass. So now it is dQV upon dt. dQV जो है वो हम thermodynamics में देखेंगे. That is nothing but dE. So this becomes dE by dt. अब मुझे dE निकालना आता है according to law of equipartition of energy. अगर मेरा मोनोएटॉमिक गैस में E आ रहा है 3/2 kT, तो 1 मोल के लिए वो 3/2 RT हो गया क्योंकि K into Na is R, so it is 3/2 RT. Now dE by dt is my CV which is 3/2 R. ठीक है. And then Cp is nothing but R plus CV. तो ये क्या हो गया 3/2 R plus R which is 5/2 R. और एक रेशियो टर्म होता है गामा which is the ratio of Cp and Cv. So gamma is equal to Cp by Cv which is equal to 5/3 which is equal to 1.67 for a monoatomic gas. तो monoatomic gases का generally gamma is constant which is 1.67. ऐसे ही आप डायटोमिक और ट्राइटोमिक का अपने आप निकाल के देखना. डायटोमिक मतलब your n is now equal to 2. तो n is equal to 2 मतलब 6 degrees of freedom. ट्रांसलेशनल 3 है ही है. लीनियर में मैंने क्या बोला है डायटोमिक के केस में डायटोमिक क्या होगा, डायटोमिक क्या होगा, नॉन लीनियर हो सकता है वो लीनियर ही होगा. तो फिर लीनियर के 2, वाइब्रेशनल के 1, क्योंकि 5 तो बाकी के हो गए, 3 ये 2 ये 1 ये, तो ये 6 हो गए टोटल. एंड नाउ यू कैन कंप्यूट द एनर्जी अकॉर्डिंग टू लॉ ऑफ इक्विपार्टीशन ऑफ एनर्जी. और अगर आपने एनर्जी निकाल ली तो आप अपना CV निकाल सकते हो, और अगर CV निकाल लिया तो CP निकाल सकते हो, और CP और CV निकाल लिया तो आप गामा निकाल सकते हो. क्लियर? डन. With this we get over with gaseous state. Now we move on to liquid state. Just remember these things. Now just to begin with liquid state. I hope you remember that liquids are something which are intermediate to those between. Liquid state is the one which is the intermediate to those of the gases and the solids. Now primarily we will be discussing only three things for the liquid state. There are three properties. पहले तो ये पता होना चाहिए that the forces of attractions are comparable to the thermal energy here. हमारे गैसेस के केस में क्या था, थर्मल एनर्जी आर मच ग्रेटर देन दी फोर्सेस ऑफ अट्रैक्शन, तो तभी वो इतनी दूर दूर मॉलिक्यूल्स होते हैं, दे आर हाईली कंप्रेसिबल. सॉलिड स्टेट में क्या होता है, फोर्सेस ऑफ अट्रैक्शन आर सो large that the molecules are just closely packed in comparison to thermal energy. They are in between. Liquids are in between. तो उनके ना अपने properties accordingly होते हैं. What are the three properties that we are going to discuss for the liquids? The three important properties that we will quickly discuss is first vapor pressure. All right. After vapor pressure, we will discuss surface tension, and we have another thing to discuss, that is your viscosity. All right. Now vapor pressure को समझाने के लिए सिर्फ it's only a qualitative concept that you have to understand in depth. When we talk about vapor pressure, मान लो आपने एक liquid लिया है vessel में, ठीक है, and then you have some free space in the vessel above. आपने लिक्विड ले लिया एक वेसल में, यू हैव सम फ्री स्पेस अबव, तो थोड़े टाइम में क्या होगा, सम ऑफ द मॉलिक्यूल्स ऑफ लिक्विड विल वेपराइज. वो वेपराइज करेंगे तो वो ऊपर चले जाएंगे. अब नाउ दे स्टार्ट एक्सर्टिंग, अब वेपर फॉर्म में होंगे तो दे विल कोलाइड विद द वॉल्स, तो कुछ अपना प्रेशर क्रिएट करना शुरू करेंगे. नाउ व्हेन दे स्टार्ट क्रिएटिंग दैट प्रेशर, देयर विल रीच अ स्टेज देन व्हेन द वेपर विल बी इन इक्विलिब्रियम विद द लिक्विड. This pressure at this, the pressure at this stage is known as the vapor pressure. I am repeating it once again. We have liquid filled in a vessel. All right. Vapor pressure का मतलब समझ लो. It is the pressure of the vapor of the liquid above the liquid in equilibrium with it. समझाने के लिए एक vessel लिया, we have filled it with liquid. अब थोड़े टाइम में क्या होगा, the liquid will start vaporizing. So the some molecules which are there above it will exert some pressure. स्लोली स्टेडली दैट प्रेशर एक टाइम पे आके कांस्टेंट हो जाएगा. जब वो प्रेशर कांस्टेंट हो जाता है तो उस प्रेशर को हम कहते हैं कि दैट इज योर वेपर प्रेशर. गॉट इट? ऐसा नहीं है कि अभी हमने लिक्विड भरा है तो इमीडिएटली वी नोट डाउन द प्रेशर एंड दैट प्रेशर इज नथिंग बट योर वेपर प्रेशर. इट विल बी दैट स्टेज जहां पे हमारा प्रेशर द वेपर will be in equilibrium with the liquid. मतलब जैसे अगर मैंने ये liquid लिया है तो this vapor has to be in equilibrium with the liquid and the pressure at this stage exerted by the vapor above the liquid in equilibrium with it is known as the vapor pressure. तो ये एक particular condition पे है that you will note down the vapor pressure. And how do you basically measure the vapor pressure? इसके अंदर कुछ points हैं that you can remember from examination point of view that you can actually check up the vapor pressure according to an equation which is given by Clausius-Clapeyron. इस equation को हम Clapeyron equation भी बोलते हैं, and that is rate of change of change of pressure with temperature is nothing but equal to delta H upon T delta V, where this delta V is nothing but that is the molar volume of the vapor minus molar volume of the liquid. Please make a note of it that according to Clapeyron equation that we can actually, it is kind of a measure of the vapor pressure, that is the change in pressure with respect to temperature can be checked up with molar heat of vaporization, delta HM vaporization upon T into Vm of vapor minus Vm of liquid. We are talking about the molar volume of vapor minus molar volume of liquid. इसको learn करने का easy तरीका ये है कि ये याद रखो, dP by dt is equal to delta H upon T delta V. Delta V क्या है? Volume of vapor minus volume of liquid. So dP by dt is equal to delta H upon T delta V. This is one thing that I wanted to tell you. The other thing is that वेपर प्रेशर तो आप समझ चुके हो कि क्या होता है, ठीक है। तो जब हम इम्प्यूरिटीज डालते हैं, सो वेपर प्रेशर डिक्रीजेस विथ एडिशन ऑफ इम्प्यूरिटीज, with addition of non volatile impurities। क्योंकि अगर मेरी नॉन वॉलेटाइल का मतलब क्या होता है, जो वेपराइज आराम से कर जाती हैं, ठीक है। तो अगर मैं अपने लिक्विड में कुछ नॉन वॉलेटाइल डाल रही हूँ, तो देन इन दैट केस आई क्लियरली नो दैट इफ आई एम एडिंग सम नॉन वॉलेटाइल सब्सटेंस, तो मतलब वो ऊपर नहीं उड़ेगा, वो वेपराइज नहीं होगा। तो अगर वो वेपराइज ज्यादा नहीं होगा तो वेपर प्रेशर ज्यादा नहीं क्रिएट होगा, तो देन इन दैट केस द वेपर प्रेशर विल डिक्रीज। और वेपर प्रेशर वही वाली स्टेज है जहां पे दे आर इन इक्विलिब्रियम विद द लिक्विड स्टेट। ओके, क्लियर विद दैट। Another thing that you have to remember, so ये एक question बहुत बार आता है, so just remember that vapor pressure decreases when your impurities, non-volatile impurities are added। volatile non-volatile का मैं मतलब समझा चुकी, ठीक है। And then another thing is, now your vapor pressure increases as temperature increases, ये भी understood है। vapor pressure increases as temperature इंक्रीजेस, क्योंकि अगर मेरा टेम्परेचर बढ़ेगा तो वेपराइज ज्यादा होगा, वेपराइज ज्यादा होगा तो वेपर प्रेशर बढ़ जाएगा, देन आई हैव टू then we have to actually have greater vapor pressure when you have more vapors on top of the liquid, ठीक है। इसके अलावा एक चीज ये है, you have to remember that when I am talking about vapor, that means I am talking about the conversion of liquid to vapor, conversion of liquid to vapor that normally happens with the process of evaporation। अब ये याद रखना कि evaporation और boiling same नहीं होता। evaporation is normally, it's just the conversion of liquid to vapor, it may be at any temperature, but what is your boiling point? boiling point is that temperature जहाँ पे हमारा जो vapor pressure, अब समझ आ गया, it is the pressure of the vapor of the liquid which is in equilibrium with the liquid। तो वो वाला जो वेपर प्रेशर जब मेरा एटमॉस्फेरिक प्रेशर के बराबर होता है, एक आसपास एटमॉस्फेयर भी तो है, जब एटमॉस्फेरिक प्रेशर के बराबर होता है तब उस टाइम पे माय बॉइलिंग पॉइंट इज अटेन्ड। सो व्हेन माय वेपर प्रेशर इज इक्वल टू एटमॉस्फेरिक प्रेशर, अब इसमें भी व्हेन माय एटमॉस्फेरिक प्रेशर इज 1 atmosphere, this is the normal pressure, right? normal pressure is 1 atmosphere। तो जब मेरा 1 atmosphere pressure होता है तो मैं boiling point को बोलती हूँ normal boiling point, और जब मेरा 1 bar pressure होता है तो I call it standard boiling point, ठीक है। this also is mentioned in your NCERT, so you have to know this also। so if my atmosphere is 1 atmosphere, then in that case I call it normal boiling point, ठीक है। और अगर मेरा pressure is 1 bar, then I call it standard boiling point। ये चीज भी, like for example water का example उन्होंने दे रखा है, the normal boiling point you know is 100 degrees Celsius, this is the normal boiling point, और standard boiling point is 99.6, check कर लेना, it's given in your NCERT, it is 99.6 degrees Celsius। okay, so with this I cover up the topic of vapor pressure। जो ज्यादा आपको याद रखने वाली बात ये है कि वेपर प्रेशर होता क्या है, इट इज नाउ नॉर्मली व्हेन यू हैव लिक्विड्स ऑन स्टैंडिंग पोजीशन वेपराइज अ बिट, उसके ऊपर जो भी वेपर होता है वो थोड़ा थोड़ा प्रेशर क्रिएट करना शुरू करता है, बट उस प्रेशर को हम वेपर प्रेशर तब तक नहीं बोलते जब तक वो वेपर इक्विलिब्रियम में नहीं आता विद लिक्विड। और वो लिक्विड बॉइल कब करेगा, जब ये वाला वेपर प्रेशर इज इक्वल टू माय एटमॉस्फेरिक प्रेशर। pressure means the same meaning as you understand of pressure, ठीक है। तो जब मेरा atmospheric pressure is equal to vapor pressure, okay, then what we have is when pressure is 1 atmosphere, तो उस boiling point को हम कहते हैं normal boiling point। when pressure is 1 bar, तब हम उसको कहते हैं standard boiling point। और water का example is given in your book। then you have to remember, अगर मैं अपनी liquid में non volatile impurities डालूंगी तो मेरा वेपर प्रेशर कम हो जाएगा, रीजंस एक्सप्लेन्ड। अगर मैं टेम्परेचर इंक्रीज करूंगी तो मेरा वेपर प्रेशर भी इंक्रीज हो जाएगा। क्लियर। नाउ वी मूव ऑन टू द नेक्स्ट प्रॉपर्टी व्हिच इज सरफेस टेंशन। अब सरफेस टेंशन को समझने के लिए जस्ट लुक ऑन टू द बोर्ड फॉर अ व्हाइल। अगेन सरफेस टेंशन इज द प्रॉपर्टी ऑफ लिक्विड्स. जो मैं बोल रही हूँ, अगर मेरा लिक्विड्स है यहाँ पे, तो मेरे कुछ मॉलिक्यूल्स टॉप पे है और कुछ बहुत सारे मॉलिक्यूल्स बल्क में है. बल्क मतलब अंदर वाले. जो अंदर वाले हैं वो तो हर डायरेक्शन में मूव कर रहे हैं, तो उनका फोर्स ऑफ अट्रैक्शन इज देयर इक्वल इन ऑल द डायरेक्शंस, राइट. जो बल्क में है मॉलिक्यूल्स, उनका तो अट्रैक्शन हर तरफ है, लेकिन जो सरफेस वाले हैं दे आर बीइंग पुल्ड. ठीक है, they are pulled by the molecules due to the forces of attraction. They are being pulled, so there is some kind of a tension created on the surface. ये समझ में आ गया. टेंशन का मतलब वही टेंशन ही होती है, बट और सरफेस पे है तो surface tension. The meaning is as it is there in the words, but definition wise आपको ये याद रखना है, it is the force acting per unit length. ठीक है. What is surface tension? It is force acting per unit length on the surface at any line which is imaginarily drawn perpendicular to it. एक हम perpendicular line surface पे मान लेंगे, तो उसमें हम सोचेंगे कि unit length उसके अंदर जितना force लग रहा है, that is my surface tension. It is the force acting per unit length along the line drawn perpendicularly to it at any line along any point of the surface. It is the line which is perpendicularly drawn along the surface and of unit length. तो जितना force उस time पे लगेगा. अच्छा, अगर surface tension is force acting per unit length at any line acting perpendicularly along the surface, then units क्या होंगी? Force के units Newton per meter. अच्छा, अगर अब मेरा सरफेस टेंशन की वजह से नॉर्मली क्या होता है, मेरा कैपिलरी एक्शन भी होता है. जैसे मान लो ये मेरा कैपिलरी है, तो मैं कैपिलरी लिक्विड में इंसर्ट करती हूँ ना, या तो पानी ऊपर उठ जाता है या वो नीचे भी चला जाता है कई बार. वेरी गुड. ठीक है, तो अगर हम जब कैपिलरी एक्शन देखते हैं तो कई बार आपने देखा है मेनिस्कस कई बार ऐसे अपर मेनिस्कस होता है, कई बार लोअर मेनिस्कस होता है. All these forces are dominated by certain factors which are known as cohesion and adhesion. These are the forces. What are cohesive forces? These are the forces acting between the particles of the same substance. जैसे liquid liquid हो गया, या liquid particles of the molecule of the same. What is adhesion? What is the best adhesive that you know? You have many adhesives. Glue stick, without taking the names of the brands, because we are not publicizing any. ठीक है, तो अगर कोई भी आपको glue stick के brands पता है, वो सब क्या है? Adhesive, क्योंकि it's a liquid which is helping you in pasting solid. So it is like holding your solid with it together. So that is kind of an adhesive force. So these are the forces which actually, when your cohesive forces are more, then you have some kind of a depression. When you have adhesive forces to be more, there is some kind of an elevation. But capillary action क्या होता है? Which makes your liquid either rise or fall. जैसे कई बार ये क्वेश्चन होता है, आई वॉज जस्ट गोइंग थ्रू द क्वेश्चंस. एक क्वेश्चन था कि एक टावल एक तरफ से डिप करके रखा, विच इज ऑब्वियस. ये तो अगर किसी ने साइंस नहीं भी पढ़ी वो भी बता देगा, बट जस्ट बाय ऑब्जर्वेशन आपने टावल डिप करके रख दिया, आप रात को सो गए, सुबह उठोगे तो फिर पूरा टावल गीला होगा या उतने का उतना ही डिप्ड होगा, डिपेंडिंग अपॉन कितना बड़ा टावल है. हाउ कैन यू बी सो नॉन साइंटिफिक? इतना तो सबको पता है ना कि यू एक्चुअली हैव टू लुक एट ऑल द पैरामीटर्स. कोई और बोलता तो मुझे समझ में आता, बट इफ यू से दैट पूरा गीला हो जाएगा, नहीं समझ में आता. तो डिपेंड्स अपॉन द लेंथ एंड द स्पीड. सो एनीवेज वी आर टॉकिंग अबाउट सरफेस टेंशन. वो गीला क्यों होगा? टू मोर एक्सटेंट. व्हाई? बिकॉज ऑफ द कैपिलरी एक्शन. ये चीज याद रहेगी. It will be gila mainly because of capillary action. Acha, then when we are talking about surface tension, there are a few more parameters that you need to know. Surface tension is normally represented by a term which is known as gamma. ठीक है, फोर्स एक्टिंग पर यूनिट लेंथ तो हमने देख लिया. इसका एक फॉर्मूला होता है, दैट इज हाफ इंटू एच कैपिलरी एक्शन में रो जी इंटू आर. सो इसको याद कर लो, इट इज एच रो जी आर बाई 2. H rho G R by 2. You say it 3 times in your heart and you will memorize it right now. जब तक मैं इसको explain करती हूँ. H will be the height to which the liquid has raised or fallen, depending upon what are we talking about. Rho is the density of the liquid. G is the force of gravity. R is the radius of the capillary. ठीक है, तो इधर हम basically we are talking about the capillary. So what we have is the gamma, which is the surface tension, coefficient of surface tension, that is nothing but equal to H rho G R, ये R है, gamma नहीं है, R by 2. Another force of acting for surface tension is 2 pi R, which is the circumference into gamma. ये हम नॉर्मली सरफेस टेंशन के लिए एक डिवाइस यूज करते हैं, दैट इज नोन एज, एक तो कैपिलरी हो गई यहाँ पे H rho GR by 2, एक और इंस्ट्रूमेंट यूज करते हैं दैट इज कॉल्ड स्टिलैग्मोमीटर. वेरी गुड. वी हैव वन टर्म व्हिच इज नोन एज स्टिलैग्मोमीटर. किसने बनाया था ये? ट्रॉब ने. TRAUBE. That is the name of the scientist who devised it. It looks something like this. ऐसे एक vertical होता है, then you have a pipe, bulb, and then you have here you have a small capillary going in within. इसी के अंदर एक छोटी सी कैपिलरी अंदर से जा रही होती है, and then what we take is, प्लीज इसको जल्दी से समझ लो, surface tension means what? We are creating a surface. अब normally हम कहते हैं liquids flow. If liquids flow and they take the shape of whichever container we put it in, ठीक है, हम लिक्विड को अगर किसी कंटेनर में डालते हैं वो उसी की शेप ले लेते हैं, बट एज सच रेन ड्रॉप्स आर स्फेरिकल, मोर और लेस स्फेरिकल इन शेप. मर्क्यूरी, अगर कभी किसी ने थर्मोमीटर तोड़ा है तो मर्क्यूरी ग्लोब्यूल्स हमेशा क्या होते हैं? स्फेरिकल. दे आर ऑलवेज राउंडेड. तो वो ऐसे स्प्रेड क्यों नहीं होते? अगर लिक्विड्स टेक द शेप तो नीचे तो कोई शेप ही नहीं है, दे शुड गो राउंडेड. दैट इज ओनली बिकॉज ऑफ सरफेस टेंशन. क्योंकि अगर वो स्प्रेड हो गया तो जितने भी बल्क के मटेरियल है वो अपनी तरफ खींचते हैं उसको, बिकॉज ऑफ विच दे बिकम स्फेरिकल. सो एनीथिंग व्हिच इज रिजल्टिंग इन द स्फेरिकल शेप ऑफ द लिक्विड्स, इट इज सरफेस टेंशन. ये याद रखना अभी इस पॉइंट पे. तो अब हम इसमें क्या करते हैं, आई विल जस्ट टेल यू क्विकली. ये स्टिलैग्मोमीटर में हम कोई भी लिक्विड भरते हैं टिल अ पर्टिकुलर लेवल एंड देन वी अलाउ इट टू फॉल, और उसको हम फॉल इस तरीके से कराते हैं, ये ड्रॉप बाहर निकल रही है, लग नहीं रही होगी, but then this is a drop coming out of it. Okay, now when it is falling through this, after passing through this capillary, this drop we want that the drop should fall for the full size. और इसमें हम इक्वेशन यूज करते हैं कि वो ड्रॉप तब गिरे when my force क्या होता है? mass into g mg. when my force which is making it fall is equal to the force of surface tension. क्योंकि सरफेस टेंशन की वजह से वो पूरी गोल बनेगी, तो हम उसका रेट स्लो रखते हैं. ऐसे नहीं, अगर जल्दी करेंगे तो वो तो स्ट्रीमलाइन वे में गिर जाएगा पानी सारा. यहाँ पे वी हैव अ पिंच कॉक और वी हैव अ नॉब समटाइम्स. ऑलराइट, वी कंट्रोल ब्यूरेट. ठीक है, ब्यूरेट से जैसे कंट्रोल करते हैं वैसे इसको कंट्रोल करते हैं. तो वी मेक श्योर दैट द ड्रॉप फॉर्म्स कंप्लीटली, सो देन द फोर्स व्हिच इज मेकिंग इट फॉल should be equal to the force of the surface tension. So that means ये force of surface tension is what? 2 pi r is the circumference of the drop that we have, surface of the drop. All right, it's some kind of a circular, so we call it 2 pi r. Into gamma is the coefficient of surface tension, and then this force can be equated to your mg. So this is another equation that we can use. अच्छा, अब इसको find out कैसे करेंगे? क्योंकि मुझे मास उस ड्रॉप का मैं निकाल लूंगी, जो भी ड्रॉप है, और उसको किसी चीज से कंपेयर कर लूंगी. मान लो मेरा एक लिक्विड है, गिवन लिक्विड, मैंने इसको गिवन लिक्विड के साथ करा, तो मेरी इक्वेशन मान लो गिवन लिक्विड इज L, सो इट विल बी mLg into 2 pi r into gamma of L. 2 pi r तो it will be according to the stalagmometer. फिर मैं पानी का करती हूँ इसके साथ, क्योंकि पानी की सरफेस टेंशन की वैल्यूज आर अवेलेबल, तो आई टेक इट एज अ रेफरेंस लिक्विड. तो मैं अगर पानी के साथ करूंगी तो व्हाट विल बी द इक्वेशन? मास ऑफ 1 ड्रॉप ऑफ वाटर, क्योंकि फिर वाटर गिरेगा, इनटू जी. 2 pi r will remain the same क्योंकि स्टिलैग्मोमीटर सेम है, तो जितना ड्रॉप उससे बनेगा नीचे, that will also be the same, so that will be equal to 2 pi r into gamma w. तो अगर मैं इन दोनों का रेशियो लूंगी तो मेरे पास आ जाएगा ml by mw is equal to gamma l by gamma w. तो अगर मुझे सरफेस टेंशन ऑफ वाटर पता है, मास मैं निकाल सकती हूँ. वी हैव इलेक्ट्रॉनिक बैलेंसेस जिससे हम मास मेजर कर सकते हैं, ठीक है। तो मास हम फाइंड आउट कर सकते हैं, गामा डब्ल्यू हमारे पास लिटरेचर में अवेलेबल है, तो हम किसी भी अननोन लिक्विड का सरफेस टेंशन फाइंड आउट कर सकते हैं। और सरफेस टेंशन होता क्या है, टेंशन ऑन द सरफेस, some force acting per unit length along a line which is perpendicularly drawn along the surface. Okay, so there are 2 points. Surface tension का सबसे पहले आपको पता होना चाहिए, it is force acting per unit length, units न्यूटन पर मीटर, ठीक है। एक और यूनिट्स होती है इसकी, that is kilograms per second square, ये भी याद रख लो, that is kilograms per second square, ठीक है। और दो फोर्सेस के बारे में पता होना चाहिए, कोहेसिव फोर्सेस आर बिटवीन सेम टाइप, adhesive forces are between different types. Then you have gamma is equal to h rho gr by 2, h rho gr by 2, and the other is force is equal to 2 pi r gamma, वो तो बहुत ही easy है, 2 pi r gamma is equal to f which can be equated to your mg. और मैंने बताया कि अगर ये याद है तो आप कंपेयर करके सरफेस टेंशन ऑफ लिक्विड निकाल सकते हो, that is ml by mw is equal to gamma l by gamma w. इधर एक और कॉन्सेप्ट रह गया, that is the concept of surface energy. सरफेस एनर्जी और सरफेस टेंशन के यूनिट सेम ही होते हैं, लेकिन इस केस में जैसे अब मेरा सरफेस टेंशन क्या है, इट इज फोर्स एक्टिंग पर यूनिट लेंथ, ठीक है। अगर मैं इसको एक और डिस्टेंस से मल्टीप्लाई कर दूं, ऑलराइट, व्हाट इज फोर्स इनटू डिस्टेंस, दैट इज वर्क डन, फोर्स इनटू डिस्टेंस फिजिक्स में पढ़ा है आपने, फोर्स इनटू डिस्टेंस इज योर वर्क डन, व्हाट इज एल इनटू डी, दैट विल बी से एल इनटू एल, और से अगर मैं इसको एल से मल्टीप्लाई कर दूं तो फोर्स इनटू सम डिस्टेंस एल विल बी योर वर्क डन, व्हाट इज योर एल इनटू एल, दैट इज एरिया, सो वर्क डन पर यूनिट एरिया इज योर सरफेस एनर्जी। आपको सरफेस टेंशन समझ में आ गया, व्हाट इज योर सरफेस टेंशन, इट इज फोर्स एक्टिंग पर यूनिट लेंथ, ये मेरा सरफेस टेंशन था, मैंने न्यूमरेटर डिनोमिनेटर को एल और एल से मल्टीप्लाई कर दिया, सो देन इन दैट केस आई गेट फोर्स इनटू डिस्टेंस इज योर वर्क डन एंड एल इनटू एल इज योर एरिया। सो अब इसको समझ लो कि सरफेस एनर्जी क्या होती है। अब कोई टेंशन क्रिएट हुई, ठीक है, तो मेरा सरफेस मिनिमाइज हो गया क्योंकि वो खिंच गया, तो सरफेस थोड़ा सा मिनिमाइज हो गया। अब उसको अगर मेरे को यूनिट एरिया से एक्सपैंड करना है, वो मिनिमाइज हुआ, श्रिंक हो रहा है ना सरफेस, अब अगर मुझे उसे यूनिट एरिया से एक्सपैंड करना है तो मुझे काम करना पड़ेगा, और वो जितना काम करना पड़ेगा दैट इज माई सरफेस एनर्जी। अगर मुझे उसे 1 मीटर स्क्वायर से एक्सपैंड करना है तो जितना वर्क डन होगा उतना ही मेरा सरफेस एनर्जी होगा, तो माई सरफेस एनर्जी विल बी वर्क डन in expanding the surface area by 1 meter square or by unity. It is surface energy now is nothing but it is defined as work done to expand my surface by a unit area. The units of surface tension and surface energy are the same. The only thing that you need to understand is like surface energy में हम सिर्फ एक LL का factor introduce करते हैं, तो this can also be written as joule per meter square, where joules are the units of your energy and meter square for area. Okay, next we talk about the concept of viscosity. Next we talk about the concept of viscosity. अब viscosity क्या होता है, उसको viscous force होता है, viscous force क्या होता है, जैसे अगर मेरा liquid move कर रहा है, now I have the liquid moving in different layers, ठीक है, तो अब एक लेयर जिस भी स्पीड से मूव कर रही है, the other layer will definitely try to compete with it, so it will drag the pull of the other, it will drag or pull the force of the other layer, so it is some kind of an internal resistance to flow. Any kind of resistance offered by the liquid to flow of the liquid is known as viscosity. Viscosity का मतलब समझ में आया, जो भी हमारे एक लिक्विड के फ्लो को रोकने की कोशिश करेगी, so that is what is known as viscosity. मैथमेटिकली तो एक बार अगर आपने फॉर्मूला याद कर लिया, डिफाइन करना इजी हो जाता है, ठीक है। इट इज सम काइंड ऑफ अ रेजिस्टेंस ऑफर्ड टू द फ्लो ऑफ द लिक्विड, तो ये समझ में आया, हमारे पास डिफरेंट लेयर्स होती हैं which are moving with different speeds. So say whatever is the speed of this, the others will try to rid reduce the speed because they'll try to offer resistance or resist. Okay, now this force of resistance will be directly proportional to the area of contact between the two layers. जैसे मान लो हमारे पास different layers हैं, ये layers infinite है, मतलब depending upon your experimental setup, पर मैं एक area of contact बना रही हूँ. मान लो this is moving with the speed u, ठीक है, this is moving with the speed u plus du, du मतलब a small change in velocity, and this is moving with the speed of u minus du. Let the area of contact, कि कितना area है दोनों के contact में, let that be a, ठीक है. So and let the distance between the two layers be dz or dx in some of the books. So let that be dz, and then now we can actually state that the force acting between the two layers is directly proportional to the area of contact, and it is also proportional to the velocity gradient. Velocity gradient means du by dz. It is also directly proportional to velocity gradient. So that means my force acting between the two layers is directly proportional to A into du by dz. And when I actually remove the proportionality sign, I get a constant which is the coefficient of viscosity eta. This is the coefficient of viscosity eta into A into du by dz. So now viscosity can also be defined as the force acting between two layers per unit area per unit velocity gradient. ठीक है, viscosity को define करने के लिए you can say that it is the force acting per unit area per unit velocity gradient. जो इसकी normal units होती हैं that are Newton meter minus 2 seconds. The units of coefficient of viscosity, the SI units are Newton per meter square into second, or they can also be written as kilogram per meter per second. They can also be written as kilograms per meter per second. Another thing that you have to remember is like there is a law which is known as the Stokes law. Force is equal to 6 pi eta RV. RV. Where force, that is again the viscous force that we are talking about, is equal to 6 into pi is a constant 3.14, eta is the coefficient of viscosity, r is the radius, all right, and v is the velocity with which your solid substance is like falling within the liquid. Okay, this is your Stokes law. Then there is another equation which is known as the Poiseuille's equation, which again is very important, which states that your coefficient of viscosity is equal to pi pt r to the power 4 upon 8 lv. I will just explain the terms. Coefficient of viscosity is equal to pi pt r to the power 4 upon 8 lv. Please understand the terms. Eta is the coefficient of viscosity, pi is a constant 3.14, p is the pressure head which is maintained. जब आपका लिक्विड किसी भी ट्यूब से, जैसे सरफेस टेंशन के लिए हमने स्टिलैग्मोमीटर यूज किया था ट्रॉप का, इस केस में भी हम इस इक्वेशन को यूज करके वी कैन यूज, ऑस्टवर्ल्ड ने एक बनाया था डिवाइस और एन इंस्ट्रूमेंट व्हिच इज नोन एज विस्कोमीटर. Viscometer looks something like this. Not really good in drawing, but then you can just check it for yourself. इस ऐसा कुछ दिखता है विस्कोमीटर. ओके, बहुत खराब डायग्राम है इसीलिए बहुत ज्यादा ध्यान से देखने की जरूरत नहीं है. So what we have is we fill in liquid from one of the ends, alright. और जब हम liquid fill कर लेते हैं इसके अंदर, मतलब यहाँ से हम डालते हैं तो क्या होगा, यहाँ से तो we can use a pipette or something to pour in liquid from here. फिर यहाँ पे इसको यहाँ से ऊपर खींचते हैं liquid को and then we allow it to fall. सेम की, पर इसके अंदर हम दो मार्क्स बना लेते हैं. फिर इन दो मार्क्स के बीच में देखते हैं कि कितना टाइम ऑफ फ्लो है। अब ये देख लो, P इज द प्रेशर हेड। हम नॉर्मली प्रेशर हेड को कांस्टेंट रखते हैं क्योंकि एक ही विस्कोमीटर यूज करते हैं फॉर वन सेट ऑफ एक्सपेरिमेंट, ठीक है। तो P इज फॉर द प्रेशर हेड व्हिच इज H rho G. What is P? That is the pressure. H into density into the force of gravitational constant, that is G, acceleration due to gravity. Then you have P which is pressure. T is the time of flow. टाइम ऑफ फ्लो बिटवीन अ पर्टिकुलर रेंज, वो मैंने बता दिया कि 2 मार्क्स होते हैं, फिर हम उसी के बीच में मॉनिटर करते हैं। R is the radius of the capillary that it is falling through, which again remains constant for viscometer. L is the length through which you are making the liquid flow. V is the velocity. ठीक है, I repeat, एक हमने करी थी स्टोक्स लॉ where force is equal to 6 by eta RV. अभी आप जो एक्सपेरिमेंट स्कूल में करते हो, that is according to Stokes law only. Do you do it? You make some balls fall through a long cylindrical this thing. So force is equal to 6 by eta RV. ये याद रखना, मतलब एक हर टर्म का पता होना चाहिए. That is Stokes law. Poisson's equation is eta is equal to pi pt r to the power 4 upon 8 LV, जहाँ पे P is your pressure head, T is your time of flow, R is the radius of the capillary, L is the length through which your liquid is flowing, V is the velocity. अब होता क्या है, what is the instrument called? That is called the viscometer. अब इस केस में भी अगर मेरे को किसी अननोन लिक्विड का विस्कोसिटी निकालना है तो मैं विस्कोमीटर यूज करूंगी, ठीक है। तो ईटा ऑफ एल निकल आएगा और मैं एक बारी विस्कोमीटर यूज करूंगी पानी के लिए, क्योंकि वाटर इज यूज्ड एज अ रेफरेंस लिक्विड फॉर विच वैल्यूज आर नोन. सो कोएफिशिएंट ऑफ विस्कोसिटी ऑफ वाटर इज नोन टू मी. किसी अननोन लिक्विड का मुझे अगर निकालना है तो उस केस में अगर मैं ईटा एल बाई ईटा डब्ल्यू करूं तो मेरा प्रेशर हेड सेम रहेगा क्योंकि मैं सेम विस्कोमीटर यूज करूंगी. इफ आई यूज द सेम विस्कोमीटर देन दिस विल रिमेन सेम. My R, radius of the capillary through which it is falling, will remain the same. My length will remain the same. My pi pt r to the power 4. Now here I have another term which is H rho G. Now height through which it is falling remains the same. G is a constant, remains the same, but not density. Density of the liquid will vary. ठीक है, तो इधर दिस इज पाई पी टी आर टू द पावर 4 ना, तो व्हाट इज दैट प्रेशर? दैट इज H into rho into G. तो इसका मतलब मेरा रो ऑफ लिक्विड विल मैटर एंड टाइम ऑफ फ्लो विल आल्सो मैटर. सो इट विल बी रो एल टी एल अपॉन रो डब्ल्यू टी डब्ल्यू. बाकी सारे टर्म्स कैंसिल आउट हो जाएंगे. जब मैं रेशियो लूंगी तो बाकी सब टर्म्स कैंसिल आउट होंगे, सिर्फ मेरा रो एल टी एल बाय रो डब्ल्यू बाय एंड टी डब्ल्यू दे विल बी लेफ्ट. ठीक है, clear to everyone? I repeat it again. So eta L by eta W will be dl TL by dw tw. d मेरा density, t मेरा time of flow. बाकी length same है, मेरा height same है, g same है, r same है, pi constant है, v velocity है. ठीक है. So now with this I think we sum up the viscosity thing also. अब viscosity में एक चीज याद रखनी है, that the viscosity of the liquid will increase as temperature decreases. ऐसा क्यों? And surface tension also decreases as temperature increases. For the liquid, अभी हम सिर्फ liquids की बात कर रहे हैं. Please make it a point कि temperature increase होगा तो surface tension of liquid will decrease and viscosity of the liquids will also decrease. Viscosity is very easy to understand. टेम्परेचर बढ़ेगा तो मेरे मॉलिक्यूल्स विल बी मोर फ्री. जब वो मोर फ्री होंगे तो फ्लो एनीवे ज्यादा ही होगा एंड देयर विल बी लेस रेजिस्टेंस ऑफर्ड, तो विस्कोसिटी ऑटोमेटिकली कम हो जाएगी. एक चीज ये है. एंड देन देयर आर टू टाइप्स ऑफ लिक्विड्स. एक होते हैं एसोसिएटेड और एक होते हैं नॉन एसोसिएटेड. जो एसोसिएटेड लिक्विड्स होते हैं वो होते हैं जो हाइड्रोजन बॉन्डिंग कर रहे होते हैं. एसोसिएटेड लिक्विड में नॉर्मली देयर इज अ हाइड्रोजन बॉन्डिंग फैक्टर, ठीक है. और नॉन एसोसिएटेड वो होते हैं जिनमें कोई बॉन्डिंग फैक्टर एज सच नहीं होता. तो अगर मैं अल्कोहल क्या होते हैं? C2H5OH, ये अल्कोहल है. तो दे आर एसोसिएटेड लिक्विड्स और ईथर है जो ROR टाइप होते हैं, दे आर नॉन एसोसिएटेड। और जितने ज्यादा हाइड्रोजन बॉन्ड फॉर्म हो सकते हैं उतनी ज्यादा मेरा विस्कोसिटी और विस्कस टेंडेंसी होगी। ठीक है, हाइड्रोजन बॉन्डिंग एसोसिएटेड लिक्विड्स में होती है, जितनी ज्यादा हाइड्रोजन बॉन्डिंग होगी उतना ज्यादा मेरा लिक्विड विस्कस होगा। तो दैट मीन्स विस्कोसिटी ऑफ द एसोसिएटेड लिक्विड्स विल बी ग्रेटर देन द विस्कोसिटी ऑफ द नॉन एसोसिएटेड लिक्विड्स। इज दैट क्लियर टू एवरीवन? Viscosity of the associated liquids will be much greater than the viscosity of the non-associated liquids. And इस केस में अगर मैं ईथर और अल्कोहल को कंपेयर करूं तो viscosity of ethanol will be more. अच्छा, if I compare, इनके ना कुछ के फॉर्मूले आपको लर्न भी करने पड़ेंगे when you do organic also. इथिलीन ग्लाइकॉल और अगर मैं ग्लिसरॉल देखूं तो इथिलीन ग्लाइकॉल होता है CH2OH एंड CH2OH और ग्लिसरॉल में 3 OH होते हैं, CH2OH, CHOH एंड CH2OH। तो इस केस में सबसे ज्यादा विस्कोसिटी किसकी होगी? ग्लिसरॉल, क्योंकि उसमें हाइड्रोजन बॉन्डिंग बहुत एक्सटेंसिवली होगी। तो जितनी ज्यादा हाइड्रोजन बॉन्डिंग उतनी ज्यादा विस्कोसिटी। नाउ आई क्विकली रिपीट विस्कोसिटी वंस अगेन, प्लीज लुक अप ऑन टू द बोर्ड। विस्कोसिटी में सिर्फ ये याद रखना है that the force acting in the viscous flow is equal to eta A into du by dz। यहाँ से आप विस्कोसिटी डिफाइन कर सकते हो that is nothing but the force acting per unit area per unit velocity gradient, units न्यूटन मीटर माइनस टू सेकेंड। दूसरा एक और यूनिट भी याद रखो क्योंकि कुछ भी दे रखा हो सकता है, किलोग्राम पर मीटर पर सेकेंड। ठीक है, उसके बाद सर्फ, ये तो सरफेस टेंशन में क्या था, then what we have is in this Stokes law that force is equal to 6 pi eta RV, and what we have is Poiseuille's equation also that eta is equal to pi pt r to the power 4 upon 8 LV, and what is your pressure? H into D into G या H rho G, जो भी आप लिखते हो। जब हम उससे निकालेंगे तो विस्कोमीटर वाला मेथड यूज करके तो बाकी सब चीजें कांस्टेंट हो जाएंगी। H कांस्टेंट, मेरा R कांस्टेंट, L कांस्टेंट, V कांस्टेंट, रह जाएगा सिर्फ मेरा एक तो डेंसिटी एंड टाइम ऑफ फ्लो। टाइम ऑफ फ्लो ही हमने देखना है, वही एक्सपेरिमेंट है कि हम पानी एक तरफ से भरेंगे, दूसरी तरफ हम देखेंगे कितना टाइम लग रहा है बिटवीन द टू एच्ड मार्क्स। 2 मार्क्स हैं, उनके बीच में कितना टाइम लग रहा है। तो दैट वेज मेरे को TL पता चल जाएगा, TW भी पता चल जाएगा। एक बार पानी से करेंगे, एक बार लिक्विड से करेंगे। डेंसिटी कैन ऑल्सो बी फाउंड, डेंसिटी कैन बी फाउंड दैट अगर मैं वॉल्यूम सेम रख के मासेस लूंगी तो मेरे को डेंसिटी का रेशियो पता चल जाएगा। ठीक है, एंड व्हाट इज योर ईटा डब्ल्यू? दैट इज द विस्कोसिटी ऑफ वाटर एट अ पर्टिकुलर टेम्परेचर। ठीक है, फिर वो हम निकाल लेंगे एंड ईटा एल हमें यहाँ से मिल जाएगा। सो ईटा एल बाय ईटा डब्ल्यू विल बी DL TL बाय DW TW, एंड ये याद रखना है कि टेम्परेचर इंक्रीज करेंगे तो विस्कोसिटी डिक्रीज होगी। ठीक है, एंड ऐसे ही सरफेस टेंशन के केस में टेम्परेचर इंक्रीज करेंगे तो सरफेस टेंशन डिक्रीज हो जाएगी। अब जब ये होगा तो इस केस में हमें एक और चीज याद रखनी है। सरफेस टेंशन के लिए मैं अगर बात कर रही हूँ तो आई जस्ट लेफ्ट वन मोर डिस्कशन विद यू हियर। सरफेस टेंशन में हमने सरफेस एनर्जी कर लिया। व्हाट इज सरफेस टेंशन? फोर्स एक्टिंग पर यूनिट लेंथ। व्हाट इज सरफेस एनर्जी? एज गुड एज सरफेस टेंशन ओनली, it is the work done to increase the unit, work done in increasing the area by 1 unit, so that is joules per meter square। and इधर surface tension के केस में the units are Newton per meter क्योंकि force acting per unit length, और in terms of kilogram it will be kilogram per second square, but check it once। then when we have for surface tension here is that there are some substances which are known as surface active substances। surface active substances वो होते हैं which work by lowering the surface tension of water। ठीक है, मैं बताती हूँ कैसे। what happens is surface active substances होते हैं जैसे डिटर्जेंट्स, सब डिटर्जेंट्स अपने घरों में यूज करते ही हो। तो when you add detergents to water तो वो क्या करते हैं, वो they accumulate normally on the surface, they accumulate on the surface। अब अगर सरफेस पे ज्यादा मॉलिक्यूल्स होंगे तो अंदर की सरफेस की टेंशन कम हो जाएगी। अभी टेंशन क्यों है? क्योंकि अंदर वाले पार्टिकल्स surface वालों को नीचे drag करते हैं. That is what is the surface tension mainly due to. But if they accumulate onto the surface, then the surface tension would decrease. All right. And if the surface tension would decrease, they reduce one term which is known as interfacial tension between grease and interfacial. Surface tension सबको समझ में आया? Surface की tension है जिसकी वजह से and that is basically due to the pull of the molecules from within the surface, within the bulk. बल्क वाले जब ऊपर वालों को खींचते हैं तो सरफेस टेंशन क्रिएट होता है. इंटरफेशियल टेंशन है, मान लो मैंने दो लिक्विड्स ले लिए, पानी और ऑयल, ठीक है, उन दोनों के बीच की जो टेंशन होगी ना, उनके बीच में भी एक सरफेस बनेगा. उन दोनों के बीच की टेंशन इज इंटरफेशियल टेंशन. इंटर मतलब दोनों के बीच की, फेशियल मतलब जो फेस पे उनके आ रही है, ठीक है. इंटरफेशियल टेंशन इज नॉर्मली गामा ए बी. अगर दो लिक्विड्स हैं तो इट विल बी गामा ए माइनस गामा बी. ये इंपॉर्टेंट है इंटरफेशियल टेंशन. तो अब क्या होता है जब मैं सरफेस एक्टिव सब्सटेंसेस लाइक इफ आई यूज अ डिटर्जेंट, देन इन दैट केस व्हाट हैपेंस इज इट डिक्रीजेस द सरफेस टेंशन ऑफ वाटर. कैसे? ऊपर एक्यूमुलेट हो जाते हैं. अगर मॉलिक्यूल ज्यादा ऊपर एक्यूमुलेट होंगे तो अंदर की सरफेस टेंशन कम होगी. अगर अंदर की कम होगी तो बेसिकली डिटर्जेंट से हमने क्या वॉश करने हैं? कपड़े. कपड़ों के ऊपर क्या लगी हुई है? ग्रीस या डर्ट, ठीक है. तो वो ग्रीस और डर्ट और वाटर की जो इंटरफेशियल टेंशन है ना, वो कम कर देता है, जिसकी वजह से ग्रीस गोज इनटू वाटर. अगर इफ वी बोथ हैव, आई मीन इफ टू ऑफ अस, मी एंड वन ऑफ यू हैव टू गेट अलोंग वेल, तो हमारी टेंशंस क्या होनी चाहिए? कम. हमारे बीच की टेंशन कम होनी चाहिए. तो सरफेस एक्टिव सब्सटेंसेस क्या करते हैं? लाइक फॉर एग्जांपल डिटर्जेंट्स, दे अक्यूमुलेट ऑन द सरफेस. उसकी वजह से पानी की सरफेस टेंशन को कम करते हैं. उसकी वजह से क्या होता है कि ग्रीस जो कपड़े पे है उसकी और पानी की इंटरफेशियल टेंशन कम हो जाती है. एंड देन इट्स इजियर टू एंड देयर इज बेटर एक्शन. गॉट इट? नहीं तो अभी फिलहाल इतना याद रखना दैट सरफेस एक्टिव सब्सटेंसेस आर दोस द वंस व्हिच accumulate on the surface and decrease the surface tension of water. Water is like tried and tested, so I am saying water. And surface inactive substances are opposite. So by and large, we have now discussed three properties: vapor pressure, surface tension, viscosity. Quick revision. Vapor pressure के केस में क्या होता है कि you have your vapor pressure basically of the vapors above the liquid in equilibrium with it. Vapor pressure जब atmospheric pressure के equal होता है तब you say you have reached the boiling point. Pressure अगर 1 atmosphere है तो normal boiling point. If the pressure is 1 bar, then it is standard boiling point. And then we say that how can you determine the pressure? By Clapeyron equation. dP by dt is equal to delta H by T delta V. बस एक ही फॉर्मूला है इसका, आराम से याद होगा. वेपर प्रेशर इंक्रीजेस विद टेम्परेचर. टेम्परेचर बढ़ेगा, वेपर प्रेशर बढ़ेगा. इम्प्यूरिटी अगर नॉन वॉलेटाइल ऐड करेंगे तो वेपर प्रेशर डिक्रीज हो जाएगा. नेक्स्ट प्रॉपर्टी, सरफेस टेंशन. इट इज द प्रॉपर्टी ऑफ द सरफेस ऑफ द लिक्विड बिकॉज ऑफ विच देयर इज अ नेट पुल, इनवर्ड पुल. पर होता क्या है? फोर्स एक्टिंग पर यूनिट लेंथ अलोंग एनी लाइन ड्रॉन परपेंडिकुलरली टू द सरफेस. ठीक है? It's kind of an imaginary line about unit length drawn from the surface. तो units क्या होंगी? force per unit length की Newton per meter. ठीक है? Then what is the device which is used for determining surface tension? Stalagmometer use कर सकते हैं, capillary भी use कर सकते हैं, capillary rise method. उसके अंदर हमारा surface कोई भी चीज, अगर कोई भी liquid circular होता है in shape, उसका by and large reason is surface tension. Why are raindrops spherical? Due to surface tension. Why are mercury globules spherical? Due to surface tension. Then once surface tension is done, you should also know what is surface energy. It is the work done in increasing the area. क्योंकि minimize surface tension works to minimize the surface. अगर surface कम हो रहा है मतलब छोटा दिख रहा है, that is only because of surface tension. कितना काम करना पड़ेगा उसके एरिया को बढ़ाने के लिए? by 1 meter square is your surface energy. So surface energy की units joules per meter square. Surface tension की units Newton per meter. Surface active substances कौन से? जो accumulate on the surface and the ones which decrease the surface tension of water. Then in surface tension we have force is equal to 2 pi r into gamma. 2 pi r into gamma तब था जब मैं स्टेलाग्मोमीटर की बात कर रही थी, ठीक है, एंड वेयर फोर्स इज इक्वल टू mg. और एक और हमने कैपिलरी वाला फॉर्मूला देखा था, दैट फोर्स इज इक्वल टू h रो g r by 2. चेक कर लो, h rho gr by 2. All right, that was the force. Then we came on to viscosity. Viscosity is nothing but the resistance offered by the liquid to the flow of the liquid. तो अगर हमारी एक के ऊपर एक लेयर फ्लो कर रही है तो उस केस में क्या होगा कि मेरी जो एक लेयर है वो दूसरी लेयर को पुल करने की कोशिश करेगी जिससे उसका फ्लो कम, आई मीन इट विल ट्राई टू रिटार्ड इट्स मोशन, स्लो करने की कोशिश करेगी. दैट इज द रेजिस्टेंस. रेजिस्ट मतलब रोकने की, रेजिस्ट कर रहे हैं उसको. So that means it is the resistance offered by the liquid to the flow of the liquid. So if we have three different layers in contact, हमने अगर लिया एक U से मूव करी एक U plus du से, so then we arrive at a formula that force is equal to eta into A into du by dz, where A is the area of contact. Layers तो चाहे कितनी भी बड़ी हो, हम सिर्फ एक area of contact की बात कर रहे हैं, and du by dz is nothing but the velocity gradient, and eta is the coefficient of viscosity, and F is the viscous force that we are talking about. So eta is the force acting per unit area per unit velocity gradient. Units will be Newton meter minus 2 seconds. कई poise भी बोलते हैं, कई pascal second भी बोलते हैं, और किलोग्राम पर मीटर पर सेकेंड भी होता है. ठीक है, so remember all the units because these are to be remembered. After that we have surface tension, ये हो गया. उसके बाद we have two formula for viscosity. One is force is equal to 6 pi eta rv, which is the Stokes law, where force is, this is the viscous force, of course, this is the coefficient of viscosity, r is the radius of the capillary, v is the velocity with which your liquid is moving. Then for the Poiseuille's equation we have pi pt r to the power 4 upon 8 lv. ठीक है, p मेरा h rho g है, ठीक है, और बाकी सब चीजें हमारी कैंसिल हो जाती है if we compare it with the reference liquid, and what we have the basic formula is nothing but eta L by eta W is equal to dl TL upon dW TW. ठीक है, from till here we are like done with viscosity. You have to remember जब मैं temperature increase करेंगे तो molecules will start moving more randomly and the viscosity will reduce. Here you also can remember that viscosity is given by a formula. ये फॉर्मूला कोई पूछेगा नहीं, बट यू विल रिमेंबर दैट विस्कोसिटी वेरीज इनवर्सली विद टेम्परेचर. टेम्परेचर बढ़ेगा तो विस्कोसिटी कम होगी फॉर लिक्विड्स, लेकिन गैसेस के केस में इट इज नॉट द केस. नाउ दैट वी हैव लर्नड अबाउट विस्कोसिटी, तो विस्कोसिटी गैसेस के केस में भी, फ्लूइड्स क्या होते हैं, गैसेस और लिक्विड्स दोनों हैव अ टेंडेंसी टू फ्लो, सो बोथ आर फ्लूइड्स. सो हियर इन दिस केस व्हाट वी हैव इज, व्हेन आई टॉक अबाउट गैसेस तब मेरे मॉलिक्यूल्स आर मूविंग रैंडमली. तो इस केस में देयर इज एक्सचेंज ऑफ मोमेंटम. कुछ फ्रैक्शन ऑफ मॉलिक्यूल्स नीचे आ जाते हैं, कुछ फ्रैक्शन ऑफ मॉलिक्यूल्स ऊपर वाली लेयर में चले जाते हैं. तो इट इज एन एक्सचेंज ऑफ मॉलिक्यूल्स और मोमेंटम. हियर विस्कोसिटी इज मेनली बिकॉज ऑफ, यहाँ पे विस्कोसिटी क्यों था, ड्यू टू ड्रैग ऑफ द लेयर्स अबव ईच अदर. क्योंकि लेयर्स एक दूसरे के ऊपर कर रही हैं तो देयर इज अ विस्कस ड्रैग, उसकी वजह से विस्कोसिटी है. लेकिन गैसेस के केस में विस्कोसिटी किस चीज की वजह से है, it is mainly because of the exchange of momentum. ठीक है, तो here in this case if we increase the temperature our viscosity will also increase, because if we increase the temperature then in that case the exchange of momentum would increase. For gases it is easy to move faster, and here we are saying that only the exchange of molecules will result in the exchange of momentum. So here you say that the coefficient of viscosity for gases is directly proportional to under root T. इतना याद रखना कि for gases as we increase the temperature viscosity increases, and for liquids if we increase the temperature viscosity decreases. All right, with this we can just look at some of the questions. I had some 50-60 questions. I'll request people to just allow me to do some of them. The very first question, please focus on the screen. We can discuss some questions quickly. A pura gases or liquid state, that means the states of matter, whatever is to be done till now has been covered. So we'll just quickly discuss some questions here. check up the question quickly. A gas occupies 300 ml at 27 degrees and 740 mm pressure. Calculate its volume at STP. तो आपको पता है इसका सोल्यूशन जल्दी से, अब तो आपको सारे फॉर्मूले पता है. आई थिंक गैसियस स्टेट तो मैंने रिवाइज भी बहुत करवा दिया है, तो यू शुड बी नोइंग. यू नो हियर व्हाट इज द वॉल्यूम. 300 ml है वॉल्यूम. सो 300 by 1000 उसको लीटर में कन्वर्ट करोगे ना, तो 300 by 1000 दैट विल बी लीटर्स. हमारा प्रेशर कितना है mm. अगर 740 mm दे रखा है उसको मुझे एटमॉस्फेयर में कन्वर्ट, स्टैंडर्ड एटमॉस्फेयर मुझे प्रेशर पता है, दैट इज 1 एटमॉस्फेयर. तो अगर मेरे को mm वाले को एटमॉस्फेयर में कन्वर्ट करना है तो प्लीज रिमेंबर आई विल बी डिवाइडिंग इट बाय 760. ओके, तो ये मेरा इन एटमॉस्फेयर हो गया. एंड देन आई हैव द टेम्परेचर इन 300 Kelvin and STP में मेरा P1 is 1 atmosphere and T1 क्या है? T1 is standard temperature which is 273 Kelvin. अब मैंने प्रेशर को एटमॉस्फेयर में इसलिए कन्वर्ट करा क्योंकि मेरे को स्टैंडर्ड प्रेशर पता है which is 1 atmosphere. And so we'll have to find out what? We have to find out V1. तो अब मेरा कौन सा आइडियल गैस लॉ इक्वेशन यूज होगी? What is that? P1 V1 by T1 is equal to P2 V2 by T2. और यहाँ से आपका V2 निकल आएगा. सारी वैल्यूज आपको पता है, सिर्फ आपको सब्स्टिट्यूट करना है. दिस न्यूमेरिकल शुड टेक अबाउट 30 seconds to 45 seconds. ठीक है, योर मैथमेटिक्स स्किल्स शुड बी सो स्ट्रॉन्ग. आई एम जस्ट पुटिंग डाउन द आंसर फाइनली सो दैट आई डिस्कस मोर क्वेश्चंस. नेक्स्ट स्क्रीन प्लीज. नाउ लुक एट दिस क्वेश्चन, वेरी इजी. द वॉल्यूम ऑक्यूपाइड बाय 22.4 liters of a gas, 22.4 grams of a gas is what? वेपर डेंसिटी आपको गिवन है. अब आपको अगर वेपर डेंसिटी गिवन है तो आपको फिर मोलर मास निकालना आना चाहिए. मैंने आपको बताया व्हाट इज मोलर मास. मोलर मास इज इक्वल टू वेपर डेंसिटी इनटू 2. ठीक है, व्हाट इज माय वेपर डेंसिटी? जल्दी से देखो, वेपर डेंसिटी 11.2 into 2, व्हाट इज दैट? 22.4. डन. अब मेरा कितना मास गिवन है? गिवन मास इज व्हाट? ये सब तो लिखना भी नहीं है व्हेन यू विल प्रैक्टिस. गिवन मास इज 22.4 grams. Molar mass is also 22.4 grams. निकालना क्या है मुझे? Volume. What is ideal gas law equation? nRT by P. What is this? N is to be calculated mainly. N कितना है मेरा? That is 22.4 given mass upon molar mass. So that is 22.4 upon 22.4. अब यहाँ पे मेरे को स्टैंडर्ड टेम्परेचर प्रेशर कंडीशंस गिवन है, तो इसका मतलब टेम्परेचर हो गया मेरा 273 और प्रेशर हो गया मेरा 1 एटमॉस्फेयर. ठीक है, तो डिनोमिनेटर की तो टेंशन ही नहीं है, ये कैंसिल हो गया. यहाँ पे मेरा जो R होगा वो जूल्स पर केल्विन पर मोल नहीं होगा, because I'll have to take it in terms of atmosphere now, and that will be 0.081821. Very good. So what will that be equal to? That will be equal to, ये कैलकुलेट करके देखोगे तो it will come out to be equal to 22.4. वैसे it was understood also. Okay, the volume occupied by 22.4 grams. और अगर आपको यहाँ से समझ में आ गया कि ये 1 मोल का है, तो you know what is the 1 मोल? ये सिर्फ मैंने समझाया कि अगर कोई और सिमिलर क्वेश्चन आया तो you should know. Otherwise this question should take about 10 seconds time. कैसे? Look at the question. The volume occupied by 22.4 grams of a gas at NTP. आपने जब एक बारी नंबर ऑफ मोल्स कैलकुलेट कर लिए, नंबर ऑफ मोल्स कितने? 1. और 1 मोल कितना ऑक्यूपाई करता है NTP? That is 22.4 liters. Next question. In the next question, what we basically have is, if 1 liter of a gas, ये Dalton's law of partial pressure का question है, मैं directly बता रही हूँ. 1 liter of a gas is given at 600 mm and 0.5 liter of a gas at 800 mm are taken in a 2 liter bulb. अब अगर देखो कि मेरी गैस A कितनी है, गैस A मेरी है 600, गैस A है 600 mm. ऑलराइट, 600 mm का मतलब है कितना है? ये 1 लीटर है. और B कितना है मेरा? 800 mm और 0.5 लीटर्स है ये. और टोटल मेरा कितना है? 2 लीटर्स. अब देखो ये कितना है? हाफ है टोटल वॉल्यूम का, तो इसका प्रेशर ऑफ A कितना होगा? इसका समझ लो इसको, ये सीधा 600, आप लोग क्या करोगे, PA प्लस PB 600 और 800 1400, बाई चांस इसमें नहीं है तो 1500 पे टिक मार दोगे. Some of you have a tendency to do that. So what are you going to do? PA will be pressure of A 1 liter है, 1 liter is half of 2 liters, so pressure will be 300. ठीक है, प्रेशर ऑफ ए. प्रेशर ऑफ बी देखो, बी कितना है, 800 मिलीमीटर है और 0.5 है. 0.5 is 1/4, so 1/4 of 800 will be 200. So total pressure will be 300 plus 200, which is 500. So the option number D is correct. Next question. Value of what we have here is value of a gas constant. इसके लिए तो आपको बहुत easily you should be knowing all the values, which is 8.314 joules per mole per Kelvin. Option number 3 C is correct. Next question. Next, in the next question, what you have is, for an ideal gas, what is the number of moles equal to? What is ideal gas law equation? PV is equal to nRT. What is your N by V is the number of moles. So N by V will be equal to RT. अगर N by V is the number of moles, that will be equal to P by RT. ठीक है ना? N by V will be equal to P by RT. So which option? C. All right. Next question. A closed vessel contains equal number of nitrogen and oxygen molecules at a pressure P millimeter of mercury. If nitrogen is removed from the system, अब आप ये देखो कि अगर दोनों इक्वल नंबर में है तो इसका मतलब हाफ प्रेशर नाइट्रोजन का, हाफ प्रेशर ऑक्सीजन का, डाल्टन्स लॉ. ठीक है, अगर नाइट्रोजन हटा देते हैं देन द प्रेशर विल बी व्हाट, P/2. अरे सिंपल है, दो नाइट्रोजन और ऑक्सीजन दो गैसेस हैं, ठीक है, इक्वल वॉल्यूम में, तो दोनों का प्रेशर कंट्रीब्यूशन आधा आधा होगा. टोटल प्रेशर अगर P है तो P/2 उसका, P/2 उसका. एक अगर हमने हटा दिया तो देन इन दैट केस क्वेश्चन, तो देन इन दैट केस व्हाट वी हैव इज नाइट्रोजन का कितना प्रेशर, P/2. नेक्स्ट क्वेश्चन. To which of the following Dalton's law of partial pressure is not applicable at room temperature? अब देखो Dalton's law का प्राइमरी कंडीशन क्या है, that they should not be reacting at room temperature. हाइड्रोजन ऑक्सीजन रिएक्ट करेंगे रूम टेम्परेचर पे? क्यों, पानी बन रहा है यहाँ पे. You have hydrogen in air, you have oxygen in air. This is room temperature. So we have option number which will not follow. So O2 and H2 will follow at room temperature. They are not forming water. N2 and O2 are not forming N2 or NO or something else. So NH3 and HCl, they will form NH4Cl. आपको ये ध्यान से सोचना है क्योंकि टेम्पटेशन होती है H2O2 तो रिएक्ट करके पानी बनाएंगे. पानी बन रहा है अभी आसपास, नहीं बन रहा ना. फॉर हाइड्रोजन हीलियम तो इनर्ट गैस है, वो वैसे ही रूल्ड आउट है. N2O2 भी इंटरैक्ट नहीं कर रहे रूम टेम्परेचर पे. सो व्हाट आर यू लेफ्ट विद, अमोनिया और HCl अगर यहाँ पे अगर हम ले आएंगे, दे विल इमीडिएटली एंड मिक्स देम, सो दे विल फॉर्म, दे विल इंटरैक्ट, सो दे विल नॉट फॉलो Dalton's law. नेक्स्ट क्वेश्चन इज डेंसिटी ऑफ अ मिक्सचर ऑफ ऑक्सीजन and N2 at STP is 1.3 grams per liter. Well, I'll take 2 more questions after this. Let us complete at least 10 questions. So the density of a mixture of oxygen and N2 at STP is 1.3 grams per liter. Calculate the partial pressure. यहाँ पे मैं फॉर्मूला बता देती हूँ जो पार्शियल प्रेशर का लगेगा. Let us just assume, पहले तो मॉलिक्यूलर वेट निकाल सकते हैं टोटल. What will be the molecular weight? It will be density into molar volume, right? You are given density. What is the density? 1.3 grams per liter into molar volume is 22.4 क्योंकि STP given है, ठीक है. तो हमारा टोटल मोलर वेट निकल आएगा, it will be 29.12 approximately grams per mole, ठीक है. अब O2 के मान लेते हैं कि N1 moles है. Let us assume that O2 has N1 moles. Then total number of moles will be N1 into 32. अगर N1 moles O2 के माने तो एक मोलर मास होता है 32, तो N1 into 32 plus 1 minus N1 into which is the other gas. So 1 minus N1 into 28 N2 का weight 28 will be equal to the total mass that will be equal to 29.12. तो यहाँ से मैं बता रही हूँ कि N1 will turn out to be 0.26. I'm not giving you time, work it out yourself. 1 minus N1 will be 0.74. अब मुझे क्या निकालना है? मुझे निकालना है partial pressure of oxygen will be mole fraction of oxygen into total pressure. ठीक है, total pressure हो गया मेरा 1 atmosphere. STP पे निकालना है ना. So total pressure is 1 and what is the mole fraction of O2? ये 0.26 upon 1 क्योंकि हमने total number of moles को 1 माना है. So that will be 0.26 upon 1. So answer will be 0.26 atmosphere. So 0.26 atmosphere is option number C. I repeat this question once again because इसमें थोड़ा सा calculation था. हमें density given है, लेकिन हम उस density को कैसे use करेंगे? हम total molar weight निकालेंगे. Molecular weight total जो system का है that will be density into molar volume. हम एक मोल मान के चल रहे हैं, total है हमारे पास, total is 1 mole. So now what we have is 1.3 into 22.4 will give me per mole of the mixture that I have, that is 29.12. हम मान लेते हैं ऑक्सीजन के N1 मोल्स हैं. अगर ऑक्सीजन के N1 मोल्स हैं तो टोटल मॉलिक्यूलर वेट हमारा 29.12 है. तो ऑक्सीजन का वेट कितना होगा? N1 into 32, 16 into 2 32, और N2 का कितना होगा? 1 minus N1 मोल्स बचे, हम टोटल मान के चल रहे 1 मोल है, तो 1 minus N1 into 28 is equal to 29.12. इसको आपने N1 के लिए सॉल्व करना है. N1 आ जाएगा आपका 0.26. तो अगर N1 आ गया तो फिर N2 के नंबर ऑफ मोल्स आ जाएंगे 1 minus N1 which is 0.74. टोटल नंबर ऑफ मोल्स कैलकुलेट करने की जरूरत नहीं, हमने 1 ही माने हैं. तो इसीलिए व्हाट विल बी माय मोल फ्रैक्शन? 0.26 upon 1. So mole fraction into P total which is 0.26 into 1 will be 0.26 atmosphere. Simple. It only looks complicated. Next question. Next question is that two gases A and B having molecular weight 60 and 45, मैं सिर्फ methodology समझा देती हूँ, respectively are enclosed in a vessel. The weight of A is 0.5 grams and that of B is 0.2 grams. The total pressure of the mixture is 750 millimeter of mercury. Calculate the partial pressure of the two gases. Now you know what is partial pressure? Total number of moles into total pressure. Total pressure आपको 750 given है. आप moles, number of moles निकालोगे, और number of moles कैसे निकालोगे? 0.5 upon 60 and 0.2 upon 45, और mole fraction कैसे निकलेगा? वो moles upon total moles. Done. Answer आएगा इसका 260. Oh sorry, the answer will be C. That will be 490 and 260. Calculate it for yourself and just check. I mean, I'll give you, pass it all these questions, right? And let's take up 10th, and 1 is like subjective only. Just take up the next question. The molecules of a gas A travels 4 times faster. They're giving me signals to leave as much as you want. The molecules of a gas A travels 4 times faster. ये clearly Graham's law of diffusion है. तो rate 1 by rate 2 जो है वो मेरा 4 by 1 है. तो MA by MB क्या होगा? 1 by 16. ये तो बिना देखे भी आप कर, मतलब बिना the molecules of a gas A 4 times, तो 4 by 1 अगर rates का ratio है तो हमारा molecular weights का ratio is 1 by 16. तो ये देखो, किसी question में अगर 5 सेकंड लग रहे हैं तो किसी में 30 to 45 seconds और 1 minute भी लग रहे हैं. So the more you are prepared, the more. Now the last question. For today, 4 rubber tubes are respectively filled with H2, O2, N2 and helium. 4 gases से filled है. The tube which will be required to be re-inflated first. अब ये देखो, सबसे पहले कौन सी भरेगी? Rate of diffusion is inversely molar masses. ठीक है, तो जिसका मोलर मास सबसे कम वो सबसे ज्यादा डिफ्यूज होगी और वो सबसे पहले फिल होनी चाहिए. तो उस केस में सबसे कम किसका मोलर मास है? Hydrogen. So answer is A. All right, thank you. I'll pass more questions to everyone. Please practice, and just in case if you have any problems, please talk to me. And no question should be taking more than a minute's time. 1 मिनट से ज्यादा किसी क्वेश्चन में नहीं लगना चाहिए. सिर्फ ये सोच के चलना. All right, thank you.
Okay, good afternoon, girls. So, yesterday we discussed the locus, and there we came to know that there are basically three types of locus in mathematics, right? It was geometric locus, algebraic, and parametric locus, and we also learned how we can go from parametric to algebraic and algebraic to parametric, and from geometry to algebraic and algebraic to geometric. So, for going from algebraic to parametric, we had to eliminate the parameter. And what was parameter? Something which is varying. So elimination of parameter will help you go from parametric to algebraic. And from algebraic to parametric, you have various ways. Just you have to put x is equal to 2, get the counterpart of y. If the objective question comes, you have to see all the options, right? Now, we also did from geometry to algebraic. We were given some algebraic geometric conditions. We took the moving point as h comma k, and then we assigned all those geometrical properties we know, or in the questions the conditions are given. And after that, we were able to get our algebraic locus. And we also learned to draw some of the basic curves, that is from algebraic to geometric locus. After that, we discuss circle. So we got little friendly with the 2-degree curve, and then we got the general expression of circle. And by watching the general expression of circle, we were able to tell what is the center and what is the radius. After that, we found the diametric equations using the concept of slopes, that we know that in semicircle we get the angle, inscribed angle is 90-degree. So we took the moving point on the semicircle curve, and we just took the slope as -1, the product of the slope as -1. We got the diametric form. When we got the diametric form, we actually saw that it is nothing but x minus alpha into x minus beta plus y minus p into y minus q, right? This was the thing which we got. It means we got a quadratic equation in x plus quadratic equation y. The first quadratic equation is giving us the abscissas of the diameters, and second quadratic equation is giving us the ordinates of the diameters. So we were able to say, okay, fine, if I write the first quadratic expression then plus the second quadratic expression is equal to 0, that gives me the diametric form, and we were able to guess the diameters, right? After that, we use the same concept for finding the angle with if I have got A, B is lying on particular curve, then we could have easily guessed that if we give you the point P, we could have easily guessed what angle APB is going to be. Either it is going to be the acute, obtuse, or right. How? Just we form the diametric form of the equation, and then we saw the position of P with that respect of the circle. If the P is lying inside, the angle is obtuse. If P is lying outside, the angle is acute. If P is lying on the curve, it is right angle. Till here, no issue was that. After that, we discussed was uh, the length of the chord. For finding the length of the chord, we were not doing by going finding the abscissas and finding the ordinates and then applying the distance formula. We were not doing that. What we were doing, we were using the concept of line, that we know that y1 minus y2 is equal to m into x1 minus x2. So we get the relation between y1 minus y2 and x1 minus x2. And we were able to find the quadratic equation in abscissas, where we can find the difference of roots. So the length of the chord turned out to be the difference of root under root 1 plus m square. That was the condition we got it, right? Till here, there was any issue? No. After that, we found the x-intercepts and y-intercepts, the general expressions when it is going to touch x-axis, when it is going to touch y-axis, when it is going to touch both the axes. Was there any issue? Okay. And after that, we did if y is equal to mx plus c is the tangent of a circle, then what is c? The c square turns out to be a square into 1 plus m square. We found it by two ways. One was just, okay, we know that it's a circle. I have a tangent, so the distance from the point of contact to the center would be the distance. So using that, we found the relation that c square is equal to a square into 1 plus m square, right? The other way was, okay, put y is equal to mx plus c in place of y, put mx plus c in the equation of circle, and make the discriminant 0. Then also the line qualifies as, tangent. So the relation also turned out to be c square is equal to a square into 1 plus m square. Till here, there was no issue. Okay. Then I missed one thing, the power of a circle. We just discussed what is the length of the tangent from point. So it turned out to be, okay, if I put the x1 comma y1 in the equation of the circle, that will be the under root of that part. Turns out to be the length. Okay. So where you guys lose it, tell me. You just feel that the class last time was fast. It was not fast, it was smooth. Maybe you were not able to get time to relax, but we are meeting for a very brief period of time. काफी मुख्तसर वक्त के लिए मिलते हैं ना. So we have to get grasp as many things as we can. You have to take as many information as you can so that you can get back home. You have 5 days to study. You have 5 days to look on the video lectures. You have 5 days to assimilate everything. You have 5 days to practice everything. So what is the issue? Okay. Now, other reason of being little speedy is that at the end of the circle, I want to discuss more of the last topic of straight line, which has some relation with circle as well. Okay. So please bear with me the speed. Okay. So should we continue or should we discuss any last thing? Anything in detail? What we did in the last thing? Anything? No? Anyone? Online people? Any query from the last class? No. So it means that we should go ahead, right? So we were, I think, can you please come down? Some people came out that in 15 they were having problems. I think the problem is sorted out. Okay. We have already discussed 16 and 17. It was very easy, 16, and then we just shifted the circle to x1 on the right on the x1 and up y1. So the tangent also shifts up by x1 on the right and y1 to the up. Okay. Now see question number 18. So it's just an application of 16 and 17. The question number 18 says, find the equation of the tangent. I know slope of the tangent. This is root 3, right? And the equation of circle is right? So I know the equation of tangent is going to be y minus y1 into m into x minus x1 plus minus a into. So now the idea is, what is my x1? What is my y1? It was nothing but the center. It has been shifted, right? What is the center here? I see 2. Centers turned out to be 2, 2. Right? And what is the radius? G square plus f square minus c. That is 4 plus 4 minus minus 1. So this is my radius square. So what is my radius? So a is 3. So the equation turns out to be y minus 2. What is m? Root 3 plus minus 3. 1. That is right. Under root 4 is 2. So very easy question. Right? You don't have to every time take, okay, I am going to consider y is equal to mx plus c, my line. I'm going to make the discriminant. And then I'm going to solve the equations. No, you don't have to. We have already proved that y is equal to mx plus c for x square plus y square is equal to a square. And that was very easy. And that was, even if you forget the result, it's very easy to derive it from y is equal to mx plus c and x square plus y square is equal to a square. And then the concept of transformation, like shifting the circle on the center, on the new center, things will be fine, right? So this is the way we are going to solve. Even in the examination, right? When you are in the examination, they do not want to see how good you are in calculation. They just want to see how smart you are. Okay. Now see the 19th question. The 19th question says that find the equation of tangent at 6, 8 for this circle. First of all, I want to make a tangent at 6, 8, right? First of all, if it's at 6, 8 must lie on the circle. If that is not lying on the circle, that is not the tangent, right? So, of course, here we can see it easily that it is lying on the circle. But whenever you see in questions, always make sure that whether that point is lying on the circle or not. Okay, so here I see that, okay, 6, 8 is lying on my circle because x square plus y square minus 6x minus 8y is equal to 0, which means 6 square plus 8 square minus 6 square minus 8 square, that turns out to be 0, right? Am I fast? No. Now, I see the circle and I know the center. 3, 4. I'm going to say this point as 6, 8. And I know this is going to be my tangent. I know how to write equation of line when I know point and slope. Right? That is point and slope form. I know that circle, that this tangent has this point 6, 8. And I know the slope of this line. What is the slope of this line? 4 by 3. So what is the slope of this line? So what is going to be the equation? Easy, right? Next page. So, are we going fast? No. So it's right. It's fine. No issue with this. Okay. Yesterday it was just a warm-up scene. We are going to be more fast. Can we go to the next slide? Okay. Now what is normal? Normal is a line which is perpendicular to tangent and the point of contact remains the same, right? It is only for circle that normal turns out to be the diameter also. Only for circle, not for other 2-degree curves. What are other 2-degree curves? Parabola, ellipse. Okay. Okay. Now, for question number 20, you see the circle is x square plus y square is equal to 1. Right? Find the equation of normal with slope √3. How to go for it? I know this is my circle whose center is origin, and I want to draw a normal which is making 60 degree, or the slope is √3, right? So what is the equation? Y is equal to √3x because it is passing through center. Of course, for circle only, it is true. Now, equation of normal passing through 2, 5. You have to tell me the equation of normal which is passing through 2, 5. That normal is obviously passing from origin, and that is also passing from 2, 5. So what will be the answer? Got it? No. Up. Got it? Got it? Okay. Y minus 0 upon x minus 0 is equal to 5 minus 0 upon 2 minus 0. Good? Clear? What is 0? The abscissa and ordinates of the center. Third, equation of tangent is slope √3. So I know the slope thing. So my equation is going to be, I know the center. So it will be y is equal to mx plus minus a into, and I know y m is √3 x plus minus, what is a? A is 1. And what is m? So into 2. So y is equal to root 3x plus minus 2. Right? Any issue? No. Part D, find the equation of tangent at 1 by root 2 comma 1 by root 3. Please fast. Tell me. Find the equation of tangent at 1 comma 1 by root 2 comma 1 by root 3. Tell me answer in 30 seconds. Twenty seconds. 15 seconds. 10 seconds. 5 seconds. Okay, I give you another 20 seconds. Anyone? Yeah. Wrong. Because that point is not lying on the circle. Okay? Whenever you see the question, you just go try to find the answer. I told you just 2 minutes back that whenever you see the point, you just make sure that that point lies on the circle. Nobody were able to tell me that, sir, that point is not lying on the circle. Okay. Now, party. Equation of tangent from 3 comma 0. Now here comes something new coming up. I know this circle. I know the center. I know this point. This is 3 comma 0. So I see two tangents going from 3 comma 0. Right? I can make out that. I am going to say, I don't know the slope of this line. I'm going to say this line as y minus 0 upon x minus 3 is equal to m. Any issue with it? No. I know the center. Center is? So my equation is y is equal to mx minus 3, which I can write mx minus y minus 3 is equal to 0, right? So I'm going to drop the distance. It will turn out to be mod 3 upon, I'll put 0 here, upon 1 plus m square is equal to, what is the radius? 1. Now I have to find m square. I'm not comfortable with root, I'm not comfortable with mod. How to get rid of it? Square it up. 9 is equal to, so m square is equal to, m is equal to, so what is the equation? Y is equal to plus minus 2 root 2. These are the two tangents, right? This is going to be my two tangents. This one, right? One is with plus 2 root 2. Other one is 2 root 2. Any issue? No. Clear? Similarly, go to question number 21. So we were finding the tangents. जब यहाँ पे point दे रखा था, we were able to find the tangents, equation of tangent when the point of contact was given. We were able to find the tangent when the slope were given. Now we are finding the tangent whose from a point is given, right? See this 21st question. I'm drawing the equation of tangent from 5, 7. And what is the center? And what is the radius? 3. Right? So what would be the equation of this line? Right? This is my equation. What is the challenging part? To find the m. That is the only unknown here. And I have to find, and I know how to find it. So first I'm going to rearrange my equation. Right? This is going to be my rearranged form of equation. Distance is going to be mod 2x minus 2 plus, 2m minus 2 plus 7 minus 5m 1 plus m square is equal to 3. So I get 9 into 1 plus m square is equal to, what is 2m minus 5m? Minus 3m. And what is 7 minus 2? 5. So it turns out to be 9m square plus 25 minus 30m. Right? So my final equation turns out to be 9 plus 9m square is equal to 9m square plus 25 30m. What is the solution of this equation? M is equal to 8 upon 15. Is it the correct answer? Is it the complete answer? So you want to say the answer is going to be y minus 7, 8 by 15, 5. Only one tangent. So you are going to say that I can draw only one tangent from here to that circle. There has to be another. What mistake we did? We are not getting plus minus. The mistake we did was we just cut this off. This was the mistake. Of course, we cannot treat infinity as my solution. We cannot. Whenever we see both side x square, we cut it off. But actually we reject the answer x is equal to infinity. We reject what? We reject the answer as x is equal to infinity because we don't consider x as a number. Infinity as a number. Okay. But what is m here? It's a slope. Slope infinity hota hai when the angle becomes 90 degree, and that line is a parallel line to y axis. So we missed that thing. So whenever we see m square on the both side, we are not going to cut it. We are going to see that what is that equation roots, what we are solving. If we are solving for any finite quantity, we are going to reject that answer. But here we are talking about slope. There are other quantity also which assume infinity as their answer. Okay. So here you have to be, whenever the slope comes, so you are not going to cut it off. Okay. There was also one question in IITG in which everything was cutting down, and we were arriving to something. In a straight line also there was some question which I want to which I'll be discussing later on. So whenever you see this, do not cut it off. See what is m. M is slopes. M can take infinity. So one answer is going to be that, okay, one line must be tangent which is passing through, and that line is parallel to y-axis. So the other line is x is equal to 5. We missed this line. This one tangent and this is another tangent. X is equal to 5 can be tangent. Of course, it can be tangent. क्या है ये? Tangent है. It can be tangent. And 5, 7 somewhere lying here. I can draw another tangent. It's something like this. Okay. So what was the mistake? We just cut it off m square both sides. Okay. Of course, one solution is that one solution is where m square gets cut and you get m is equal to 8 by 15. But what is the another solution? That I'm not cutting it off. I'm saying I'm dividing everything by m square. 9 by m square plus 1 is equal to, plus 9. 9 plus 25 by m squared minus 30 by m. This is going to be equal to 0. This is going to be equal to be 0. This is going to be equal to be 0. So m is equal to infinity is satisfying this equation. So yes, one solution is m is equal to infinity. The other solution is m is equal to 8 by 15. Okay. So see, whenever you are solving quadratic equation, you are solving for any finite quantity, it's fine. You're going to cut it off. But whatever quantities, let's say that tan 90 degrees, so theta must be 90 degrees, right? So these type of things you have to be very careful about it. Okay, infinity can be the answer, but it is actually not the answer. But the question, they are not asking what is the slope of that line. The question is asking what is the equation of that line. The equation of that line is x is equal to 5. Clear? And that is line that exists. That is not imaginary. So you got the idea? Okay. Now I see question number 22. It says that find the locus of P. Okay, locus thing. Find the locus of P such that tangents drawn from P. यहाँ से tangent draw हो रहा है, उसी का locus निकालना है. 2x square plus y square is equal to 16 have slope m1 and m2. Okay, so I'm going to draw the diagram first. So it is something like, and let's say this is my P, a moving point. I'm going to call it h comma k. This is my equation of circle whose center is origin, right? Have slopes m1 and m2. So what is the drill? Find the equation, then put the thing. Okay. So what is the equation going to be? Y minus k is equal to m into x minus h. This is my equation of line. I'm going to rearrange it. Mx minus y plus k minus mh is equal to 0. This is my equation of line. I'm going to find the distance. This gone. K minus mh mod upon under root 1 plus m square is equal to, what is the radius? 4. Right? And should I rub the diagram? Okay, I have the space here. I can solve it here. Okay, now I can square it up. Okay, so k minus mh ka square is equal to 16 into 1 plus m square, right? It turns out to be k square plus m square h square minus 2 hkm is equal to 16 plus 16m square. So I can say that h square minus 16m square minus 2hk m plus k square minus 16 is equal to 0. Can you see this quadratic equation? Is it a quadratic equation in M? The solution is going to be M1 and M2. That was the drill. Now, the condition which he gives in part A, the condition he gives, the questioner gives that okay, 1 upon M1 plus 1 upon M2 is 2, which means M1 plus M2 is equal to 2 sum of roots is equal to twice of, what is sum of root? 2hk h square minus 16 is equal to 2 into k square h square minus 16, right? So this gone, 2 gone, 2 gone. I got the equation hk is equal to, so what will be the answer? Xy is equal to, so this is going to be the locus for part A, right? Any problem here? No. ठीक है, सब कुछ समझ में आ रहा है? Good. So should I rub the part A part, because part B is going to use the same result? Should I rub the part A? The part B says the product is -1. It means that's 90 degree, right? And M1, M2 is equal to k square minus 16 by h square minus 16 is equal to -1, which means k square minus 16 is equal to minus h square plus 16, which means k square plus h square is equal to 32, which means x square plus y square is equal to 4 root 2 ka square. So I see that this is nothing but a circle, right? Whenever it gets perpendicular, the locus turns out to be circle. That circle is called director circle. What is that circle is called? So what is the definition of director circle? It's a locus. It's a locus of a point P from where we draw tangents to a circle. They are perpendicular to each other. So easy. What is director circle? So it is the locus of a point P such that from P, if you draw two tangents, obviously you're going to draw two tangents from point P on a circle. The locus of that P is going to be your director circle. That if they are perpendicular to each other, if the tangents are perpendicular to each other. And what is the properties of director circle? That okay, this circle is going to be concentric to the original circle. It will be concentric to original circle. See the origin, center, its origin again. What is the radius? 4 root 2. So what if the radius is r? R root 2. Getting the idea? What is director circle? And what are the properties of director circle? First thing, the director circle is the locus of point P such that from tangents, if you draw tangents, they are perpendicular to each other. That locus is director circle. That ये definition director circle का हर इसमें होगा. जरूरी नहीं हमेशा director circle हो director circle. Director circle जरूरी नहीं हमेशा circle हो. ठीक है? If we are drawing, we will be finding in parabola what is the director circle. If in ellipse, what is the director circle? It's not necessary that director circle has to be a circle. Okay. here, but the definition of director circle will always be the same. It is a locus such that from there, if you draw tangents, that will be perpendicular to each other. Okay, now the property of director circle of a circle is that it is going to be concentric to the original circle, and the radius is going to be r root 2. That is root 2 times of the original circle. Good. That we have already written. Ask Siddharth that please attend the last lecture very carefully of the circle. The last lecture, I'm going to repeat the locus. Okay. So and now 23rd, now you don't have to actually every time find the locus. If the person wants to know what is the equation of director circle, x square plus y square minus 4x minus 4y is equal to 0. First of all, I should know the center, that is going to be 2, 2. And what is the radius of this? So this is the equation r and center. Director circle का क्या कहानी होगी? Center remains same. Radius is root 2r, that is 4. So my equation of circle is hmm? 5 seconds, 10 seconds, 15 seconds. उससे ज़्यादा नहीं. Huh? Now, since we have discussed director circle, it was making 90 degree. Even if the angle comes down less than 90 degree, 30, 60, 40, or even 100, it will always follow the locus as circle only, and we are going to call that locus as theta circle. What we are going to call that circle as theta circle, and when theta circle has theta is equal to pi by 2, that circle becomes director circle. Okay. So let's see what are going to be the properties of theta circle. Director circle when theta is pi by 2. So this is your circle. This is your tangent from point P. Let's say this is theta. So this locus, ये जो locus है, this is going to be the theta circle, which will be concentric to original circle, and radius, Vijay will just find out. This is symmetrical, so it is going to be theta by 2. This is 90. This is r. This is my hypotenuse, which is going to be the radius. So r is going to be, if this is theta, this is r. So this is going to be r cosec theta by 2. Clear? Because sine theta by 2 is going to be r upon capital R. Got it? So pi circle की property क्या हो गई? कि it is same as director circle. मतलब director circle is a type of theta circle when theta is pi by 2. It is concentric to the original circle. The radius is going to be r cosec theta by 2. When theta is 90 degree, this is going to be pi, theta by 2 is going to be pi by 4. What is cosec pi by 4? Root 2. We got the root 2r. Right? Good. Can you go to the next page? So are we going very fast? No? Yes? So just tell me 24th answer. You all have to come out of your shell. You have to face the heat. You have to be fast. Find the equation of pi by 3 circle of x square plus y square minus 4x minus 4y. Is it going to be concentric? So the center is going to be 2,2 रेडियस ओरिजिनल सर्कल का रेडियस क्या है 2√2 so the radius is going to be 2√2 cosec pi by 6 and what is cosec pi by 6 that is 1 by sine 30 that is 2 so the answer is going to be easy peasy. Okay, now question number 25. So director circle is clear, theta circle is clear, good. Find the angle subtended by chord made by y is equal to root 3 4x1 at 4 comma 2. Yes, no, so you see this is your circle, let's say the center turns out to be 2 comma 1. Is 4 comma 2 lying on the circle? Yes, it is lying on the circle. I'm going to call this as y is equal to 1. I have to find the angle. Now let me tell you how to see whether 2 you know the center. Obviously we just want to know whether my 4 comma 2 is lying on minor part or major part, on minor segment or major segment. How to find it? By in straight line you must have done that. If this is your line, how to say these 2 points are lying on the opposite side and how to say when they are lying on the same side. Have you done this? Very good. So we'll be discussing this in detail, in greater detail. For a timing, just keep it in a thumb rule that if this is your equation ax plus by plus c is equal to 0, we'll be doing in the last day all the thing. If this line is ax plus by plus c is equal to 0, if my point P and Q, if they are lying on the opposite sides, so you put this thing on this thing and you put this thing on this thing, they will always have opposite sign. They will always have. If I put this one, I get, let's say, +3. If I put this, I get -7, not -3. It can be anything. Just we have to observe, we are not concerned what quantity we are getting. We are only concerned the sign. If they are of the same sign, they are on the same side. It's easy to keep in mind, but difficult to prove. Okay, so we'll prove it, don't worry. So for a timing, since we are not into straight line, we have to finish up circle first. So after finishing up the circle, we'll go to that part also. So if you see this is my equation of line. This 2 comma 1, for sure it is lying here. Now we just have to see that 2 comma 1 and 4 comma 2, whether they are lying on the same side or opposite side. I'm going to rewrite this as root 3x minus 1 plus 1 is equal to 0. So I'm going to put 2 comma 1, that is 2 root 3 minus 1 plus 1, it's a positive quantity. I'm going to put root 3 into 4 minus 2 plus 1, of course it is also going to be positive quantity. So it means it is lying somewhere on the upper part. Now why we are interested in knowing where P is lying, here or here? Remember class 9 circle chapter. If I call this angle as theta, 2 theta, अगर यहाँ होता तो क्या angle हो जाता? Pi minus theta. So we should know. Okay. Now यहाँ पे तो clear हो गया case. So it is very necessary. It is very important to see where your P point is lying. See, I have written caution also. Always when you are doing this type of question, you have to be cautious about your this. क्योंकि randomly what you will think, okay, यही हो रहा होगा यार, है ना? You will just draw the circle line and then okay fine, this is 2 comma 1, this is okay, तुरंत निकाल दिया. क्या पता यहाँ होता तो आंसर सीधे 180 माइनस थीटा हो जाता ना, तुम्हारा आंसर गलत हो जाता ना. आंसर ऑप्शन ए 60 डिग्री, ऑप्शन बी 120 डिग्री, आंसर ऑप्शन बी था। तुम लोगों ने तुरंत करके गलत कर दिया। तो क्या क्वेश्चन नहीं लिया कि whether they are lying on the same side or not? So you should always see whether they are lying on the same side. Here by calculation we know that it's lying on the same side. Now we know this property, this is going to be theta and this is also going to be theta, right? ये theta और ये theta same होगा ना? So we just have to find the angle subtended by chord. So I know what this length is, radius. What is the radius of the circle? Center is 2, 1 and radius is 4 plus 1 root 5. Root 5, right? G square plus F square minus C. I do not see C, so it's 0. So G square plus F square ka under root, that is root 5. Okay. Now what is this length? You got the point, you got the line. So distance formula. So I am going to say 2 root 3 minus 1 plus 1 ka mod upon under root 1 plus 3. Obviously this is 2 root 3 by 2, that is root 3. This turns out to be root 3. So root 5 cos theta is equal to root 3. So cos theta is equal to root 3 by 5. So theta is equal to cos inverse root 3 by 5. Okay, 5 by 3 cos inverse. What you said? Someone said 5 by 3. Cos inverse 5 by 3 क्या होगा? अच्छा, cos inverse 5 by 3 होगा क्या? What is going to be cos inverse 5 by 3? I'm asking a general question. What is the value of cos inverse 5 by 3? Anyone? Cos inverse 5 by 3? Possible नहीं है. It's range ही में नहीं है ना उसके डोमेन ही में नहीं है. Cos inverse minus 1 से cos inverse 1 ही तक जा सकता है. So what type of, you really guys need to revise trigonometry. In last class also I saw that you guys are missing the basics of trigonometry. Okay. Find the locus of the midpoint of the chord which subtends 120 degree at the center of the circle. I know the circle. The circle is 2, 2 center. Okay, this is by 2, 2. And what is the radius? Okay, if P and C center, just in the caution part, if P and centers lie on the opposite side of circle, then P is in minor and the angle is going to be pi minus theta. Theta तो हम सीधे center से निकाल लेना. Okay, good. Find the locus of the midpoint of the chord which subtends 120 degree at the center. What is the radius? What is the radius? 2 plus 2 ka square plus 1, 3. So this is going to be 3. H comma K root 60 degree. Now what we have to do? We have to find the equation of the locus of the middle point. We have to find the locus of the middle point. So how to go for it? And we are going to square it up. 3 cos 60 is sin 30, that is 3 by. So it's going to be x minus 2 ka square plus y minus 2 ka square is equal to 3 by 2 ka square. It will again be the circle concentric to the original circle, right? And it will move radius at 3 by 2. Yana 3 by 2? Got it? It's going to be something like this. Clear? So till 26, any problem? Everything's cool? Okay. Now we are shifting to the other part that is called direct common tangents and transverse common tangents. Okay. DCT and TCT. And we have to find, if we see two circles, we have to find how many total number of tangents are common tangents are there. So what is common tangent? Of course, when I say common tangent, I'm talking about at least two circles. And I'm seeing that two tangents are common to those two circles, right? So there are basically two types of common tangents. One is going to be direct common tangent and one is going to be transverse common tangent. Direct common tangent होंगे ऐसे जिसके सेंटर्स सेम साइड होंगे और ट्रांसवर्स कुछ होंगे ऐसे जिनके सेंटर्स and you know how to find, you know how to check when they are going to be on opposite side, right? Okay, good. But you don't know how, you just know that this is the method. Okay, so you understood the definition of transverse common tangent and direct common tangent. When I say direct common tangent, it means the tangent which is, first of all, that has to be common tangent, means both that line has to be tangent to both the circles. The second thing, the center should lie on the same side. When I say transverse common tangent, of course it has to be common tangent, and then the center should lie on opposite side. Okay, now I'll see all the cases I can draw between two circles. One case, these two circles is going to interact. Second case, right? Third case, fourth case, fifth case, right? Concentric is only just a type of this. So you saw these are the cases. Any other case you can think of between two circles? Only these two? So just tell me how many direct common tangents are there? Only two possible. And how many common tangents, transverse common tangents? Two. So in this case, I see four common tangents, two DCT and two TCT. Clear? Here I see this is your transverse or direct. Why? Because they are on the opposite side. So one TCT and two DCT. 3 CT, which means 2 DCT and 1 TCT. Clear? Can it have a transverse common tangent? No. So it will have, and both are okay. How many common tangents? One. What is it? TCT or DCT? DCT, direct. And that is only the here. So you see, whenever I say four common tangents, I want to say I'm talking about this case. When I say three common tangents, I'm talking about this case. When I'm talking about two common tangents, I'm talking about this case. And when I'm saying one, I'm talking about this case. When I'm talking about zero, I'm talking about this case. Any issue? Now, how to find when the circles are this? I know this is center 1, this is center 2, so distance may be d. If d is greater than r1 plus r2, this is the case. Any issue? No. When d is equal to, this is the case. When d, this is the case. When d is equal to mod r1 minus r2. See, this is D, and this is R1, and this is R2. So R1 minus R2 is D. Got it? And this, all cases clear? Any problem in these cases? No? Pakka? Should I rub it? Now let's say this is the case. अच्छा, ये जो होता है ट्रांसवर्स और डायरेक्ट, ये पॉइंट और ये पॉइंट कभी सेम नहीं होगा. You know it. एक पॉइंट से सिर्फ एक ही टेंजेंट बन सकता है. That is the property of any curve other than a straight line, है ना? It is a smooth curve, so it will have only one tangent at one point. So ये हमेशा याद रखना, ये दूसरा point of contact है. Question में हो सकता है दिखे. It may appear that they are on the same, but it is not possible. Maybe just a neighborhood. Okay. Now the question is, if this is my point of contact PQ, and this is my D, C1 and C2 is given, so I can find D. And this is R2 and this is R1. I want to know what is the length of PQ, the length of direct common tangent. How to find it? How to go for it? I have to find the length of DCT, PQ. I know this is. Then I can draw this. What is the length of this? What is the length of this? This is R2 and this is R1. So what is the length? This length. This length will be equal to PQ. And this is? And is it a right triangle? So just a sec. So it is a right triangle. Here it is 90 degree, right? So how to go for it? I can say PQ square plus R1 minus R2 square is equal to D square. This is your 90 degree, right? You can make this thing out. You can see this piece. This is your right angle triangle, 90 degree at here. So what is the hypotenuse? This D. And what is this? Getting the idea? Any issue? And this is difference of the radius. So what is the length of the direct common tangent? D square minus done? Any problem? No. So length of DCT you can find. Now let's say TCT. Should I rub it? Now I have to find let's say I have to find the length of PQ again. It is my transverse. This is my D, right? This is my D. right? Any problem? No? We have to find PQ again. है ना? So how to go for it? I know D, the distance between the centers. How to go for it? I see this 90 degree, so I'm going to extend it. This is R1, this is going to be R2. I'm going to join it. 90, 90. Is it my PQ? I can see this right triangle. Everybody can see this? This is the locus. है ना? I know D. I know this is 90 degree. I know this is R1 plus R2. Last time it was R1 minus R2. This time it is? And what is this? PQ. We have to find PQ. So PQ is equal to under root . Got it? Good. Next. Next slide. Next slide. Last time, yesterday I wanted to come till here. We were actually slow. Okay. See, the color has changed now. So you understood this? DCT, TCT, length. Good. Are we going very fast? Now the question is, find the equation of tangent x square plus y square is equal to 13 at 2, 3. Very easy. We have already done it, point slope form. Second question. Should I solve it first for 28? No. Second question. X square plus 2y square is equal to 12. It's not circle. Huh? And we have to find the equation of tangent at 2, 2. How to find it? आप लोगों ने differentiate करना सीखा है? थोड़ा बहुत, just a basic polynomials को at least you know how to differentiate, right? You know what is dy by dx? That is nothing but delta y by delta x, limit x approaching 0. That is basically the slope only. किसी भी curve का dy by dx is actually the slope. So if I find dy by dx at that point, I'll get the slope. Even I can find the equation of circle with that also. I can find dy by dx. The slope turns out to be something, and then y minus y1 upon x minus x1 is equal to dy by dx at x1 y1. That is the story of tangent. Understood or not understood? Y minus y1 upon x minus x1 is equal to dy by dx of at x1 comma y1. This is the story of tangent. This is the story of tangent, na? These 2 points are the point of contact. So y1 minus y, these are the, and the slope we want to know, that is slope is nothing but delta y by delta x, that is dy by dx. Right? Curve ke liye it has to be dy by dx. For line it was delta y by delta x, which is also dy by dx, because it was a linear thing. Right? Any issue with this? So we can use this? No problem? Okay. So let's say I'm not going to solve 28. Any issue with it? You all can solve that. So I'm going to solve 29 for you. What is going to be? X square plus 2y square is equal to 12. Right? I have to find first the form of dy by dx. What expression for dy by dx? So I'm going to differentiate both sides with respect to x. So x square, when I differentiate with respect to x, it turns out to be, and then 2y square turns out to be 4y dy by dx. Y is dependent on x now. Y is dependent on x. So dy by dx. And what is the definition of a constant? 0. Till here everything's fine. So I can say dy by dx is minus 2x upon 4y. I want dy by dx at what point? 2, 2. So it going to be minus 2, 2 by 4, 2. That is minus half. So what is the tangent? Any problem here? So what is the tangent? Y minus 2 upon x minus 2 is equal to minus half. Easy? So this is going to be the equation of tangent of parabola, which we of ellipse we have given. That's an ellipse, right? So it is true for all the curves. All the curves. Just find dy by dx. Find the dy by dx at that point, and then y minus y1 upon x minus x1 is equal to dy by dx at that point. Right? That is the equation of tangent. That is the equation of line. Tangent is nothing but line. Okay. When you will go to the calculus class in next year, you will be able to understand why everything is coming. But you are able to make sense, right? At least, not in a very formal definition way, but in intuitive way, you are able to find it. You are able to think about it, right? In the intuition, totally on the basis of intuitions. Now see, question number 30. I just gave you find the equation of tangent on ax square plus 2hxy plus 2gx plus c is equal to 0 at x1 y1. Hence, find the equation of tangent for any 2-degree curve ax square plus 2hxy plus by square plus 2gx plus fy plus c at x1 y1, and remember it. I'll tell you why, because it is going to help you in very, the things will become very easy, and it is not very difficult. Whenever you forget, you know how to derive it. Now see, the equation of curve is ax square 2hxy. Please pay attention, everyone, very careful. We are going to, you have to pay attention at every step, every calculation we are making here. Plus c is equal to 0, right? Any problem here? I'm going to differentiate 2ax. Okay, how to differentiate? What is the product rule? I'll take first as constant, then I'll differentiate other one, then I'll take another one as a constant and differentiate other one. So first I'm going to take hy as y as constant. So 2hy, clear? And then I'm going to take cool. And this is 2g, x gone, 2g ban gaya, c is gone 0, so everything is here. ठीक है? No issue here. I can get rid of this, right? So I can say my dy by dx, hx dy by dx turns out to be minus of ax plus hy minus g, right? यही होगा. So dy by dx turns out to be upon hx. ठीक है? सबने नोट कर लिया ये? So dy by dx at x1 comma y1 क्या बन गया? Minus ax1 एनी प्रॉब्लम? ठीक है सब कुछ? ये रब कर दूं? This left part? So what is the equation of tangent going to be? ठीक है? I can cross multiply. ठीक है? ठीक है? कर सकता हूं ये, मैंने x को इससे मल्टीप्लाई किया तो माइनस रह गया और ये हो गया, फिर माइनस माइनस प्लस होके x1 ही बन गया, ठीक है। I can shift this minus here and this minus there, so it will turn out to be hx1y plus ax1 plus hy1 ax1x plus hy1x minus gx, राइट यही हुआ, यही हुआ ना। देखो कुछ कैलकुलेशन मिस्टेक नहीं होना चाहिए। hx1y ax1x hy1x minus gx, clear? This is equal to ax1 square plus hx1 y1 minus gx1, ठीक है। ठीक है, यहां तो कोई प्रॉब्लम नहीं है ना, कुछ गड़बड़ तो नहीं किया हमने, गुड। नाउ आई सी ax1 here and I see hx1 y1 there, ठीक है। I'm going to rearrange it, I'm going to, कौन सा टर्म, कोई टर्म मिस हो गया क्या, ये वाला ना, ठीक है। Any problem? Till here everything is fine? Okay. Why minus gx is coming? Minus gx आ रहा है क्या? This whole thing has come up here, so it will be plus, no issue, ठीक है। I think यहाँ प्लस था, प्लस था ना यहाँ पे, क्योंकि हमने उधर शिफ्ट कर दिया था सबको, ऑब्वियसली। ठीक है, ओके। नाउ इफ यू सी, दिस इज a x1x plus h x1y plus y1x plus gx, I'm going to add gx1, so it will turn out to be ax1 square plus 2hx1y plus 2gx1, ठीक है। मैंने क्या किया, gx1 दोनों साइड ऐड कर दिया, ठीक है। आई एम गोइंग टू ऐड प्लस सी बोथ साइड, इससे क्या हो गया, व्हाट दिस थिंग हैज बिकम, इक्वेशन। If I put x1 y1 and x1 y1 is lying on the curve, so this thing will turn out to be 0. What, getting the idea क्या हो रहा है, हाँ? So this whole expression has turned out to be 0, and left hand side turns out to be a into x1 plus 2h into x1y plus y1x by 2 plus 2 into g x plus x1 by 2 plus c is equal to 0. This is the equation of tangent. ये आ गया expression. So now see what are the transformation happened. X square became xx1. xy became x1y plus y1x by 2. 2gx, x turned out to be x plus x1 by 2. C remained C. Getting the transformation? क्या समझ में आया कि when we are finding the tangent of this curve ax square plus 2hxy plus gx, the everything remains same with little replacement. The replacement has to be marked, has to be remembered, has to be kept in mind because it's not so difficult to keep in mind. X square will be replaced by xx1, xy should be replaced by x1y plus yx1 by 2. Okay, x to be replaced by x plus x1 by 2, y square to be replaced by y1, y to be replaced by y plus y1 by 2. Getting the idea? So you can now you are going to a better way of finding the tangent for any 2-degree curve when you have x1 and y1 is given. What you have to do? You have to write the equation as it is with a little change. What are the changes? X squared to be replaced by xx1, y squared to be replaced by yy1, x to be replaced by x plus x1 by 2, y to be replaced by y plus y1 by 2, xy to be replaced by x1y plus y1x by 2, and c to be replaced by c. It will be unaltered. Okay, any problem? So tell me what is the tangent for this 2-degree curve? So I'm just writing that expression a x x1 plus 2h x1y plus xy1 by 2 plus b y1 plus 2g x plus x1 by 2 plus 2f y plus y1 by 2 plus c is equal to 0. ठीक है, mug it. Rut low. X square to be replaced by xx1. It's very easy to keep in mind. I think you have already mugged it up. Just the questions, 10 questions kar loge, it will be internalized. So whenever you see the parent expression s is equal to 0, any 2-degree curve, you can write t0, valid for all 2-degree curve. Okay, it is going to help us a lot. आगे देखना. It's going to make अभी तक हमने क्या देखा? We just saw in circle we are actually not doing so much of calculations. If we were not doing those methods, then the circle is a chapter full of messy calculations. But is it a chapter of messy calculations? No, it's not at all a chapter of messy calculations. Even a straight line is also not a chapter of messy calculations, though you must be seeing that there are a hell lot of calculations, but it is not the right way. In coordinate geometry, there are 50-60 ways of solving any question, but there is only 1 or 2 ways which are actually the optimal way, the best way to do in the examination, right? Till here, everything's fine. So we are going to write the tangents now, very fast. 31st. Just tell me. Answer बताओ, start कर दो. X square to be replaced by y to be replaced by y plus 5 by 2 plus हो गया, कोई टेंशन ही नहीं. Easy. Okay, do it again. X square plus 3x plus 5y minus 9 is equal to 0. Was it so easy to write tangent equation? कल तक बहुत difficult था. Difficult नहीं था वो, but it is far easier, right? Okay, now here the tough one. 32. It's the origin, I guess. I cannot recognize my writing. It's origin, it's origin. It's not 6, it's origin. Okay. So, just a sec. X square will vanish. Minus 3 into 0 plus 0 by 2. It will also vanish. Minus 3 into x, it won't vanish. और 6 के लिए थोड़ा सा xy के लिए लफड़ा होगा. वही लफड़ा क्या होगा? थोड़ा सा 2 सेकंड और एक्स्ट्रा लगेगा. ठीक है? It's okay. No issue. Easy to find. Question number 33. Are we going very fast? Good. We have class till 3 now. I think today हम लोग ज़्यादा मतलब we will be getting shorter questions. We will be getting short of questions, so I'll be adding more questions on my own. So, 33. Find the point where y is equal to mx plus a under root 1 plus m square touches x square plus y square is equal to a square. बताओ. Locus वाला जिसको प्रॉब्लम था, maybe we will be able to handle in the last one. हाँ. Are you going to do all the calculations? Then, are we going to use t is equal to 0 thing? We can use that. Let's say it is h comma k. So what is the tangent going to be? hx plus ky minus a square is equal to 0. And what is the equation of tangent? mx minus y plus a under root 1 plus m square is equal to 0. These two are same lines. So how to find hk? H by m is equal to k by minus 1 is equal to minus a square by. हो गया. h निकल गया, k निकल गया. Easy ना? T is equal to 0. Things are understood. Otherwise, what you had to do? Okay, I have to find the point of intersection. I'll put that thing into y square thing, and then I'll solve that equation. Then I'll find x. Then I'll find corresponding y. And that is the point, right? That is the way. Or I think that is the only way. Or just put the parametric form and then find the distance and then hell lot of calculations. But t is equal to 0 has made my life easy. Okay. See 34th. Find the point where x by 4 plus y by 3 root 2 touches. Same story. It's nothing but tangent. So I'll say that point to be. See, this is ellipse. This is not circle. So we are going to say that point is. So the tangent is going to be. Is same as. Which means these two are same. H by 16 divided by 1 by 4. है ना? H by 16 divided by 1 by 4 is equal to k by 9 divided by 1 by 3. So h is 4 by root 2, k is 3 by root 2. Easy question, right? Again, otherwise, put that thing, solve the quadratic equation, put d is equal to 0, you will get same thing. Now we are going to the another part of circle, that is chord of contact. You know contact, point of contacts क्या बनते हैं? जब एक point से दो tangent बनते हैं, then you have point of contacts at the circle. And when you draw that chord, that becomes chord of contact. X1, Y1. Let's say this is A, this is B. So this is your chord of contact. A, B. This is your alpha comma beta, and this is P comma Q. Show that X1 alpha plus Y1 beta is 16, and X1P plus Y1Q is equal to 16. and also find the equation of chord of contact. This. So tell me how to solve, prove this thing and this thing. Any guess? Any idea? Any thought process? Can I write the equation of PA? What is that equation going to be? You are going to two points form or what? Don't you see that is a tangent? So don't we use t is equal to 0? Can't we use? So the equation turns out to be x alpha plus y beta is equal to 16. So the equation of this line, x alpha, take, and this line contains, so this will satisfy this. Easy? 2 seconds. What is the equation of this tangent? Px plus qy. And is it lying? This line contains x1, y1? Proved? Now tell me the equation of this line. The equation of chord of contact. Observe these two. If I say line, the equation is xx1, yy1 is equal to 16. This is nothing but t is equal to 0 for x1, y1, right? But unfortunately, t is equal to 0 is not the tangent because it is lying. But it is something, must be a line. And that line is nothing but chord of contact. Why? See, if I say this line, if I put alpha beta here, it will satisfy. If I put PQ here, it will satisfy. It means this equation contains both points. So obviously this is the line which contains both points. So this is going to the equation. This is equation of chord of contact. और इसका एक्सप्रेशन क्या निकल के आया? T is equal to 0. Tangent का भी क्या एक्सप्रेशन आया था? T is equal to 0. दोनों में फर्क क्या है? Just the position of x1, y1. If x1, y1 is lying on the circle and you write t is equal to 0, that line turns out to be tangent. And if that point is lying outside the circle, that t is equal to 0 turns out to be chord of contact. What about when p is lying inside and I write by mistake t is equal to 0 for that? That will turn out to be pole. Equation of pole. The line will lie outside. So basically, pole is a broader term for tangents, for chord of contact, and for the line. Basically, it's a line. It's a line. This is pole. एक पोल ये हो गया, ये हो गया, एक ये हो गया, ठीक है? It's basically polar. Sorry, not pole. This is polar. We have only 3 polar are possible, na? Either this, or just touching, or cutting. And if it is a polar, then it has a pole, and that pole is point. If the point is lying outside, the polar is cutting. That is nothing but chord of contact from that point. If that point is lying on the circle, that becomes tangent. Tangent is nothing but a polar only. And what is the pole? Just the point of contact जो साथ, pole और polar साथ आ गए. And here, pole अंदर चला गया, polar बाहर आ गया. See, pole polar ऐसे हो रहा है. ये पहला केस, my finger is pole, and this is my polar. Here it's fine. We both are meeting here. That is it. And then we are crossing it. Easy? दिख रहा है ना कैसे हो रहा है? दोनों मिल रहे हैं. They are meeting point at on the curve, that is tangent. So the polar is this line. So polar is a subset, a superset. उसके अंदर आता है chord of contact और उसके अंदर आता है tangent is nothing but a special type of chord or contact ना, जहां पे chord of contact सिर्फ एक ही है. Get the idea? So you understand the sets thing. Polar is a superset, chord of contact second, and then get the idea? और पूरा मतलब इसका मतलब एक superset है, मतलब tangent is also a polar and chord of contact is also a polar. And what is pole? The point. तो chord of contact के लिए P ये है, tangent के लिए point of contact, और इसके लिए बाहर. हम लोग देखेंगे कि ये कैसे बन रहा है. What is the equation and all. So we can write T is equal to 0 is equation of tangent if x1 y1 lies on circle, center नहीं circle. T is equal to 0 is equation of chord of contact if x1 y1 outside. मतलब पावर क्या होगा? पॉजिटिव. इसका पावर क्या होगा? 0. और T is equal to 0 is equation of polar if the pole is lying inside. Clear? ठीक है, कोई प्रॉब्लम इसमें? Easy to keep in mind and easy to visualize also. See, they are coming up, meeting here, and then they are going down. ठीक है? वो हटा दीजिए, मुझे लगता है कि डस्टर है. So T is equal to 0 is going to be our very, very good friend, right? Proof, you know. Please do it again because we had a little confusion with minus g ना, हमने थोड़ा सा miscalculation कर लिया था. आप फिर से करना घर पे. Okay? Whatever we are doing it, do it at your home. Do maintain a lecture notes. I told you on the very first lecture of mine. If you are not making notes, no use of sitting here. And you have all 5 days with you. So this is only what I was talking about, and we will be talking later also. Okay, valid for all 2-degree curve. It's not only for circle. It is for whenever anything. I'm talking in general. I'm talking about 2-degree curve. If there is anything only for circle, I'll let you know. That's a normal. I'll let you know that normal was it is passing. It is just a diameter for circle. है ना? Normal and diameter are same for circle. Now see, can you little up, down. हाँ, पूरा play. हाँ, ठीक है. Now before I start this question, it's a big, huge question, and it's going to take most of our time. So first, I wanted to know how many you have already finished straight line. So I wanted to know what is Euler's line, Euler's line. Have you heard this line? No? Okay. What is centroid? Point of concurrency of medians. What is orthocenter? Point of concurrency of altitudes. And what is circumcenter? Angle bisector, that's in center. Perpendicular bisectors. That is your. So ये circum circle बनाता है. In centers में in circle बनते हैं. X centers में X circle बनते हैं. I'm not going to talk about in circle in centers. I hope you know how to derive everything, right? You know how to find the coordinate of this? You know how to find the coordinate of this? How? What is going to be H? X1? Sin 2A? What? And same goes for Y. कैसे आता है ये? नहीं पता? Good. और what about in center? ax1 plus by1 bx2 plus cx3 upon a plus b plus c. आता कैसे? नहीं पता. और circumcenter cos 2a sin 2a कैसे आता है? मैं भूल जाता हूँ हमेशा, इसलिए हमेशा मैं निकाल लेता हूँ. तुम लोग भी शायद भूल जाते होगे, इसलिए निकाल भी नहीं पा रहे हो. Okay, we'll go into this later on. But tell me, we are talking about Euler's line. So do you know that Centroid, orthocenter, and circumcenter of a circle, they are collinear. That line is called Euler's line. Okay, that line is called Euler's line. Now tell me, what is the ratio? 2:1. Centroid divides that line connecting. If I say this is G, this is H, this is O, this is 2:1. Yeah, this is 1. This is 2:1. Which one? Up 1 or down 1? Up 1. It's closer to circumcenter. Okay. How? How can you say this? First of all, how can you say that they are lying on the same line? You want to see how, and you just want to know why. Okay. क्या straight line में what you did? Just a general equation of lines, slopes, 2 points, 3 points, intercepts. Okay, you missed the class also, na? Good. Let's say this is my circle. This is A, this is B, this is C. Right? Okay, this is a better circle. Okay, you see ABC? This circle is called circumcircle, and this point is called circumcenter. That is O. ठीक है? Perpendicular bisectors, right? This is, let's say, R. Clear? Let's say this is my H. Orthocenter will lie. Okay. Now, I'm going to join H and O. ठीक है? And I'm going to join. I'm going to call this as D. Okay. What is AD? Median. Okay. This is median, but I'm not going to call this as centroid because I don't know where it is lying. So I'm going to call this point as X. Any issue with it? What we have to prove? That my X is centroid. Then the moment if we prove that X is my centroid, we can say that, we can easily say that HX and OX are collinear. Collinear, and the ratio 2:1. That is the story. Okay. Now see, this angle is going to be equal to this angle. ठीक है? This is 90 degree. This is also 90 degrees. So this is going to be equal to this. Right? And this is going to be equal to this. So I can say triangle AHX is similar to triangle A से H आए हैं ना, so D से हो जाएंगे. We can say this DOX. Docs. ठीक है? Now I can say AH by DO is equal to HX by OX is equal to AX by DX. Okay. I know OD. If angle this is A, this is A, same. So OD is going to be r cos a, राइट? आप लोगों ने AH का लेंथ कभी निकाला है? क्या होता है AH का लेंथ? You haven't done this solution of triangle thing or triangle thing, property of triangles. You haven't done in trigonometry? Have you done sine rule? Okay. So I have to find AH. AH is basically 2r cos A. We are going to see how. If this is your triangle ABC, right? This is your 90 degree. This is 90 degree. Obviously, this point is your H. This is C. So this is going to be your C. I'm going to call this as A, this as B, this as C. I know this point E, let's say. What is the length of E? C cos A. है ना? This is nothing but A. C cos A. So I can say that A is C cos A. So I know this right triangle, जिसका मुझे hypotenuse AH है. So I know AE by AH is equal to cos C, sin C. AE by AH, sin C, है ना? So I can say AH is AE is nothing but C cos A by sin C. Any problem? What is sine rule? A by sin A is equal to K. What is K? 2R. 2R. See? Getting the idea? What is this? R cos A. This is R cos A, na? Sorry, this is R sin A, na? And what is the length of BC? 2R sin A. And what is BC? A. So A is 2R sin A. Similarly, everything will be 2R sin B, 2R sin C. Right? So that K is basically 2R. And what is R? Radius of circumcircle. So I can say AH is nothing but C को मैं क्या लिख सकता हूँ? 2R sin C cos A by sin C. Gone. क्या बना? 2R cos A. So DO is R cos A. AH is 2R cos A. So AH by DO QED. हो गया proof? It's a mathematical way of saying that, hence proved. So हमें क्या पता चला? AH by DO is 2 by 1. I know X is lying on median and AX by DX is also 2:1. So X is nothing but centroid, and I know that HGO is collinear, and I also know this line is called Euler's line because he was the one who actually found it, and the ratio it divides is 2:1. Done? भूलोगे कभी? There are many things which you need to know how they are being derived. You have no knowledge of in-center, you have no knowledge of orthocenter, you have no knowledge of circumcenter, and that's a very sad state. You should know how to prove it. So we'll try to cover those things also. So we have to be little fast. Okay, if time allows today, we'll do the derivation of in-center and orthocenter. Okay, still here it's fine. So if we know in-center, if we know centroid, if we know orthocenter, we can find circumcenter. You don't have to derive formula for circumcenter. If you know orthocenter, if you know centroid, you can find. Any of the two is known, the third can be found. Using the concept of Euler's line, that centroid divides 2:1, okay? Now coming to the question. I see this circle I see the point of contact as A, and this is P, this is A, this is P, equation of circle is x square plus y square minus 2x minus 2y plus 1 is equal to 0. So P turns out to be 6. P is given 6, 6. Centers obviously 1, 1. है ना? And radius is 1. Radius is also 1, right? G square plus F square minus C. Now, this is the scenario. A and B are point of contact. PA and PB are tangents, right? So should we start from part A? Find the equation of AB. What is it, AB? Chord of? So what is going to be the answer? 6x plus 6y minus 2 into x plus 6 by 2 minus 2 into y plus 6 by 2 plus 1 is equal to? Understood? T is equal to 0. T is equal to 0. समझ में आया ना कैसे आए? x1 plus y1 minus 2 into x plus x1 by 2 minus 2 into y plus y1 by 2 plus 1. Easy? No issue with that? Part A. Part B. Find mod AB. Who is thinking of finding the, how to find mod AB? I'm going to join this line. Okay, I'm going to join this line. This is going to be, let's say, theta. Let's say theta, theta. Symmetrical. This is going to be 90 degree. I know the length of this. Under root S1. Remember? How to find? Just put 6 here. 36 plus 36 is 72. 72 minus 12 is 72 minus 24 is 48 plus 1 is 49 and the square root of 49 is 7. Clear? This is theta. I know the radius. That is 1. So I know tan theta is 1 by 7, right? And I know this thing is going to be 7 sine theta. So twice of 7 sine theta. B is equal to twice of AP sine theta, which is equal to AP is nothing but root S1 and sine theta, tan theta is nothing but R by root S1. So sine theta is going to be R by tan theta is R by root S1 na? So sine theta will be, this is my altitude, this is my base, this is my altitude, so I put an R, base, this is going to be okay. So we are able to find, so tan theta is 1 by 7, so sine theta turns out to be 1 by root 50. 7 square plus 1 square. See, easy or difficult? Blank. See, you know how to find this? You know how to find this? It means you know theta. If you know theta, this right angle triangle share the same angles. They are basically similar triangles. This is nothing but 7 sine theta. And twice that is the whole thing. Twice of AP sine theta. Twice of root S1 sine theta. What is theta? Theta nikal do. Clear? So A and B part is done. मिड पॉइंट ऑफ ए बी, मिड पॉइंट ऑफ ए बी, एक तो मुझे ये इक्वेशन पता है, ये इक्वेशन लिख लो, इंटरसेक्शन पॉइंट, एक तो ये हो गया। दूसरा और मेथड कोई आसान है, विल यूज सेक्शन फॉर्मूला। हाउ? दिस इज थीटा, this is 90 minus theta, this is theta, so this length is going to be arc sin theta, है ना, and this length is going to be root s1 cos theta। कुछ गड़बड़ हुआ क्या? नहीं, ठीक है, r sin theta and root, so what is the ratio? m is to n, r tan theta by root s1 say, let's say I'm going to call this point as m, so m is basically dividing OP in the ratio r tan theta root s1, right? So I can find that. Two methods, one is write the equations and find the point of intersection, or use direct section formula using the geometry of the graph, diagram. Okay, so till C no issue. We have to find angle APB, 2 theta. We've already found it. C done, D done. We've already found tan theta is 1 by 7. So we just have to find theta is tan inverse 1 by 7. So 2 theta is twice of tan inverse 1 by 7. Clear? ABCD done? E part. Area of triangle APB. So this is my base. I know this length. I know this length. So I can find area. So E is done. E is done. Any issue with E? No? Anyone? Not with me? Lost the track? Blank? No. F, area of kite ACBP. अच्छा मैंने इसे C था ना ये, ACBP. Okay, this is the kite. So I know the area of this triangle. I have to find the area of this triangle. What is the area of this triangle? The same this into half r sin theta, or basically this into this. Of course half, है ना, kite है, rhombus is also kind of kite. ठीक है, F is done. Now come the difficult parts. Centroid, G ही देखो G है, तो G का क्या होगा? G APB. I see this triangle APB. अब मैं AB निकालूं, फिर क्या करूं? What should I do? I have already found this point. I know this is my median. 2:1. I can find G. Right? Any problem? No. H. Centroid of triangle ACB. Same story. This is the median. I know this. I know this. I can find 2:1. Right? Any issue? No. I point. Circumcenter of triangle APB. APB. हाँ, क्या होगा? ये जो चार बंदे हैं, चार वर्टिसेस ए सी बी पी, कोई स्पेशल है क्या? ये कोऑर्डिनेटर कोई स्पेशल कोऑर्डिनेटर है क्या? कोई स्पेशल कोऑर्डिनेटर है क्या ये? गौर से देखो, इज इट अ साइक्लिक कोऑर्डिनेटर? इट्स अ साइक्लिक कोऑर्डिनेटर, है ना? क्यों? This is 90 degree, this is 90 degree. Of course, opposite sides sum is. It means what is concyclic quadrilateral? Whenever we see any quadrilateral whose opposite sides, opposite angles are supplementary to each other. That is, they make 180 degree, which means that they are being circumscribed by one circle, which I can say this is one circle, right? Okay. So what will be the circle? इस लाइन का मिड पॉइंट, इस लाइन का मिड पॉइंट would be my circumcenter. Good. You have found circumcenter, you have found circumcentroid. What will be the circumcenter of this triangle? Same. What will be the circumcenter of this triangle? Same. You have already found the centroid. You've already found the centroid. So how to find the orthocenter? Euler's line, 2:1. You will never forget 2:1. You will be able to draw every time. You will be able to prove it every time. No? We just discussed the proof. So you have to get back home and see it, watch it closely. Okay. Clear? No issue with it? So we are done with this huge question, right? है ना? So kite जब भी बनेगा, ध्यान रखना. Next question. Okay. I have this again, a sort of kite thing, right? X square plus y square is 16. The equation is given of the circle, and equation of AB is also given. Find C. How to go for it? Huh? What is C? C is my H comma K. So my chord of contact is HX 16, which I can write as so my H by 8 is 3 and K by 8 is 5. So H is 25 and K is 24. Excellent. And K is 40. Okay. Now B part. Find the locus of circumcenter of triangle PQR if QR is chord of contact and P lies on the curve XY is equal to 4. We can handle it, right? Yesterday we did lot of calculus questions, locus questions. So you see, this is XY is equal to 4, P is lying on this, and this is my Q, this is my R, and this is my PQR, OR. I know circumcenter will lie in the middle of this, and I'm going to call that thing as H comma K. My center is OO. So this point is going to be 2H comma 2K. P is 2H comma. I have to find the locus of M. The midpoint. Midpoint ka locus nikalna hai na? Okay. So I know this 2H comma 2K is lying on this curve. So 4HK is equal to 4. So HK is equal to. देखो बहुत सारे लोग एक्स वाई इक्वल टू 4 लेके आ जाते हैं आंसर इसका। क्या गलती करते हैं? वो बेसिकली इसका लोकस निकाल देते हैं। वो तो दिया ही हुआ है, निकालना क्या है ना, वो तो दिया हुआ है। पी को एच कॉमा के लेने की बहुत आदत होती है, सो पी को एच कॉमा के लिख के के इक्वल टू 4 आ गया। ठीक है, क्लियर। सो बेसिकली ये जो पाथ फॉलो करेगा एग्जैक्टली ये भी वही पाथ फॉलो करेगा, लेकिन ये 4 टाइम्स होगा, ये 1 टाइम्स होगा, है ना। क्लियर और नॉट क्लियर? So that was 37th. Okay, 38. Find the locus of P if chord of contact of P with respect to this circle touches another circle. So it is something like इसके रिस्पेक्ट में मुझे लिखना है P. So let's say this is Y and it is touching this one. Both are concentric, right? है ना? If I call this point as H comma K, what is this equation going to be? This line should touch, है ना? This line should touch the circle. It means इसके center से distance. So what is the thing? That is 16 mod 16 upon under root h square plus k square, right? Is equal to 1. So x square plus y square is equal to 16 square. A very larger circle, है ना? ये 1 है, ये 4 है और ये 16 है. 3 concentric circles, right? Understood? So you are seeing the concepts of circles. It is going to help you when if you select mechanical engineering. So when you will understanding the mechanism of gears and all. So these circles thing are going to help you a lot. Okay. Should we go to next question, 39? Today we didn't go fast, no? Yesterday did we go or we were not adjusted to the speed? I think we are on the same speed, only that we have adjusted to this speed. First we learn how to walk, then we learn how to crawl, then we learn how to walk, stand, and then we learn how to walk, and then how to run. Okay, so this is 39. Find the locus of P if chord of contact of P with respect to this circle x. This is not circle, this is ellipse. X square plus 2y square minus 16 t is equal to 0 is going to help me in all the 2-degree curves, right? Touches, same story, exactly the same question, but instead of the outer circle he has given the ellipse. So I'm going to write t. P को मैं क्या मानूंगा? H comma k. So my t is going to be hx plus 2ky minus 16 is equal to 0. Any issue with it? Okay. Mod 16 upon h square plus 4k square is equal to 1. So x square, ये बिल्कुल वैसा ही एलिप्स बनेगा जैसे सर्कल था. 4, 16 ये एलिप्स बनेगा जिसका मेजर, get the idea? So 39 is easy. Okay. Show that if a chord of contact is drawn from any variable point on x plus y is equal to 4 to x square plus y square is equal to 1, then the chords of contacts are all concurrent. Concurrent. What is concurrent? More than two lines are passing through one common point. Yes, a centroid are the concurrence point of concurrency for all the medians. So I have this circle, okay, and I have this random line x plus y is equal to 4. याद समझ में आ रहा है ये क्या बन रहा है? क्या बन रहा है ये? Polar. और क्या कह रहा है कि if I take any random point here, I'll call this point as t comma 4 minus t, parametric form. Any issue with it? This is my parametric form. I'm going to now write the chord of contact. ये chord of contact बना, ऐसे ही कोई और भी बनाओगे तो इसका भी chord of contact बनेगा. ये कह रहा है कि जितना भी तुम बनाओगे यहां से, it will always be concurrent to this point. तो ये क्या बन गया? यही प्रूफ करना है. ठीक है, अभी देखो कैसे करेंगे. मैं बताता हूं इसका आंसर. जो पोल आएगा वो क्या होगा. इक्वेशन ऑफ सर्कल क्या है? एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल टू 1. है ना? Which means 1 by 4 is 1. So x1 is 1 by 4. The point of concurrency 1 by 4 comma 1 by 4 आएगा. लेकिन we are not going to say this way. We are going to first prove it and then we are going to make it a result. Okay? Let's see how. This t comma 4 minus t, I have already taken t as a variable. So I'm going to write the chord of contact. What is the equation of circle? Is equal to 1. So the tx plus 4 minus ty is equal to 1. This is the chord of contact, variable chord of contact. T is varying. I'm going to solve this question. Tx plus 4y minus ty minus 1 is equal to 0, which means 4y minus 1 plus t into x minus y is equal to 0. Line 1 plus t into line 2. What is this we call it? Straight line chapter. Family of lines. What is family of lines? 2 or 3 lines passing through one common point. Concurrency. So t is variable. It defines that, okay, this is a family of lines. तो इसकी point of concurrency क्या होगी? Intersection of these two lines. इसका ये line क्या है? Y is equal to 1 by 4 और x minus y is equal to 0. So x is equal to y is equal to 1 by 4. So 1 by 4 comma, पहले guess कर लिया था ना? Getting the idea? So you understood pole. If pole is inside, the polar is outside. T is equal to 0. If pole is on the thing, the polar is the tangent, and that is T is equal to 0. If pole is outside, the polar is inside, and that is chord of contact. And you see the movements, right? ऐसे आता है, and then they cross. So this was all, I brought 40 questions and we have still 20 minutes. So we were actually very fast. Yesterday we were not fast. We were actually lagging. So now it's all about conditioning. Last class में तुम कंडीशन नहीं थे फास्ट क्लास के लिए, अब तुम कंडीशनड हो चुके हो. सो प्रोबेबली नेक्स्ट क्लास में हम लोग और फास्ट भागेंगे. ओके, नाउ few things which we left to prove. We thought that we'll be proving in the last. Why not prove it now instead of starting fresh? So first thing I wanted you to prove is in center ka coordinate. You already have proved the centroid thing. I don't have to go into that. So I'm going to find the in center. First of all, I must know what is in center. Intersecting points of internal angle bisectors, right? So first I'm going to draw this triangle as A, B, C. I'm going to call this as x1, comma. I'm going to call this as A, this as B, this as C. Any issue? No. This is my angle bisector. I'm going to call this as D. Can you tell me what is BD by DC? What is the ratio of BD by DC? BD by DC. Class 9th angle bisector theorem. BD by DC will be the ratio of C is to B. C is to B. Adjacent side से रेशियो लेता है यहाँ पे. भूल गए? यहीं से तो सेक्शन फॉर्मूला आता है इंटरनल बाइसेक्टर का और एक्सटर्नल बाइसेक्टर का. When I say C is dividing my line AB in internally, it means that angle bisector from a triangle is coming and dividing the ratio m is to n whose adjacent sides are m and n. And externally, मतलब कभी सुना है कि externally divide करा किसी को? But it is actually the external bisector. It's the angle which is giving the name. It's more of a this story. This is my angle bisector. Let's say ABC. I'm going to call this as M, this as N. This is angle bisector, internal angle bisector. And this is external bisector. This is, let's say, D. This is E. D is dividing BC internally in the ratio M is to N. And E is dividing externally in the ratio M is to N. But why we take minus? Because BD by DC तो एक ही direction में है ना. BE and then EC. We have changed the direction. We went B and then we went. This one will be M times and this one will be N times. And that will be minus M is to N because direction is being changed. We'll see the sign distance. We'll consider this distance as a sign distance. Okay? Any issue with it? From where now it won't. Obviously, when I was a kid, when I was doing section formula thing, I was like surprised to see how D is actually dividing AB because it's lying outside. It's not even touching them. How it is dividing them? But it appears that it's a story of 4 points. But it's not a story of points. It's a story of angle bisectors. Okay? Now, coming to the basic than this, angle bisector theorem. How can I say that this is dividing in the ratio M is to N? Prophet Gabriel came and said that, okay, it is the answer and you should remember that. Is it the way we do with mathematics? Then how do we go for it? We prove it. So how did we prove it in class 9? Yes, we did. Go turn up the page, turn on the pages of class 9th NCRT or 10th, maybe 9th or 10th, I don't know. So if you see, do you want to see the proof? Okay. A quick proof. I'm not going into detail. A very fast proof. This is my angle bisector. I'm going to extend it. I'm going to draw a parallel thing. AB is parallel to CE. Okay. Okay. This angle is going to be this angle. This angle is going to be equal to. Okay. And this angle is going to be equal to this angle. Okay. Now tell me, are these two angles equal? This is A by 2, this is A by 2, this is A by 2, right? Are they equal? So they are isosceles triangle. If I call this M, this is N, so this is also N. So this ratio, these two are similar triangles. So this upon this will be equal to this upon this. M is to N, QED. Done? So we can come to this. So always remember that angle bisector divides the opposite sides in the ratio of the adjacent sides. So I'm going to say This is A. I'm going to say D coordinate is nothing but Cx3 plus Bx2 by B plus C, comma, the counter Y. I'm not going to write Y. Counter Y is, the same thing. Now, this is my in-center. Can you tell me at what ratio the in-center divides this bisector? B plus C is to A. It divides in the ratio. You also don't know the proof. Should I show you? No, I shouldn't show the proof. Show. Okay. मुझे लगा नहीं सर मत बताइए. So I'm going to prove that my AI is actually dividing, my AD is divided by in center in the ratio B plus C is to A. तो पहले मैं क्या करूंगा, एक ट्रायंगल बना लूंगा. ठीक है, मैं यहां से A बनाया, यहां से B बनाया. Okay, now this is I, this is D, right? I'm going to call this as A, B and C, right? I know BD is to DC is C is to B, so I know D. है ना? कोई problem इसमें? नहीं. So what is the length of BD? This is C is to B part na, so C by B plus C into A. This is the length of BD. Any issue with this? No. Concentrate in this triangle. Can you see this triangle? Is it the angle bisector? I is the point. तो ये किस रेशो में डिवाइड करेगा इसको? This upon this. So AI by ID is equal to BA by BD. What is BA? C, and CA B plus C. तो क्या हो गया? QED है. तो तुम्हें पता चल गया कि B plus C is to A. और याद करना भी आसान था. ये B plus C है, मुझे ये अच्छा नहीं लग रहा. It has to be go out. So यही बचा सकता है ना मुझे. और ये x1 के साथ भी मुझे लाना है. तो आंसर क्या हो गया? काउंटर पार्ट सेम y. मुझे बोलो यार जब मैं गलत लिख दूं. ठीक है, क्लियर? एनी प्रॉब्लम? है ना? गुड. सो we still have 10 minutes. Can we prove orthocenter? Good. अच्छा, इन सेंटर कर दिया, सेंट्रोइड कर दिया, ऑर्थोसेंटर कर देंगे तो सर्कमसेंटर करने की जरूरत है क्या? We know Euler's line. We can find it. Now if you see ठीक है, so you see this? Any issue? No. This is my thing and this is my H, right? This is B, this is C, so this thing is going to be C cos B and this thing is going to be B cos C, so ratio is going to be C cos B by B cos C. I know sine rule, so C is going to be 2R sine C cos B upon 2R sin B. Okay, so I can say D is nothing but x3 tan C plus x2 tan A by any issue? Same counterpart. Why? Clear? Not clear? This is tan C by tan B. So this is tan C, this is tan B. So tan C is going to go with x3 and tan B is going to go with x2. Clear? Now the question is AH by HD. Very good. Tan B, tan C is to how? Prove kare. Yes or no? Should we prove it? Why? Still we have 5 minutes, we can prove it. Okay, till here everything's fine. The moment we'll prove, we know the result. So I'm just rubbing it off, I'm just going to prove it. Prove हो जाएगा ना, वो होते ही prove हो जाएगा. Obviously, the final answer would be H is equal to x1 tan A plus x2 tan B plus x3 sigma tan A. है ना? Similarly, Y की story. ठीक है? Now, the missing bridge is this statement. And otherwise we have built this bridge, this one is left. So we just have to put this one here. So वो करते हैं, करें? These all are class 9, 10 thing. Come on. Is it difficult? No. So this is going to be my A. Right? Huh? Yeah. Okay. So this is equal to this. And obviously, clear? Huh? Now, if this is C, this will be pi minus C. This will be C. AE is nothing but AE turns out to be C cos A. A होगा ना? C cos A. And AH will turn out to be AH. This is your right triangle. So this is your C. So sine C is going to be AE by AH. So AH is going to be C cos A by sine C. है ना? Now what is HD? This is C, so this is also C. So this is HD. So this is going to be C sine C cos B. This is going to be C cos B. So this is your right triangle. C cos B. BD by DH is equal to tan C. है ना? यही होगा ना? So DH is BD by tan C. And what is BD? C cos B by tan C. So AH by HD. C cos A sin C upon C cos B tan C. Okay, so I got cos A sin C कट जाएगा, cos A sin C cos C sin C cos B, right? कुछ कैलकुलेशन मिस्टेक तो नहीं हुआ है? So I have cos A by cos C cos B, right? Dead end या कुछ कर सकते हैं अभी हम? A से रब कर दूं, इसे रब कर दूं, यही रेशो प्रूफ करना है ना हमें। cos A को क्या मैं लिख सकता हूं, cos पाई माइनस which will turn out to be minus cos ठीक है, which will finally turn out to be minus sin B into upon which I can write tan B tan C minus 1, which I can write 1 minus tan B tan C, right? Which where we see this expression in tan B plus C form. What is tan B plus C? So I can write tan B, I can write tan B plus tan C upon tan B plus C. I can write it. So I'm going to write minus tan B plus tan C upon tan B plus, which I can write finally. Still we have 2 minutes. Huh? Anything more? The sign thing, na? Why the same side has the same sign? It's a long theory. We'll discuss maybe जब भी हमें लास्ट में 10-15 मिनट मिलेगा। कल हम लोग चाहेंगे 1 घंटा और, मतलब नेक्स्ट क्लास में 1 घंटा मिल जाए बच्चे, so that we can take all the backlog. Okay? ठीक है? Any problem? No? So should we call it a day? Okay, bye bye.